testing's realm, where challenges reside, robot framework emerged, a beacon by our side, empowering with precision, its syntax guides the way, logging every sway. Robot framework, you light on our fire, with versatile syntax, taking us higher. Innovation blooms as we automate each day. Robot framework leads, showing the way. Amidst the code where complexities entwine, robot framework shines, design so fine. With libraries to hand, solutions we define. Test the line. Robot framework, you fuel our drive. With libraries abundant, helping us thrive. Innovation blooms as we navigate this maze. Robot framework empowers in so many ways. Through testings, trials, boldly we tread. With robot framework, no challenge fills with dread. From APIs to UI, test widespread, our path ahead. Robot framework, you make us excel. With testing prowess, breaking every spell. Innovation bloom, with every test we convey. Robot framework empowers day by day. In testing's realm, where challenges reside, robot framework emerged, a beacon by our side, empowering with precision, its syntax guides the way, logging every sway. Robot framework, you light on our fire, with versatile syntax, taking us higher. Innovation blooms as we automate each day. Robot framework leads, showing the way.
Hello everyone, my name is David Fogl and I'm here to talk about how we can integrate.
Robot framework shines, design so fine. With libraries to hand, solutions we define. Test the line. Robot framework, you fuel our drive. With libraries abundant, helping us thrive. Innovation blooms as we navigate this maze. Robot framework empowers in so many ways. Through testings, trials, boldly we tread. With robot framework, no challenge fills with dread. From APIs to UI, test widespread, our path ahead. Robot framework, you make us excel. With testing prowess, breaking every spell. Innovation bloom, with every test we convey. Robot framework empowers day by day. In testing's realm, where challenges reside, robot framework emerged, a beacon by our side, empowering with precision, its syntax guides the way, logging every sway. Robot framework, you light on our fire, with versatile syntax, taking us higher. Innovation blooms as we automate each day. Robot framework leads, showing the way. Amidst the code where complexities entwine, Robot framework shines, design so fine. With libraries to hand, solutions we define. Test the line. Robot framework, you fuel our drive. With libraries abundant, helping us thrive. Innovation blooms as we navigate this maze. Robot framework empowers in so many ways. Through testings, trials, boldly we tread. With robot framework, no challenge fills with dread. From APIs to UI, test widespread. Our path ahead. Robot framework, you make us excel. With testing prowess, breaking every spell. Innovation bloom with every test we convey. Robot framework empowers day by day. In testing's realm, where challenges reside, robot framework emerged, a beacon by our side, empowering with precision, its syntax guides the way, logging every sway. Robot framework, you light on our fire, with versatile syntax, taking us higher. Innovation blooms as we automate each day. Robot framework leads, showing the way. Amidst the code where complexities entwine, robot framework shines, design so fine. With libraries to hand, solutions we define. Test the line.
Hi, witamy serdecznie. Welcome everyone to the third Wrobocon, the first Polish robot framework conference that is open to participants all over the world. I'm Chris.
Good day to all of you joining us from the various corners of the globe. We're thrilled to have such an international audience. I'm Guido, and together with Chris, we will be your hosts today.
So before we begin, we'd like to extend a special welcome to our attendees, to those who are the first time joining Wrobocon. Witamy. We are excited to have you here, and we hope that this conference opens up new horizons in your testing journey.
And for our second time attendees, welcome back. Nice to see you again, and we're glad you found value in our previous conferences and chose to return. And we've got we've got even more for you in store this year.
Yeah, and to our loyal attendees, we have you that are with us third time, so they are every year with us. Can say welcome home, witamy w domu. Your continued support and enthusiasm are what makes this community so special.
And this year's Wrobocon promises to be our best yet. With two main teams which are shaping the future of testing. One of them AI in testing and collaboration in open source projects.
Yeah, we are excited to explore how artificial intelligence is revolutionizing the testing landscape and discuss ways we can work together more effective in open source communities. But before we start, I would like to go over some housekeeping items to ensure that you get the most out of our virtual platform. So the first is a Q&A function. You should see a form on the left side from the screen when you see the broadcast. So you can paste your question there and submit it. After the submission, the window would get minimalized, but it's still there. It should be on the bottom left corner of your screen. So if you want to add another question, just open it up and submit the next one. To chat with someone, it's just easy. Just get up to that person and your mic and camera will open and you can talk with that person. We have also speakers corners. There are 2 speakers corners. They are marked as talk to the presenter. This area is intended to get direct contact to the speakers. So in the breaks between the sessions, the speakers will be available for you there, so you can ask direct questions. In the next building, there's booths with our sponsors, so you can go there and check out the links to the pages of the sponsors. If you get lost, there are people from Wrobocon team that can help you. They are marked with the Wrobocon icon that is following them everywhere. So if you need any assistance, just get up to them and explore our QA world. There are videos from previous editions of Wrobocon. There is a form to sign up to Wrobocon 2025 and much more.
And now let's take a quick look at today's agenda. So at 9:15, David Fogl kicks off today with implementing Robot Framework AI library. So uncovering the potential of AI with Robot Framework. At 9:45, Kailash presents the automating Playwright Tests with AI, so guiding you on how to harness AI for intelligent Playwright test automation. At 10:55, Marcel Veselka shares this insight into Autopilot, your robot framework testing, revealing techniques for maximizing automation in your robot framework test. At 11:40, we'll explore the innovative RFSwarm project with presentations from Dave Amies and Arkadiusz, and I'm very bad at those last names, so I'll skip that one. And they will shed a light on support provided by the NICE project. Then we'll have some lunch. And after the lunch break, Tariq King presents automation quality, a vision beyond AI testing, challenging us to think beyond the current AI testing paradigms. At 2, Artur will guide you through the construction of scalable and resilient test automation architectures in his presentation, Scalable Test Automation Frameworks. At 15:20, Dirk will present supporting agile development with generated test cases and demonstrate how to leverage test case generation for increased agility. And last but not least, at 4:10, Joshua will illuminate the intersection of Web3 technologies and robot framework testing in his presentation, Web3 cross-chain tools and testing using robot framework.
Yeah, and remember, all sessions will be recorded and made available to you after the conference. So if you miss anything, don't worry, you will have the opportunity to catch that up.
Yeah. So we are looking forward to an inspirational and knowledge-packed day that bridges the test community with the international robot framework scene.
So without further ado, let's get this third Wrobocon underway.
Yes, enjoy the conference, everyone.
And we start right away with our first guest live with us from Helsinki. It's Mika Solmala, the Executive Director of Robot Framework Foundation. Hi, Mika.
Hi, Chris. Hi, Guido. Great to be here again. I must say I'm really glad that you are doing this third time around again. I was in the first one and as a speaker, and then joined the second one through the videos, and now here again. So great job overall, nice project, and the whole team there. So really good job, Wrobocon team. Awesome.
Cool, Mika. Can you tell us something about the Robot Framework Foundation and why it exists?
Sure. So Robot Framework Foundation is a non-profit organization, and also purpose is to support the development of robot framework and also the ecosystem and the community around it. So that is our mission. So we are there really for robot framework. Maybe as a side note, so basically all the robot framework fans, you should go to your kind of company representatives and tell them like, hey, there is a Robot Framework Foundation and we have an awesome tool in use for free. Maybe we want to give a little bit back and contribute to the community and the tool and join Robot Framework Foundation. So that's something that I hope you consider.
Mm-hmm. And while becoming a member of the foundation, what comes with that?
Yeah, I mean, of course, we listen to the community very closely always, but as a foundation member, there's a bit more direct connection to the development team, for example. And also we always have some benefits for the members, such as discounted and free Wrobocon tickets. So Wrobocon is our annual conference. If you have not heard about it, it's going to happen in February in Helsinki and March online. So welcome everybody. I think there will be also a small departing gift for those kind of who have not yet purchased a ticket. So there will be a small discount given later point. So really hope you join this conference and see you all in Helsinki in February. But maybe one thing about the member benefits as well is that it's really about coming together, thinking what is the best way for Robot Framework and the whole community to move forward always together as a democracy. So we are one vote, one member company. So it's not about buying in more influence with money, but more about how can we together make this great tool and community even better.
Mm-hmm. And yeah, one of the main themes of our this year's conference is collaborating in open source projects. And so I have a question regarding that. How can one get involved and contribute to Robot Framework?
Great question, Chris. So I think you both know that quite well, but both good contributors. Thank you for that. And I'm sure there are many there in the audience. But one of the biggest things to note about is you can, of course, always contribute to Robot Framework itself through identifying bugs or helping out when we have a release candidate to check it out and not just make pull requests to the project. But of course, in the ecosystem, there's a vast amount of libraries and tools available. Some of them also need help identifying bugs, developing new features, and these kind of things. Also, there might be some libraries that are being underdeveloped. So maybe you want to pick up one of those libraries and start putting it up to the speed, so to say. So those are definitely things that we hope that people will do. And I encourage you to kind of look around and see where you can help. One important thing is also that although it's really good tool, Robot Framework, and also libraries and ecosystem tools that are out there, but it's really more about the people and the community. So I think people can do a lot more than just the technical things. For example, helping each other in our forum and in our Slack. So do join those, just go to robotframework.org and community. You'll find the links there. And it's also about being there for the community members when they have issues. So not just asking your questions, but supporting others. So that's the vital part, giving back. Also, we are plenty. So in a way, it's all about what is your thing. Maybe you want to go to conferences to talk about robot framework, give a workshop in some conference. Maybe you want to write a blog post or make a podcast about robot framework. What's your thing about it? Why you think it's so cool? Maybe you want to be an administrator in one of our Slack channels and so forth. So there are multiple of things that one can do. So it's not related only to technical things, but also about this wider aspect of how can we make this community ecosystem and robot framework itself better.
Yeah, that's a good point, because for me, for example, when I first thought about contributing, I thought that you have to do only technical stuff, but there's also plenty other things to do. You don't have to be a developer expert to contribute.
Yeah, for example, we are both working with our upcoming certificate, so that's super important. We work mainly volunteers are doing. So just as a good kind of a point, that there are definitely things that we do need and do need support with other than just code.
Okay, so thank you, Mika, for joining us live. You stick around in Work Adventure.
Definitely.
If anybody has questions, they can approach you directly. Am I right?
Definitely, yeah. Feel free to reach out and let's enjoy the day. Thanks for having me, Chris and Guido.
Yeah, thanks.
Thank you, Mika. And then we will be starting with our first presentation from David Fogl, and that is about implementing Robot Framework AI library. And we will be watching that video, and after the video, there will be a Q&A. So get your questions in, and we'll talk to you about it. Have fun.
Hello, everyone. My name is David Fogl, and I'm here to talk about how we can integrate AI with Robot Framework using a new library called Robot Framework AI. I am representing Continuero and Mingle Minds. Also, I'm an active Robot Framework Foundation board member, and today I will show you how AI can make test automation smarter, faster, and more flexible. Let's start by looking at how test automation has changed over time. In the past, most testing was done manually, which took a lot of time and was often prone to mistakes. Tools like Robot Framework make testing much faster and more reliable by automating repetitive test tasks. Now, we are entering a new phase where AI can make automation even smarter by helping us make decisions and create more realistic test data. This sets the stage for integrating AI into our current test automation tools. But we need to find the right tools and the right ways to integrate them. Traditional testing tools often rely on static test data, which isn't always enough to catch complex bugs. Sometimes we can just miss some things because we are using the same data sets over and over and over. AI can generate more realistic and varied test data, which helps simulate real-world user behavior. AI can also help us adjust tests on the fly based on the results it gets, making testing even more dynamic. By using AI, we can make tests more intelligent, helping us find issues that we might miss in the normal automation. It also reduces unnecessary tests and improves overall test coverage. And this is where our library can really shine. The goal of the Robot Framework AI library is to combine AI's data generation power with the structured approach of Robot Framework. To start with, this library makes it easier to create realistic test data, interact with AI during the test cases and test runs, and keep everything within the Robot Framework environment. Overall, the goal is to simplify the process of making tests and make them smarter and more adaptive and even more dynamic. So, what is Robot Framework AI? It's a library that connects Robot Framework with the AI models, such as OpenAI's GPT. But not only the GPT, but you can connect it to basically any AI that has some API. This allows testers to use AI directly in their test scripts, for example, to generate test data or get intelligent feedback during the test cases. So something fails and you can send it to AI and immediately find how to fix it. With this integration, test automation becomes more than just running the scripts. It becomes an intelligent process that can adapt during the testing itself. Let's now look at the main features of this library. The robot framework AI has three main components: the test data generator, chatbot module, and assistant module. The test data generator helps to create real-world test data. The chatbot, how the name suggests, allows you to have conversation with the AI before or during the test cases. And the assistant module takes this further by remembering the context and supporting file attachments for even more complex interactions. So basically, you can chat with your own robot framework code and with your own project. So the test data generator can create realistic test data, such as addresses, user profiles, phone numbers, basically anything you imagine. You can customize the data to fit your tests, for example, by choosing the country or specifying how many records you need. You can also specify what kind of output you would like to have. Is it a JSON? Is that a dictionary? Is it a list? It's your call. For instance, you can generate 3 addresses from Poland using this following command, and that's generate test data. We specify the model, OpenAI. We specify what we want. We want addresses, and we specify the country, Poland. And we get 3 nice real-life addresses from Poland, 2 from Warsaw, and 1 from Lodz. This creates and makes it overall really easy to generate any dynamic data set that you might need. And you don't need to store these files in. You can just search, you can just generate them on the fly. The chatbot module allows you and your test to communicate with AI during the execution. So it can be very useful for testing chatbots or applications that require some dynamic responses. You can simulate a conversation with an AI, for example, to generate different types of user inputs or responses. This brings more intelligence into your tests, making them more interactive, adapting different scenarios. I selected a little bit different use case. For example, here I want to create a list of 10 existing Poland postal codes from different cities in JSON format without any other text or markups. So you can see I'm not using it for like a chatbot. I'm using it as more extended data generator even here. And I get a list of the cities and the postal codes directly in the JSON format that I can use with my tests. And the assistant module extends on the chatbot by keeping track of conversation history and allowing file attachments. For example, you could ask the AI to analyze a piece of code or log file, which it can reference during the test. This is especially useful when you need more context-aware interactions in complex tests. In my example, I'm creating an assistant. I'm again using OpenAI. We are selecting a module, which is 4.0/mini. It's called Test Assistant. The instructions are Robot Framework Automation Expert and some other parameters. And what kind of message I'm sending? Well, I specify all my files within RF/AI directory, which is 3 files. It's all those code you saw. I'm again using OpenAI model. And the message is describe my robot framework tests. So what is the outcome? It's a structured file in MD format where it says your robot framework tests primarily focus on automation tasks using library designed for interaction with AI model. Here's a summary of the key components. And then it goes and lists all the files and all the functions that I'm using. This is again just a simple example, but it's really powerful whenever you need to work with data sets on the fly. It can be documents, it can be any structured text. It doesn't do well with images yet, but everything else you can chime in. It can be even CSV files. And this is really powerful whenever you need some more context from the chatbot itself. Let's look at how you can use these AI tools in real-world testing environments. We'll check examples in browser testing, API testing, SQL testing, and an interaction using robot framework listeners. Also, we can then talk about how to do some self-healing. So AI can generate realistic user inputs for web forms or simulate different kinds of user interactions with a web page. AI can also be used to compare visual elements, for example, making sure a website looks the same after the updates. And also, AI can detect errors in the UI that traditional tests might miss, such as layout shifts or hidden elements. We all know that testing browsers is a really hard thing. You are only validating the stuff that you write into the automation test. So if you are searching for a button, you're probably using some XPath or CSS selectors to find that one button. But that doesn't mean that the area around the button has changed, or that there is a problem with CSS and the button doesn't look like it should. And this is somewhere where the AI can really shine. Also, we can use AI together with listeners, and we can use the HTML code inside of our testing. So basically, we can use the HTML code of the page at a certain step of our test. We can use it as a context, and then we can ask questions to that HTML page. And it can be, for example, if a test case fails or the keyword fails that was searching for some XPath. So, hey AI, I didn't find this particular XPath. Can you give me suggestions? What has changed? Why cannot I find it? And we can use this data and put it into the log, for example, log warning or some info, so that we can find it when we are debugging the test case. So this is just one of the examples. Also, we can use AI with the APIs. For example, we can create a different kind of payloads for edge cases that we wouldn't predict. Instead of using fixed checks, AI can validate API responses based on the business rules and logic. For example, if our API is going by some standard like OpenAI or OpenAPI, or for example, we are using Swagger documentation, we can put it all into the context with the AI. And then the AI can help us drive the test cases, create the request, and validate the responses. And I can also detect unexpected patterns in the API responses, which could point out to potential bugs or security risks. So again, if we provide the AI with a good context, we can utilize it really well, even for API testing. And what I really love is using the AI with SQL. AI can write complex SQL queries to test your database, checking things like relationship between tables or, for example, performance issues if it's just taking too long. It can also verify that the data in your database is consistent and follow the right rules. AI can even predict performance problems by analyzing how your SQL queries are running and suggest some improvements, for example, how to make your queries more efficient. But what I really love is that I can just provide the AI with the output from the database. I can tell it my business logic. So, for example, I'm working with financial data. I have a huge table with 10,000 rows, with, for example, 20 columns, and I need to spot the problems. And if I provide the right context to the AI, I can ask it questions like, is there anything within this table, within this data, that doesn't fit? this and this particular business use case, and it will search through the data. The analytical capabilities of AI are really strong. So really excited about using AI for SQL testing. And how we can use this robot framework AI library in our testing scenarios. So one of the strengths of the robot framework AI library is how easily it can be integrated into our existing test suites. So you don't need to start from scratch. You can add AI model to enhance your current test cases. For example, you can use AI to replace or enhance your test data generation process, or even to add intelligence to part of your test script without changing everything else. In some cases, you may need to be more specific for the AI models. For example, if you are testing a banking application, you might want an AI model trained specifically on the financial data. Or you are testing a particular application, and for example, you have a really good documentation. You can take this documentation from your project, the design manuals, the operation manuals, and put it all into an assistant, and then work with this assistant. The assistant will know what your application does. So that's really cool. Also, the library allows you to use custom AI models for domain-specific needs. So giving you the more control over how AI is applied in your test cases. So again, if you have your own company AI models out there, you can hook it in. We built the library in a way that you can easily implement the API calls to your own AI and use it almost without any other changes. So definitely, there are some challenges when working with AI models that you need to consider. First, there is some cost. So if you are not using your own company AI models and you are using OpenAI or you are using Gemini, there are definitely some costs. And the more you communicate with the AI, the more data you create, it will cost you when using it over API. So be careful about that. Second, the response time is important. We want our tests to run as fast as possible. Some AI models might take longer to provide the right answers. Or even the OpenAI, when you are running it in the afternoon, when there is the US people are working with that, it will be slow. So if you want to run your test cases, run them in the morning if you are using OpenAI, because that's really fast. But in the afternoon, you might hit some roadblocks. And lastly, the output from AI models can sometimes be unpredictable. It can create the data in a wrong format. It can use some ND markup that you didn't want to. So you really need to explain and control the questions. So you really need to do some prompt engineering. But it's not too hard to learn. And what I really love are robot framework listeners. And I'm talking about it for 2 years now when I learned about them, and I'm trying to use them almost everywhere now. So robot framework listeners allows us to capture events during the test execution, such as when a test fails or passes, when keyword fails or passes. So we can hook to these events like a keyword start, keyword end, test start, test end. And we can hook the AI into the process and communicate with the AI during our whenever we are running these test cases. So, for example, if a test is failing, we can look onto this fail. For example, it's failing for a browser test, like I mentioned for the XPath. We can take the HTML code of the page, send it to the AI with the question why this XPath is failing, and we can use the answer in our logs to extend our logging capabilities, or for example, to hook it up even to Jira and create a bug report or a maintenance task for our test with even some data on top. So if you want to learn more about listeners, definitely check out YouTube. Pekka Clark created a really great talk on Wrobocon 2023, and there are more videos out of that. So really check the listeners API. So now looking at we plan to develop more templates for real-world use cases and support even more AI models. We also try to work with the community to really get the ideas. So how we want to use AI. What are the drawbacks? Is there something blocking you from using AI? Or do you have some specific use case that you would like to cover? So our robot framework library is on Marketplace or Market Square. So you can hop in. We already have 15 open issues, some of with ideas what we need to implement, some of the bugs as we are starting to use it, and everybody uses it differently. So we really want to make this library mean something. So if you have an idea, maybe you just don't want to use library yet, but you have some idea that could be in, definitely put it into the issues and get in touch with us. We will be really glad for some really good discussions about AI and robot framework. So what we talk about today. We talked about integrating AI into test automation to make them smarter, faster, and more adaptable to real-world scenarios and what's happening with our applications and environments. This integration can improve test coverage, make tests more reliable, and it can reduce the manual effort needed to write tests and maintain tests, because it can give us that information how we can fix this test immediately. And definitely encourage you to try the Robot Framework AI library and explore how AI can help you to improve your testing processes and how it can make your life easier. So definitely have a look on our GitHub. If you find it useful, give us a star. If you want to try it and something doesn't work, reach out to us and we will try to help you anywhere we can. And that's practically it. Thank you for your attention. And I'm really happy to take the questions now on the live Q&A.
Hey, David, welcome. Thank you for this great talk about the Robot Framework AI library. Let's see if we already have some questions. And if you have any questions from the audience, please put them in the form, because then we can ask them to David. First question. Your presentation focuses on using specific AI model with Robot Framework, but how does the choice of an AI model impact the library's functionality and its performance?
So, hello everyone. Yeah, right now we are working with the OpenAIs. It was our go-to choice, as these models were working for us the most. But like I mentioned in the presentation, you can include multiple of them. So for example, we are working with a customer that has its own GPT within its network. So you can build your own connectors to these models. You can also, for example, use Claude, which is really good for coding. And regarding performance, so it's always up to the model. So if you will be using some model locally on your laptop without some good NPU, probably it will be slower. And that if you are communicating with the AI, for example, within the listeners, then yes, definitely. Any addition, any communication outside the robot framework, it will make your test slower. So depends what you want to use, but overall with the OpenAI, we feel like it's not too bad. But that said, we have not been using it in every test, for example, for 1,000 tests. So that would definitely slow it down. So it would add up.
Yeah. Another question is that you acknowledge the challenges of prompt engineering when using AI tools, and the question is, what are some strategies or best practices for crafting effective prompts that elicit accurate and accurate and insightful responses from your AI models?
So
Good question.
definitely, yeah, definitely. And I would say this is the most common question regarding AI for past 2 years, how to communicate with the AI. So definitely writing the prompts is not so easy at the start, but it has its guidelines, it has its rules. If you are starting with that, I would definitely recommend the documentation on the OpenAI. Like I don't know if many of the people know, but they have awesome documentation how to write prompts. So you can definitely check it out. It will help you. But in other way, I would say try it. Like you won't get it on the first time. You might not get it on the 10th time. You will still be finding some small issues. So for example, when the data were generated, we had a lot of different prompts. We had a lot of different settings for the AI. So there are options like setting up the temperature, setting up TOP, so some additional parameters for the AI. And we have selected the best one from the testing that we have found. So that's what we are using in the library, but anyone can change them to fit to their needs. But the best thing I would say, try to include as much context as you can, and try to also add an example of the return that you want to get. That always helps.
Check. Good advice. Another question. Are you as you are using LLM models, large language models, to create test data, are there any safe checks that won't make the tests flaky?
So definitely there would be checks that should be done for the data that are generated. We have, so when we are generating data with the data generator, there are checks already inside of that so that we get a correct format, that we have a good lists, but we are not checking the data itself. So if there would be something wrong in the data, for example, we were using the real addresses. So if the real address, for example, would not exist because the AI just made it up, we can't check that. But what we can give you is that the format will be always the same. So if you want a list, you will get a list. If you want a dictionary, you will get a dictionary.
Check. Good. And there's more questions.
Nice.
And we have time, so that's good. So let's have a look. Here a question saying, hey, it's a nice way to generate test data, but why would you be changing it every test run? So how do you use the test data generator? Yeah.
So from my experience, not changing the data is not a good way to do testing, because if I'm always using the same data set, I will probably miss some potential new issues that can come up. For example, if we are checking some registration form and we are always using the same email, we are not checking other formats, well, it will probably break at certain point. So what I like is for my test to be a little bit more dynamic in these ways, like having different data sets. If I'm working with financial products, I'm trying to change the products. So not always using the same product IDs, but changing them up. Because yes, I can find some issues. I can find some flaky tests, but that will probably mean that something is wrong with it in the system, or that I need to solve that. So basically, like we discussed on some Wrobocon conferences, green tests are bad, red ones are good. From the red ones, you will learn something.
Yes, definitely. I've heard that discussion come up every now and then in Helsinki, indeed. A little bit of a follow-up question, because is it even possible to reuse the previous data using the library, or refresh generated data? Is there something that we can do?
I believe definitely we can. So depends on the use case. When you are getting the data, you're always getting it via some keyword. So we could store these data. So those could be stored somewhere on either CSV file or some JSON file or anywhere within your project. and then being reused. Also, if you, for example, generate it for a test suite and store it in the suite variables, then you will have it for all the tests the same. So don't know if that answered the question, but yes, depends on the use case.
Another interesting question. Is it possible to automate, and it says WPF desktop applications using Robot Framework AI library? I'm not completely sure the WPF, but
let's discuss that in Speaker's Corner. It's an interesting question, but I need more context to that.
okay. That's a good one. So we have at least something to discuss in the Speaker's Corner already. Good.
Perfect.
Well, we have time for another question. Let me see. When you're using new test data every time, how does it impact the costs, for instance, for OpenAI models?
Depends on the model you are using. So we are heavily using the mini models. So for example, the GPT-4o mini, and these prices are pretty good. They're okay. And also we are trying to limit the amount of conversations we have. So if we are generating some data, like we discussed, we, for example, set it up for the test suites and use it within the same test suites once, or it can be also for the whole run being used once. On the other hand, if we would like to do something more, for example, with those listeners, I would recommend using some higher models like GPT-4o, or maybe trying also the O1 previews. But yes, those are pricey. And with the API, you are paying for each token that you send and receive. So some calculations are needed, but I would say with the mini models, it's pretty good. And also, if you are really investing into AI, you can also build some of your own local AIs using llamas, and then just create a connector to it. I think that's also something that we would like to include within the library. It's not there now, but the connector to llama, so you don't need to develop it for yourself, but you can just use it, connect to your local AI, and use it basically for free.
Cool. Thank you so much, David, and thanks all the attendees for all the questions coming up. Really cool to see. But we have to get on to the next talk. So I'm gonna hand it over to Chris. Thank you so much, David, for your talk and your work on the AI library. Thank you so much.
Thank you very much for inviting me. Have a good conference.
Yeah. Thank you. Over to you, Chris.
Thanks, David, for the very interesting talk. And now we'll start with the next talk from Kailash, and it's about automating Playwright Test with AI. So let's start with that.
Okay. So guys, welcome to the Wrobocon 2024. So in this year, on this conference, my talk is on automating Playwright Test with the AI. So what I did in this talk, this extent of explaining directly about the AI and how we can leverage AI in the automation, I break down this talk into two parts. So first, I will explain about the Playwright. So Playwright, the Microsoft tool. So I will explain about some of the feature of the Playwright that make him a game changer. I will explain each of the feature with the example. Then I will come to the AI in automation, where I will explain how we can leverage the AI in our automation. I will give example using some of the tool, so that basically normally that I personally use, and that I personally use for the automation to generate the script. And then I will explain about one of the library which normally we use for automation the Playwright script using the Zero Step. Zero Step is a company who has created basically the environment by using using this platform, or you can say this tool or this library, we can create our test cases, Playwright test cases, and make our execution fast. And I will explain in detail. So let's move to the next slide. So this is the agenda basically. So I will explain about the introduction of the playwright. So we will give you the brief detail about the playwright. Then I will explain how we can set up the playwright in an easy way. Then I will explain some of the game-changing feature, or you can say some of the tool that Playwright have, like browser context is one of the features, harding is a feature, UI mode there is another feature, tracer view, debugging, and code gen. I will explain all these features with example. Then I will explain AI in automation, how we can leverage the AI in automation. Then I will explain about the library zero step which we can use to create the, or you can say create the script in Playwright. And I will explain this library with some of the live examples where you can see how we can leverage zero step to create our playwright script and make our execution fast. That is me, myself, Kailash Pathak. So I am working as a senior QA lead manager in III Global. So I have more than 15 years of experience, and most of the experience in automation. And from last 4 to 5 years, I am mainly working in Cypress and Playwright. And in the free time, I love to write the blog, or you can say the technical blogs on various tools, very traditional tools, or the tool that right now in the market. And also, I love to give the conferences. I love to participate in the workshop and the talks. So this is all of this about the Playwright. So Playwright come into the market in 2020. So basically, before Playwright, the tool that was very popular in the market was Cypress. So though definitely we have other traditional tool like Selenium and all, but when we talk about the JS tool, JS framework tool, so this is the tool come after the Cypress. So the popularity of the Playwright is basically it's getting the property day by day. The reason is simple. So it's first of all that the reason that I see first of all is the multi-language support. So it support TypeScript, JavaScript, C Sharp, Java, and Python. Apart from that, the region of the popularity is like it's handle Shadow DOM, iframe, alerts, and other basically other objects very well. And by default, it's run the another region of popularity of the Playwright is the by default all the test cases in the Playwright and in parallel. And though we can adjust in our config file if you don't want to run in parallel, we can update our config file. And suppose I want to run in only single browser, so I can update my config accordingly. So I will explain in detail. And apart from that, one of the other feature that Playwright that I really like is by default it supports CI/CD GitHub action. So we don't need to configure much in the CI/CD side. So it give a by default YAML file. So when we install it, will ask whether you want the GitHub action as a default or not. So if you give the answer in yes, so the YAML file will be created by default, and you can update the YAML file as per your requirement, and you can execute your test case in CI/CD very easy. Features some of these are some of the features of the Playwright. So cross browser definitely we can run as I mentioned we can run Playwright test case in multiple browser, or I mean by default it supports Chrome, WebKit, and Firefox. So as I mentioned in the config file we have all these three browsers by default come, and if you want to execute only in one or two browser you can just update the config file. Cross platform, Playwright support the cross platform. You can run your test case in Linux, Mac, and window. Cross language support most of the basically languages like TypeScript, Python, Node, and Java. Playwright inspector is the another feature that we that the play that we have. So using the Playwright inspector, you can generate the selector, or you can say locator very easily. So you don't need to worry about how to generate the locator and all. They have their inbuilt Playwright inspector with the help of which you can generate the selector or locator. Tracer view is another feature that the Playwright have. Using the tracer view, so suppose that you have executed your test cases and some of the test cases are failed, you want to investigate the region of the failure, you can do very easily with the help of tracer view. I will explain in a few minutes. Auto-weight mechanism is there. Browser context. Browser context is nothing but kind of, you can say that it's a basically it's a incognito window, separate incognito window. So Playwright suppose a browser context concept. So in browser context, using the single browser instance, you can create the multiple browser context. When I say the multiple browser context, I mean to say multiple incognito window, and in multiple incognito window, you can run the multiple different type of application. So I will explain with the example one by one. And there is a one more feature I'm missing here, which is starting. In starting, basically, you can by default, as I mentioned, Playwright support the Pelder test case execution in Pelder. But with the help of sharding, you can enhance that capability, like running your test cases in multiple machines. That I will explain. Set up Playwright in Blink. So Playwright, we can easily set up the Playwright. So we have normally two methods. First method is npm init Playwright the latest. So once we run this command, it will install the basically Playwright. And the another way to install the Playwright is using this VS Code. So we have to just write this command, and the Playwright is installed in 7 to 8 seconds. So it would take hardly 7 to 8 seconds to installation, right? And when we do the installation, it will ask for whether you want in TypeScript or JavaScript. So it's up to you. Defaultly TypeScript. So if you want to create your if you want to create your script in JavaScript, you can select the JavaScript. Let's see some of the magic feature of the Playwright. So first is the browser context. So as I mentioned, you can see here in the diagram, using the single browser instance, you can create the multiple contexts. So Playwright create a multiple browser context within the single browser instance. This is useful when you want to test a multi-user function like role-based testing or chat application, right? Instead of launching the new browser instance for it use one browser instance for all the tests. Each test create a unique browser context within the browser instance. So suppose I want to test three applications at a time. So normally in the traditional system I have to launch the three browser, but using the Playwright, where have a browser context concept there. So using a single browser instance, you can create three contexts. In context one, you are running suppose application one. In context two, you're running application where you are logging and adding to the item to the cart. In the third context, suppose you have accessing some other application where you searching and doing some other action. So let me quickly show this browser context. How can we run browser context practically? So let me open the Visual Studio. So yes. So let me move this three test cases here just for to avoid the confusion. So this is the browser context here. So this is one of the specs file that I have created here. So if you see here, I have two browser contexts here. This is the one browser instance basically. Using the one browser instance, I have created two contexts. First context is here, second context is here. Okay, let me do one thing. Let me take this example. I think okay, yeah, this is the example. Yeah, three contexts in here. I want to take this example further. So here you can see in the first context what I am doing. I am opening this application automationexercise.com, and I am logging with NCR Meet one. In the second context, I am opening this Lambda test site, and I am logging with this username and password. And in the third context, I am again log into this application, automation exercise, and then I log in with some different user. Here I am using NCR Meet one, and but here I am using the NCR Meet two. So let me run this. So what will happen basically when this specs file we run, it open sorry, it open one browser but three contexts. For first context, it will open this application. In second, it will open this one, and in the third, it will open this one, this one actually. So let me just give me a moment. Just let me open this. Uh, Okay. Under the test folder, I have this browser context. So I am running this file browser context.spec.file. So let me in headed mode. So let me run this specs file. So you will see three contexts will open. This is the first, it will open, and this is the second lambda test side open. Then it will and this is the third one. So three applications. So at a time, one time, I am working on three applications basically. This is my first application. Here you can see I logged in with Peter. In second, I logged in with John. And in the third one, basically, I logged in the Lambda test. And whatever I want to do, basically, I can easily do. So this is one of the beauty of the Playwright. Basically, you have a browser context concept. So at a time, using single browser, even if you see here, it open all the in incognito. This is the in incognito. This is also open in incognito. And third one is also open in incognito, right? So this is the one of the good thing about the Playwright. So they have a concept of browser context here. So with the help of you can parallelly you are working in three applications. So this is one of the features that I really love about this. And whatever the action you want to perform, you can easily do basically, right? So let me stop it. Okay, let me quickly move to the other feature of this Playwright. So this is browser context, and other one is the sharding basically. Sharding, as I mentioned, Playwright sharding is technique by running the test suite across multiple machines simultaneously, right? So by default, as I mentioned, let me quickly show you. So this is my Playwright config file. So if you see here from line number 35 to line number 49, so it support by default three browser, Chromium, Firefox, and WebKit, right? So right now I have these commented these basically, and even also it support the mobile responsiveness also, right? So I have just commented these line and I keep this basically only the Chromium. So starting is basically by default as I mentioned it supports. Suppose I have to run the test cases. So let me move this test case here and let me do one thing for the. I am taking these two example here and moving to the this test one. Okay. So if you see in example one, I have how many test cases I have? I have 16 test cases. In example two, I have five test cases. So total number of test cases that I have right now is 21 test cases. So if I run these test cases here, so it will run basically as I mentioned in the config file, it will run in one browser and using the four worker. So four worker is nothing but you can say kind of basically four machine, but as I am running in the locally, so it's only basically it's a basically one machine. So practically my test case are running in the one machine. So if I run this test case here, so let me go here. Okay. So by default, Playwright run the testing further in order to achieve the even greater parallelization, you can further scale the Playwright execution. Okay. Sharding take this as a step further by distributing a test across the different machines. So what sharding will do, let me run it first in locally. So here you can see four worker, 21 test cases are running because I have mentioned here in line number 22, I have mentioned the four worker. But as I'm running locally, so it's my test case are running in one machine only. They are not actually practically they are not running in four machines. They are running in only one machine. So if you can see here, it's take around 15.9 seconds, right? So using the sharding. So for sharding, what I have to do, as I mentioned in Playwright, we have a by default one YAML file where you can mention in how many machine or you can say how can you how can you want to distribute your test cases. So if you see in line number 14, I have distributed my 21 test cases. These are my 21 test cases. I have distributed these test cases in four machines. So when I push this code, they are start executing in the four machine. And you can see here in the below basically what I am doing here. I am just checking out the code and I am running my test cases in the in the matrix dot started. Basically, I am running in 4 machine, and finally I am merging the report. Basically, what happened, because my test cases are running in 4 machine. So I want, if I want to generate the report, I have to club all the test cases, the executed test cases from 4 machine into the single machine. So finally, I am merging the report and using this blob. So for that, we have to do to run this. So in line number 24, you can see we have to give the blob option here, right? So this is my YAML file. In YAML file, I simply mention how many shard, how many machine you can say I want to run my test cases. These 21 test cases. These are the 21 test cases that I mentioned basically, right? And finally, I'm merging the report. All the my test cases are running in 4 machines. They are merging together and finally generating. So let me quickly open this GitHub. One I already executed the test cases. So let me open the this test case here. Yes. So if you see here in the action, I already running these test cases yesterday. So you can see my 4 test cases are running here in 4 machine. And because as I mentioned, I have total 21 test cases. So if you see in first machine, how many test cases are executed? In first machine, my 6 test cases are executed. Okay. So test file one, 6 test cases are running in second machine. How many test cases are executed? In second machine, you can see 5 test cases. So 6, 5, 5, and again finally 5. So total 21 test cases are running in my fourth machine. Here you can see 5 test cases, and in the last side, or you can say in the last machine, my remaining sorry, remaining test cases are executed. And finally, you will see the report. Let me quickly show you the report here. If you go into the report, so here is the report generated here. You can see the blob report. And when I click on this HTML report that is generated, it will download it itself. So let me quickly open this. Yes. Here you can see 7.9 seconds is taken by 21 test cases. Okay. And if you compare with the local, it's taking 15.9. So almost half, you can say half time it will taken when we run in the starting, or you can say if you run in the CI/CD pipeline through the starting. Here I have given the four shard actually. So if you want to increase, you can increase 5 or 6 shard. So this is all about this sharding. And let me quickly move to the other feature of the Playwright. So the another feature of the Playwright is code gen and Playwright inspector. So for the code gen, let me quickly run this command here. So code gen is nothing but just for this to run the basically to generate the code actually. So let me quickly run this command here. So I have run this command. Let me let me copy the complete command here. So what will happen when I run this command? It will open a code generator which will start generating the code. It will open the inspector. So the inspector you can see here, and you can see basically it will start recording. So let me quickly log in into this site. So let me log in with this. Okay. So I am logging with this person, and whatever I am writing here, it will start basically typing also here. Basically, it will start recording here, and you can also you can also see one thing more. So you can inspect any of the object, and you can see basically what are the locator for this contributor, what is the locator for this. So this is one of the one of the feature of this Playwright. Basically, you can, if you want to see the what is the locator of this, and you can easily see. So this is one of the feature of the Playwright Inspector. Apart from that, basically, okay, let me do further. So let me click on login button here. Okay. Okay, might be I have done something wrong here. So I think in password is wrong actually here. Password is lambda123. Let me quickly run it again. Here is the mail ID, and let me log in here. Password is 123. Yes. So let me log in. So yeah, so here you can see whatever the step I am performing, they are logged in here. And apart from this inspector, basically, as I mentioned, you can inspect any of the object and you can get the, like if I want to get the locator, I will just click here and you can see here and it will click on this and it will automatically basically get the locator also. And apart from that, there is just some another feature here for the Playwright Inspector. If you see here, there are three options here basically. One is these are the basically assertion basically, right? So these are the three assertions that Playwright have. Just a minute. So if you click on here, this is the assertion for visibility. This assertion for the text. This assertion for the sum value. So suppose I want to verify this text here. So what I will do, I will click here and I will click here and then I click here. So it will automatically type latest article, and then once I click on this check sign, it will automatically print here in my Playwright Inspector, right? So this is the basically it to contain text. If you load. So this is one of the feature basically that Playwright have, like you can inspect, you can do the recording all the stuff. You can basically you can get the locator of any of the object. You can put the assertion. So that is all. This is all about basically the this is all about this feature of the Playwright. So let me quickly move to the uh, other features. Yes. Now come to the AI in automation, basically. So AI nowadays actually very popular, basically. So everyone want to know basically how we can leverage the AI in automation. So AI in automation refer to the use of artificial intelligence to enhance the automate various aspect of the software testing. AI can improve efficiency, accuracy, speed for the analyzing the vast amount of test data. So normally when basically like the Gen AI model that we have right now, like the Chat GPT and the Copilot, and we have in the basically that normally we have. So how can we first thing basically how can we leverage these things these Gen AI model in our manual work? Then how can we leverage it in the automation? So if I talk about the manual work, so definitely we can take the benefit, like suppose I want to create the test plan, some I want to create some test plan or test strategy document. I can take the leverage of the basically of this chat GPT, Copilot, and Gemini, right? Similarly, if I want to generate some code, like this is one of the medium blog that I have written. If you see here, I have asked basically some of the prompt here, basically like generate the Playwright JavaScript code to open this website. So it will automatically generate this code. But though we can't rely 100% on this generated code, so we have to put our brain like this the code that is generated correct or not. So in this blog I have basically I have run couple of prompts. So if you see here, it will when I run this question, it will generate this code me, and after doing some minor change, so finally I am able to finally I am able to generate this to generate this code after doing some tweaks. And when I run this, I can easily run this without any error. And then in question 2, I asked to write the playwright JavaScript code to opening the URL of the site, right? So it ChatGPT generated this code for me, and after doing some minor tweak, I am able to generate it. I am able to run this code successfully. Here you can see. In question 3, I asked to print the title, so it will generate with this. So I mean to say we can leverage, we can't 100% rely on ChatGPT, Copilot, or other Gen AI model basically. But yes, we can take the leverage, like we can also take the benefit, like suppose we are struggling some debugging, we are struggling with the code where it giving the error and all. So what we can do, we can just copy and paste and put in the chat GPT, and it will give the answer like where we are doing some mistake and all, right? And you can see here that this test case also pass, and it will also generate the page title. And then I logged in with this scenario, like logged into this and logged in with this username and password. So it will generate this code for me, and after doing minor tweak, I am able to run this code successfully. So I mean to say, we can definitely we can leverage the AI in whether in manual or automation using for test script creation, but ultimately we have to put our brain like where basically what the general, because most of the time basically we have to do the tweak in the generated code. We can't rely 100% on the generated code. So definitely it help us in basically to doing our work fast. But you should have the you should have the knowledge of all the whatever the tool you are using, or whatever the language you are using, right? So in the last, actually, basically, I asked to add the cart, and also it will add the item into the cart. So this is all about basically, this is all about the chat GPT, how we can leverage the tool, basically this type of tool, whether it's chat GPT, whether it's Gemini. Here you can see I have to generate the Cucumber feature file, so it will generate for me the Cucumber feature file, right? So this is the one thing. Another thing that there are, we have couple of tool in the market right now we have that are helping to basically to doing the automation, and they're making the test very fast. So I got a chance to explore some of the tool basically. Like one of the tool I explored is Apply tool. So Apply tool, what is Apply tool? Apply tool is the world's first autonomous testing platform to help you to correctly test your application with the help of AI. So with the help of this Apply tool, I personally use this tool basically, and I love it. And basically, you can use this tool from various perspective. Like you can, for UI automation, you can do with the help of this Apply. You can do the API automation also. You can do the visual testing also. So there are different basically flavor in this tool. Like you can scan your complete website. You can scan your some of the URL you want to test, and then you can run and one good thing about it, you have to write your test case in the plain English. It support the NLP basically, right? And you can also record and debug in the real time, right? And you can verify dynamic data, right? So this is one of the good thing about this tool basically, and I personally use it, and I have run couple of basically test cases on this Apply tool. Let me quickly show you. So here you can see this is one of the, I have generated two test cases, one for the UI automation, another for the API. So you can see for the UI automation what I am doing here. So very easy basically Apply tool. So once you registered in this tool, and you can request for the free trial version also. Once you done the request and once you logged in, you can see here basically it come into the three flavor actually. So when you logged in and you click on this test here, you can create a new test for full website, for URL, for particular URLs, for custom flow. Full website, it will scan the complete website. URL, particular few of the URL, it will scan. Custom flow, basically you can, where you can record and you can type your step in plain English language, right? So let me quickly show you the further UI automation that I did here. So you can see here I have recorded some of the step here. So it's a very plain language in English language, like go to this, enter this, and then finally basically I am logging down. And so let me quickly run this so that you can understand how basically useful these type of tool are. And the good thing about these tool is, suppose you don't need to depend upon any of the basically, if there is a change in the UI is done, or there is a change from the dev side is done, it will automatically It's a self-healing concept here in aptitude actually. So you don't need to worry about like my test case will be break, and also you have to just write all your step in plain English. So here you can see I have just logged in into this, open this site and logged in with the username and password, and then click on to add to the cart, and I am adding the cart, then I am checking out, and then typing something, and then clicking on the finish, and finally I'm logging out. So it will take me some time. So in the meantime, it will running. I can explore you the basically another basically feature that they have actually. So let me. You can do API automation also. So let me quickly show you the one of the API automation script I have recorded here. So let me quickly show you. So this is my API automation that I have recorded here. Let me just a minute. Yeah, here you can see. Go to this side, and I am saying here go to this, and then I am hitting here the get request, and after getting the get request, I am verifying the status 200. Then I am verifying the title and all, right? So this is the good thing about this. Basically, you can do basically not only the basically UI automation, you can also do the API automation with the help of this tool actually, right? So might be due to some reason it's not running, but I want to just showcase you like these are the steps that you have to basically generate here, and you can quickly run your test cases. Let me stop it again and let me run one time. Yes. So these are type all the tool basically they're really helpful for the automation. So in the meantime, this test case is running. I will go to one another tool basically, which is Can AI. This is the tool from the Lambda test. Basically, they recently launched it to the market. So this is almost similar type of basically advanced AI power tool on the modern LLM, using approach to create and debug and all the end-to-end testing in natural language. So you can also do the basically you can take also this leverage this tool for your automation perspective also. So it same concept here basically they use also NLP. You have to write your step in plain English. So I already recorded some of the script here. So let me quickly show you. Okay, just a minute. Same concept is here also actually. So let me go to the test manager here. So after logged in, basically you can go here in test manager and you can create a new project, and inside the new project you can create your script. So I have created one script here. So let me quickly open this test case here, and here you have to basically create the project, and then you have to create the folder, and inside the folder you can create your basically like smoke suit or regression, whatever. So here you can see I have done same basically like open this, then enter this. Let me quickly edit this test step. They also basically in Can AI, basically we also follow the same thing. Like you can see here, we have written in plain English like open this, and then here you can see it entering the username, email ID, then entering the password here, and then clicking on the login button, and then finally basically after clicking here it clicking on this logout button, and finally after logged out it verifying this text. So these model are basically these type of tools, basically AI tool are very helpful, and you don't need to worry about the locator or all. So in case suppose that some of the locator are changed, or some of the object are changed in the UI, they will automatically heal actually. So you can see here our test case is part. So these are the two tools basically that I want to demonstrate here. And last but not least, so let me move to the further about zero step. So zero step is another basically I would say it's a library. So supercharge your playwright test with the AI. So zero step basically it's basically behind the scene. It's used GPT 3.5 and GPT 4 to make the Playwright test simpler, right? So I have created one document here just to set up all the thing for how we can set up the zero step. So why you use the zero step? The conventional approach basically set that basically the in traditional approach, basically the locator that we have to use the locator actually basically to suppose to interact with the object into the UI, right? So we require CSS locator, XPath or ID or something, but with the zero step, you don't need to worry about the locators and all, right? And they clearly mention here basically so long selector. Instead of CS selector XPath, AI instant determine what action to take the runtime based on your plain text instruction. So you have to just write your basically command in plain text and you don't need to worry about the locator, which locator they are using and all, right? So they have given one of the example here, and one of the good thing about the conventional approach they have mentioned here, selector are tightly coupled, right, to the application. No selector here, but it with the zero step, no selector is used for the zero step AI assistant, right? Every action must be precisely translated to the code, making it to test slower to implement then unit integration, but build test quickly, expressing the action assess and play instruction. They have clearly basically mentioned what are the conventional or traditional approach, and but with the help of zero step, what we how we can do very easily. So pricing model, so they have 500 AI. So when we say 500 AI, I mean to say basically 500 command that you have used basically to create your script. So up to 500 are free. After 500, they are charging like for 2000 AI, they are charging $20 and this. So so this tool is still basically this is basically I really like this tool, but yes, there are some still they have some issue with this tool basically. So sometime I feel basically for few of the objects not working properly and all, but yes, so looks very promising. So might be the down the line once the zero step launch this zero step team launch this tool full flash pro and fixing all the issue. My assumption is down the line is going to be, I mean, good tool for the testing, especially for the playwright basically, right? So they have given some of the example here, like these are the some of the E2E tests they have given some example. I will showcase you. So so for the setup perspective, you have to basically you have to run this first. You have to install an playwright. Then you have to run this command, which will install the zero step, and then after logging into the zero step, you have to copy this API key and you have to create zero step config.json file, and you have to mention this token or API key here, and then you can automate your test cases using zero step. So for the example purpose, I have taken this example here. Log into the site e-commerce, enter the valid username password, then login button, and then edit the account and then fill the data, right? So conventional approach is that basically, so okay, let me show with the code here. So let me open the Visual Studio again. So if you see here, I have given some of the example. So suppose I have to log in into the site ecom playground playwright sorry lambda test site, and I have what I'm doing here. Here I'm just entering the email address and then entering the password and clicking on the login button, and then basically what I'm doing here, I'm clicking on the login button here, and then I'm just editing this. I am doing the editing account, right? And for then I'm just updating the first name, last name, email, and all, right? So this is the traditional approach. So you can see here I have written almost 22 line code here, but using zero step, it become I mean the code become almost half actually. So if I showcase you, this is the basically I have written with the help of basically zero step. So what we have to do for zero step, we have to import line number 2 here, and instead of like you can see here in the line number 6, I click on page.go to this URL, then await AI. This is the command basically that I mentioned here. Basically 500 command they are giving free without any money, without 500 AI function they are giving per month, and after that we have to pay for extra basically. So up to 500 they are free. So you can see here There are 5 or 6 commands we are using for this test case. So total you can see in 16 line I have total 15 line code, and in the previous when in the traditional approach we have to write in 22 line code, and almost I would say almost half, basically half line of code. And one good thing about it that one about this zero step is like suppose I have to fill the data in this form after logged in, because here you can see after logged in I am editing and I am updating this information. So in the traditional approach what I have to do, I have to find the locator and then dot type, find the locator of this, then dot type, and then find the locator we have to do. But in zero step you have to write only one single line. You can see in line number 13, you have to just write fill out the form with realistic value. Okay, so let me run this command here. Let me run this test case one time. Okay, test. So this is the basically using the play zero step. So I am running this. So you can see here basically it will log in into the this email address and password and then edit account, and then it will edit the information, right? So this is the good thing about basically about the zero step actually, right? And apart from there are some other example here. You can see source demo. This is one other example I have given here. So what I am doing here in this site source demo, I am logged in with this username and password, and then I am checking this bit complex scenario that I am doing here with the zero step. So what I am doing after login, I am adding these two products to the cart. Then I go to the card and then checkout page, and then I'm entering the value here, and then finally I'm verifying whatever the value, basically total value, the sum of these one, two, these values and plus tax is equal to 4318. This is I am trying to verify with the help of this zero step. So if I do traditionally, so I have to write lot of code here, but with the help of this zero step, I can easily write very easily basically, and don't need. And one more thing, basically, I don't need to worry about the locator failure and locator, what are the locator and all, right? So let me run this code here. So this is the source lab code here. So okay, let me run this code here. So you will see here it will logged in and it will add two item into the card, add to the card, right? So you can see here two item are added, and then it will check out, and you can see here the automatically filling the value. I don't need to fill any value, and then back to him and then logged out, right? And if I go to the console, actually I have printed the value in console also like 4318, right? So the whatever the basically value is coming, like just a minute, add to the cart, and if I go here, you can see here in the checkout page, you can see here in the checkout page the value total is 43. This plus this tax equal to 4318. So I am just verifying here the combined price, product, first product price, second product price, everything I have printed here in the code here in the line number 14 or 15, you can see. So I mean to say, even with the help of zero step, we can do the complex scenario also. We don't need to, I mean, only not all the simple, but we can also do the complex scenario. I have written some other basically like for the calendar, for scheduling the calendar. I have written this code here also. So basically, I am opening this side and then just scheduling the basically scheduling the calendar for a particular day. And you can see finally you will see the message you are scheduled. So I am here also using the same zero step command here. You can see AI here. So these are some of the example and they also given some of the example here. You can see, right? So like book the next available time slot currently here, and then search for the organic, like they are what they are doing here, they are just opening this site and they are searching something, right? And then Basically, this is another example they have given here, and this is the get the latest top price. So everything basically they are doing with the help of this zero step. So zero step, I totally agree. There are people saying like it's not much stable. I totally agree with the people, but yes, down the line once they will for the POC purpose, you definitely you can leverage this zero step and you can take the benefit. And good thing about the zero step is you can use both the mix command of zero step plus playwright command. Both the command you can use basically. You don't need to rely only on zero step AI command. You can also mix the zero step plus my playwright. It's on playwright command as well. So this is the good thing about the zero step. Okay, so let's move to the next thing basically. So I think I almost done. Let me move to my next slide. I hope I already done. Let me just to make sure nothing I left here. So I have covered all about this, right? So here is it's all actually. So you can find me. You can find me in LinkedIn. You can find me in Twitter. So I hope you like my session. So thanks for your time and thanks for your basically patience.
That was a great talk from Kailash.
Mhm.
Hi, Kailash.
Hello.
And a very deep dive into playwright
Yeah.
and zero
Yeah.
step.
Playwright and yeah. I try my best. I hope people like it. People like it. Yeah.
Yeah, if you, the audience, want to add questions to Kailash, you can still post them. But I have some questions already that came in. So the first one, you mentioned Playwright is a game changer. Could you
Yes.
elaborate on some specific features of Playwright that make it stand out in the automation landscape and how these features address
Yeah.
common pain points in test automation?
Yeah. So Playwright actually, why I say the game changer, actually Playwright just come after the Cypress, right? So I am not criticizing any of the tool here, but still normally people come from the Selenium background. Actually, most of the people like what if my knowledge is correct, 50 to 60% from the Selenium Java background, right? So one of the biggest challenge that we have the language constraint actually in the previous tools, right? But Playwright resolve this tool by providing not only doing the automation with TypeScript and JavaScript, you can do with Java, we can do with Python, you can do with the .NET. This is the one thing. Cross browser, cross platform, they have given. Another good thing, parallel mechanism actually. They support by default actually parallel mechanism, right? In other tools we have to do the kind of some configuration, but here they will generate the YAML file at the time when you install it. You have to just give the command. You have to just tell, okay, you want the YAML file. If you say yes, it will automatically add the YAML file, and in the YAML file you can write your script and for CI/CD pipeline to run the test case in the CI. Another feature that I really love about this is basically stress view. Actually, there is a feature here in stress view. Stress view is nothing. It's a basically is help us in debugging actually. So normally we have in the previous traditional tool we have the debugging capability, but here in Playwright you can do even a single millisecond, even a single second, what exactly your application going on. You enter username, you are entering password, every second, every millisecond you can see in the UI actually, right? Apart from that, in trace view you can not only see your application, you can check the console, you can check the cookie, you can check the your network layer in network, what the response is coming, what the requests we have sent. So that is other thing. Another concept that really I like about the Playwright is sharding concept. There is a concept of sharding. Sharding is nothing but basically it's an enhanced version of kind of, I would say, to get a great parallelization. I would say, suppose we have parallel mechanism as I mentioned in Playwright we have, but using the sharding, what you can do, you can distribute your test cases across the machine actually, right? You in the YAML file you have to just provide the sharding, and you have to just enter like on which of the, or apart from the sharding you can just mention there like how what the report you want, right? So if you see my video here, I just showcase there. I am mentioning the sharding there, and then I am also attaching the report actually in the bottom actually, right? So you have suppose you have a 50 or 60 or 70 test cases, you can divide accordingly. And what sharding do? It will automatically divide your test cases in balanced way. If you have 30 test cases and you have suppose only 2 machine or 3 machine, it will divide automatically. Actually, that is another thing I really love about the Playwright. So these are some of the feature, and apart from that, they have the inspector also. They have recording mechanism also. If you are if the folks are new in the Playwright, they can take the benefit of this Playwright inspector, right, where they can record the step, and they can, after recording, they can convert their step into the Python or C# or any other JavaScript or TypeScript. And other thing we can do, we can during the recording time, we only not record, we can put the assertion also at the. So I would say, if I am a beginner in the Playwright, I have a recorder, I can record my step, I put assertion also there, I just copy and paste and just paste it and then run this test. At least for the beginner, it is really helpful, I would say. So these are some of the features of the Playwright. That's the reason I'd say it's a kind of game changing basically for the testing actually.
Okay. I think we have time for another question. Can you provide a real-world example of how you have successfully used Playwright in conjunction with AI to achieve a specific testing goal? For instance, could you illustrate a scenario when you used AI to generate test scripts or enhance visual testing within a Playwright project?
Yes. So for the visual testing, I personally use, I have a couple of tools. So the tool that I have personally used, one of the tool I mentioned in my conference here. One of the tool I use is Apply tool actually. Apply tool is really, good tool. So you can do the visual testing, you can do the AI testing there, you can do the UI testing. And the good thing about these tools is that they are self-healing actually. If your test case is break due to some locator error, they will do self-healing. Another tool that I use, their Lambda test just launched few months back, that is KNAI. This is also a kind of tool where you can take the leverage of the AI to automate your application, whether it's a Playwright or any other using the Playwright or using Cypress. You can use any tool and any website actually. You can take the benefit of this. And in using the KNAI, you have to just write in the plain English language. You don't need to be expert in any language actually, right? You have to write your step in plain language. Open this URL, then click this, it will automatically record in the backside. And in case your application due to some locator change or there is a problem, it comes and they have a good actually logging capability. But yes, if there's due to some locator and all your application is breaking, then they have also the self-healing concept actually. They in the behind the scene, they will automatically record your so many things from your cookies, or you can say they are recording, so that in case one locator is failing, then they immediately can use the another locator actually. So these are the two tools that I personally use using the automation actually, where I'm using the capability of the AI.
Okay, thanks, Kailash. So we have to continue with our program, but you will be available in one of the speakers' corners, right? After in Work Adventure, in our application.
Sorry, can you come again?
You'll be available in Work Adventure in one of the speakers' corners, yes, after the talk.
Yeah.
Okay, so if anybody has a direct question, you can ask Kailash there. So thank you once again for coming and for an interesting talk.
Yeah. So Chris, I have to confirm one thing. Do I have to join the same URL, and after how much time I have to join again? Can you confirm?
I will send you the information.
Sure. You can send me in my mail ID, please.
Yeah. Okay. Sure.
Okay. Bye. Thank you.
Bye. Thanks. So now I just want to, before we go into the break, notice that all the recordings of today's talks will be available to you from, I think, tomorrow. We'll send you a mail where you will have a link to YouTube where you can see all the talks recorded today. So, and now it's time for a break, and we'll be back at 10:55 with Marcel Veselka about Autopilot, your robot framework testing. So see you in a few minutes.
Lines of code, we're writing a lake and debugging till our brains feel fried. But there's a tool that's pretty great, and a robot framework by our side. Automation's our salvation. Keywords make it all so clear. We're testing like robots tonight. Robot framework makes it alright. So Selenium, SEO and more. Who knew QA could be such a score? Python powered, easy to read, and test cases flow like melodies. From web to mobile, it succeeds, and cross-platform compatibilities. Automation's our salvation, and debugging till our brains feel. What doesn't make run robots gain? Robot framework makes it alright. We're testing like robots tonight. Robot framework makes it alright. Selenium, SPI and more. Who knew QA could be such a score? Python powered, easy to read. Test cases flow like melodies. From web to mobile, it succeeds, and cross-platform compatibilities. Automation's our salvation. Keywords make it all so clear. We're testing like robots tonight. Robot framework makes it alright. Selenium, SPI and more. Who knew QA could be such a score? Coding's clean, results are green. Our code's the tightest that you've seen. No bug escapes our robot gaze. QA has never been this crazy. We're testing like robots all night long. Robot framework makes it alright. Song. The web feel API and more. Who knew QA could be such a score? Who knew QA could be such a score? Who knew QA could be such a score? Python powered, easy to read, and test cases full of melodies. From web to mobile, it succeeds. OS platform compatibilities. We're testing like robots tonight. Robot framework makes it alright. Selenium, SPI and more. Who knew QA could be such a score? Could be such a score. Reporting's clean, results are green. Our code's the tightest that you've seen. No bug escapes our robots gaze. QA has never been this crazy. We're testing like robots all night long. Robot framework makes it alright. Song. Reporting's clean, results are green. Our code's the tightest that you've seen. No bug escapes our robots gaze. QA has never been this crazy. We're testing like robots all night long. Robot framework, you're our song. Lines of code, we're writing a lake and debugging till our brains feel fried. But there's a tool that's pretty great, and a robot framework by our side. Automation's our salvation. Keywords make it all so clear. We're testing like robots tonight. Robot framework makes it alright. Selenium, SEO and more. Who knew QA could be such a score? Python powered, easy to read, and test cases flow like melodies. From web to mobile, it succeeds, and cross-platform compatibilities. Automation's our salvation, and debugging till our brains feel. What doesn't make run robots gain? Robot framework makes it alright. We're testing like robots tonight. Robot framework makes cases flow like melodies. From web to mobile, it succeeds. Ours platform compatibilities. We're tested like robots tonight. Oh, that framework makes it alright. Selenium, SPI, and more. Who knew QA could be such a score? Or be such a score? Reporting's clean, results are green. Our code's the tightest that you've seen. No bug escapes, our robots gaze. QA has never been this crazed. We're testing like robots all night long. Robot framework makes it alright. Song. Reporting's clean, results are green. Our code's the tightest that you've seen. No bug escapes, our robots gaze. QA has never been this crazed. We're testing like robots all night long. Robot framework, you're our song. Lines of code, we're writing a lake and debugging till our brains feel fried. But there's a tool that's pretty great, and a robot framework by our side. Automation's our salvation. Keywords make it all so clear. We're testing like robots tonight. Robot framework makes it alright. Selenium, SPI, and more. Who knew QA could be such a score? Python powered, easy to read, and test cases flow like melodies. From web to mobile, it succeeds, and cross-platform compatibilities. Automation's our salvation, and debugging till our brains feel. What doesn't make run robots gain? Robot framework makes it alright. We're tested like robots tonight. Robot framework makes it alright. Selenium, SPI, and more. Who knew QA could be such a score? Python powered, easy to read. Test cases flow like melodies. From web to mobile, it succeeds, and cross-platform compatibilities. Automation's our salvation. Keywords make it all so clear. We're testing like robots tonight. Robot framework makes it alright. Selenium, SPI, and more. Who knew QA could be such a score? Reporting's clean, results are green. Our code's the tightest that you've seen. No bug escapes, our robots gaze. QA has never been this crazed. We're testing like robots all night long. Robot framework makes it alright. Song. So LPL, API, and more. Who knew QA could be such a score? Who knew QA could be such a score? Who knew QA could be such a score? Python powered, easy to read, and test cases flow like melodies. From web to mobile, it succeeds. Ours platform compatibilities. We're tested like robots tonight. Oh, that framework makes it alright. Selenium, SPI, and more. Who knew QA could be such a score? Or be such a score? Reporting's clean, results are green. Our code's the tightest that you've seen. No bug escapes, our robots gaze. QA has never been this crazed. We're testing like robots all night long. Robot framework makes it alright. Song. Reporting's clean, results are green. Our code's the tightest that you've seen. No bug escapes, our robots gaze. QA has never been this crazed. We're testing like robots all night long. Robot framework, you're our song. Lines of code, we're writing a lake and debugging debugging till our brains feel fried. But there's a tool that's pretty great, and a robot framework by our side. Automation's our salvation. Keywords make it all so clear. We're testing like robots tonight. Robot framework makes it alright. Selenium, API, and more. Who knew QA could be such a score? Python power, easy to read, and test cases flow like melodies. From web to mobile, it succeeds, and cross-platform compatibilities. Automation's our salvation, and debugging till our brains feel. What doesn't make run robots gain? Robot framework makes it alright. We're testing like robots tonight. Robot framework makes it alright. Selenium, API, and more. Who knew QA could be such a score?
Welcome everyone back. What a great music we have in the breaks. It's really awesome. It puts at least a smile to my face. But we're going next. We're going up with the next video, and that is Marcel Veselka with his talk called Autopilot, Your Robot Framework Testing, where he reveals techniques of maximizing your automation in your robot framework tests. So we will be looking at that video now, and afterwards we of course have our Q&A. Have fun.
Hello everyone, thank you for joining today's talk. I'm really honored to be part of this conference, and I would like to talk about my topic, how to bring your robot framework testing on Autopilot. I will share with you 7 examples how to optimize your productivity in test automation. Let me first start with my introduction. My name is Marcel Veselka, and I am in software testing industry for more than 20 years. Last 2 years, I am focused on building a startup, which name is Wopy.io, where we are building autonomous visual testing tools, or in general, autonomous testing tools for web apps. Before that, I was working for various banks, and last 10 years before Wopy.io, I was building a company called Tesena, where we were helping our customers to build their testing teams, their testing tools, and their test automation as well. Let me first, before I will jump into the details of the talk, start with something which might be interesting as an introduction for you. And this is something what I call signals. On the market, a lot of things are happening these days, and apart from AI, you could find also some other interesting moves. And I would like to talk about it because this is some, I would say, recent updates from various companies, but also something what I could see last 20 years, what's going on out there. So let's start with the recent reports or the reports from various companies. And as I said, I would like to share with you a couple of signals I could see on the market. And if you just explore what is reported by various companies, you might find out that, for instance, Gartner is reporting that 30% growth in area of testing will be dedicated to autonomous testing. So in 2 years, Gartner predicts that 1/3 of our testing approach will be done in a way of autonomous testing. Another interesting prediction is that, for instance, Forrester estimate that 20 to 30% of our testing productivity will be increased by deploying testing bots. And if you look at the maybe most well-known report in my social bubble or among my colleagues, more than 70% of companies are now considering what AI tools they could introduce or what AI they could introduce into the quality assurance process. So you could see that many companies are nowadays dealing with the topic of AI and productivity boost. And if you look at least at these 3 reports, most of them are searching for better testing. But as I said, last 20 of years, a lot of things happened, and let me share what I could see, what's going on the market from my point of view, if we would look a bit back and then return to the current market. So if we would look at the various stages, a couple of years ago, actually it's a couple of decades, we started manual testing where we were checking all the code, and we believed that we could find some more mistakes or bugs developers introduce in their code. Later we found out, especially with the introduction of agile and iterative approaches, that we cannot keep up anymore with manual approach, so we introduced automation. And nowadays, this approach is pretty mature. A lot of companies already adapt that, and they are proud of the achievements. And I sometimes say that automation problem is already solved. So what's the next era, or what's the next stage? Is there any like a next step to go for? Or actually, I don't know the answer, but for the purpose of the presentation, I built this slide in this way, that there will be another era where we would go into more autonomous approaches. In many reports, you could find this also as an AI augmentation testing, but I believe this is not only about the AI augmentation, even though that introducing AI heavily increase your efficiency already these days. So I'm not sure whether this is another era or it's just better test automation, but definitely there will be better tools, and we are all searching for more efficient approaches in software testing. So let me share with you some 7 ideas which could help you to optimize your productivity in test automation. And some are hard-coded and some are AI-driven. So I will go one by one and explain what you could consider if you are searching for some ideas, how you could introduce or how you could improve your robot framework testing. And I split these 7 ideas in various groups. I will start with some topics around technical assertions, then I will move to the visual assertions, which I call as a challenge number 1, all about assertions. And then I will be talking also about some autonomous interaction. Actually, this part will be LLM or AI driven. And this is challenge number 2, how to increase our efficiency in the topic of interaction. So let me start first with the first challenge, and that's the challenge of assertion. And imagine that you would need to test this checkout page. There is some card number, details, card holder name, expiration date, and then the security code, 3-digit security code. And after submitting all these data, if they are valid, and clicking on the purchase, you would expect something like this. So that's the confirmation page where you could read, thank you for your order, your drone is flying to you, and then you have some return to store button. If I would check whether this thank you for your order is there, that could be one of the assert I would run after navigating through these screens. But imagine that this would happen. Okay, first, this is the code, and you imagine that this would happen. So instead of getting this nice, I don't know whether nice, but at least designed page with some logo, with some footer, you would get just simple white HTML page with the same text. So if I would just validate that that confirmation message contains thank you for your order, I would probably didn't catch this bug. And my question usually when I'm running this talk live, or when I'm talking to some other colleagues and testing friends, I'm asking the question, what you would do to fix this issue or this risk that this bug could escape into the production? I could maybe introduce some more asserts. Maybe I could cover also assert that header is available, or footer is available, or button to return back to the store is available there as well. But adding this code, I'm not sure whether this would be that ideal scenario, because you would introduce a couple of more asserts, I would say 4 times more assertions, but it would increase your effort to build and maintain these all assets. And of course, this could be done across multiple tests, and then it would just blow up. So this is probably not the right approach how to tackle the problem. So let's discuss what could be another approaches. And that leads me to that technical assertions. So one of the idea I believe could help a lot to many testers running the robot framework tests is to introduce some technical assertions, because these are actually not so or not exact asserts as you would validate all this availability or visibility of headers and footers, but that brings you or provides you some quality signals. So if I'm talking about technical assertions, I could suggest that you could check some status code through your test execution. So instead of writing each and every assert, you might start to introducing some global checks. So probably you don't want to get any 404 errors during your test execution. And if you need to check that, these will be the special tests. You need to handle them differently. Or you could check whether there is no some console error, like JavaScript errors or warnings. Or you could check what's the loading time. And if you set some threshold, you might find out that some page is loaded super quick or super slow. So this will bring you some signals, and you could probably use these signals to measure your quality and expand your coverage. And now let me show you just very simple demo how this could work. I'm taking for this demo only one simple example where I'm checking whether there are JavaScript errors or warnings, and also checking whether there are status codes. So for that, I'm using browser library. And for those who don't know what's the browser library, it's Playwright implementation in Robot Framework. And I'm using simple keyword they implement, which is called crawl site. And this keyword basically crawl your site and then executes each and on each page specific keyword. By default, it's collecting screenshots, but I override this behavior and I introduce my own keyword, which is checking certain quality parameters, which might be status code, load, like speed of loading the page, and so on. So by introducing these simple checks, I could very easily find some potential bugs. And the code would look like something like this. So we would have the crawling website test case, and then I would just log whatever would happen during that crawling. Of course, I want to limit the number of pages I want to crawl, and I want to also limit how deeply I would like to go across the website. Of course, I could make it bigger, but for the demo purposes, I just decided to have 3 pages to be crawled. And once this is done, I am getting this type of results. So I could see that page basically crawled first 10 websites and already identify one dead link. So I could get this type of tests very easily and quickly to be set up, and it could bring me some additional value where I could very quickly spot that there might be some issues. And imagine that this could not need, or this do not need to be necessarily run with crawler. You could introduce these checks as a part of your test cases. So if you have already your regression test written, you could introduce these checks across your test execution and collect various checks, which will help you to identify potential problems. In my case, I was able to catch 2 errors running this. One was because of the dead link, and the other one was some issue with external, I think it was iframe on one specific web page. So this is the example how you could introduce some additional validations across your test automation without writing too much code, because that would be across the entire test suite if you would introduce it in this way on some global level. Let me now move on to the second idea, how I could expand my coverage or how I could add some more checks or validation into my testing approach. And that's about visual assertion. And for the visual assertion, I decided to take as an example our tool we are building, but you could use any other like Percy or Applitools or Lambda Test, or there are plenty of other tools out there. Maybe you could also consider using our open source, which we built at Tesena, which is called WatchUI. And you could check your visual quality. Let me first just quickly explain why this might be useful for you. And there are basically two reasons or two ideas what this could cover. One is increasing the coverage, so you could test much more, and I will explain this in a bit more detail. And you could also boost your coding efficiency because you don't need to code so much, or you do not need to code some complex assertions by applying visual testing. So why this might be a good idea, why visual testing could be something you should consider. And also I will tell you later why you shouldn't consider that and why this might be a stupid idea. So let's first start with this visual validation and the reason why we should consider that. So imagine that you have this type of checkout page or any other registration form or any functionality you want to validate. So what usually happens when you are running your traditional test automation, whether you are using browser library or Selenium library, you navigate through the DOM, you fill some specific elements, and then you click on pay button in this case. So once this is done and all goes well, your report is nicely green and you just continue and releasing into the production. But what might happen is that the application might be slightly or completely broken. And if this happens, then you might be in trouble because this could escape into production and your tests are still passing. So what you could do with this, there are a couple of options. One is that you collect the screenshots and then someone manually check whether the screenshots collected are correct. Or you could introduce some exploratory testing to do that and cover this by humans. But all these other approaches are not feasible if you release multiple times a day. And I know a couple of companies and some customers where they are deploying a couple of times a day into the production, and sometimes even deploying only a couple of times a day into testing environment might be the same challenging as for those who are deploying into the production. So to do this automatically, you need to introduce some tool to compare this, and there are a couple, as I said, and I'll be talking and sharing with you some examples soon what we are building. But that's not the point here. What I would like to just stress out that some bugs which might be only visual might be super critical and important for the users, but are not catched by traditional test automation. Another example, when I was talking about some boosting your efficiency, imagine that you need to test this type of registration form. So there are plenty of fields you need to fill in, and then you need to check whether the validation works. And I could write this type of test in this way. So I built something like custom assert or custom keyword to validate basically two types of fields. One is the field and another one is select. And I provide just ID as a parameter to check each and every edit box or select box. Alternative approach to this would be that I just take a screenshot, keep it as an expected result. Sometimes we call it, or often we call it baseline. And then I would just compare that screenshot with the actual one. So I could remove 12 lines of code and forget about any maintenance in the future. So I even don't need to build this because the screenshot comparison would help and work. A third use case where visual testing might be useful is when you are testing some, I wouldn't say horrible, but I would rather use the term beautiful UI, where you have a lot of charts and some visual elements, which might be pretty challenging to test with traditional assets, because you could check whether the colors are there, you can check whether the width and height is basically the elements have the proper size, and so on. But it would be pretty code heavy to cover all these use cases or the features. So instead of that, you just take the screenshot and compare it with that expected baseline. So these are the 3 reasons why maybe visual testing might be useful for you. But let me also share with you why you shouldn't consider that, or why the skeptical part of our universe looking at this approach. So what might be the reason why not to consider visual testing? It might slow down your test execution. And I wouldn't say might, I would maybe use it will slow down your test execution. Because the comparison will require to take the screenshot, store it somewhere, compare it, and then you will get back the result. Many teams do not implement this properly and then often complain about the flakiness. So there is a risk that you don't succeed with this if you don't implement it properly. And I think the strongest reason why not to do that is the third one, because if you have some manual tests, this might be good enough to catch all the visual bugs. Sometimes manual tester might be blind and do not notice, especially during the regression testing, that some button is missing or something is shifted to right or left, or you cannot scroll into some certain area. But the most horrible bugs could be catched by manual testers if they are there. If you are running some tiny small changes frequently and you count only on test automation, then I believe visual testing is the must. But if you are running some manual exploratory or manual regression testing, then visual testing might not be the sexy topic for your test automation. Let me quickly show you how this could work. I will go through the demo where I'm using Wopi, but as I said, many other tools are out there. And if you would be interested, I could share some list with you. But let me show you first how you could see the results in the tool. We are building some UI to use it for comparison, and you might see here 2 screenshots. On the right side, you could see the expected result, or we call it baseline, and on the left side, you could see the current image. You could see that there is a difference. Some pictures are loaded differently, and you can see also that this is reported to the users that with status unresolved and difference of 11% of the picture. And if I would just analyze the picture, I can move around, I can zoom in and zoom out and see all the details. But in this case, it's obvious. The picture is in a gallery is different. So what I could do, I could just quickly compare and see what is different. And you can see that not only the pictures, but also the moving video down in the second part of the screen is different. And why this might be useful, sometimes the visual bugs are really tiny. And if you're running heavily your regression test, you might miss these. So sometimes it's useful to use some automation for the visual testing. And for that, in Robot Framework, there are a couple of options what we offer, and I believe other vendors as well. You just install some pip package, set up your config file, and you run your tests. There are 2 approaches usually vendors and other providers follow. One is providing the listener. We sometimes call this approach semi-autonomous because you don't need to touch your code at all. You just set up in your configuration file what are the events, like if you click on button or if you fill some field, then the screenshot is taken. Or you could have like a library approach where you are using tracking keywords and adding them into your existing test cases. So how it could look like when you're running with listener, you are not touching your code. So you can see that this is the test case, typical test case for login. So you just enter the data into login, and then you are tracking whether someone clicked on any element. And whenever someone clicks on the element, we are capturing the screenshot and comparing it with the previous one. When you are running the keyword or library approach, then you just need to introduce the keyword into specific step or after the specific step where you want to check whether it works or not. Basically, in that step, the tool takes the screenshot and compare it against the expected result. Of course, then you are getting some results into standard log HTML file, and you can navigate from there into the tool for the comparing the screens. I also saw some comparison directly in the log from some other vendors, so that's also possible. In our case, there is a link. As I said, first run is just first screenshot, which you need to approve. Then the status is approved, and whenever you run, the comparison looks like this. And if there is no issue, then the status is okay. This is just very quick live demo of the same, but we basically run the run the test, and then getting the results. And if I go to our commander, you could see the test case there, including the step I checked. And for that, if I'm happy with the screenshot, I click on approve. And after approving, I'm ready for the second run. So when I'm running second time, the screenshot is already there. So what I'm doing, I now need to execute the test again. And after executing the test, I'm getting the second run. But in this case, if you would wait a bit here, then you could see that in this case, I'm comparing the screenshot again, the baseline. So I could see that there is no difference and everything is okay. So this is the second run. And then you can keep going and compare that. What happens when the screenshots are not the same? I was explaining that, so I'll skip it here and let's move on further. Just very quickly to the slide where you could see that many bugs might be found just by screenshot testing. So you do not need to write any sophisticated and heavy asserts. Let's move on to the third part. And this will be maybe most interesting or more exciting because this will be AI driven. And I would like to talk about autonomous interactions. So what this means. I'll start again with the challenge first. So interaction, how we could build this, how we could maintain this. If you are talking to any test automation engineer or test automation professionals, you might find a lot of complaints that it's not easy to find locators, or there is no time enough to build or work on the new test, or we spend too much on maintenance, or application change too often so we cannot maintain, and many others, and you would probably could add 10 more here. So basically, building automation or test automation is a programming task. But now, I was inspired by a couple of events last 2 or 3 years. Someone says that text is new programming language. So if we are talking about programming and text is the new programming language, then it might be easier because we all could write some standard English text, or we spend a couple of years in school to learn that. And let me show you what it's meant by that. This is AI Playground by Vercel, and they offer some functionality where you could compare various models. So if you want to write something in Robot Framework, you just ask LLM model, and you could get some nice response. I don't want to now assess whether the quality is good enough. The world is changing rapidly, and I believe now it's good enough. And I'll show you why I think this is good enough to use it in our test automation. Another inspiration for me was when I saw how easy it is to write a Gherkin code using Copilot and VS Code. So you could easily write your test cases. So if you are testing login, then this is the way how it works. You just start writing the scenario name, and you are getting all the suggestion. All this gray text is suggested by GitHub Copilot. And you just keep going and adding more and more steps. You could see that some steps are underlined, and the reason for this underlining is that the steps are not defined yet. But you could easily write the test even without you just tapping or pressing tab button to get all these scenarios. So it's super simple, and I felt like, okay, what would be next? How we could go even further? So let me share with you 2 prototypes or 2 ideas I was working on, LLM driven or powered. One is form filling. It's basically simple keyword where I'm not providing too much details, almost nothing, and I expect that something will happen. I will explain the details explain details soon. And the second one is BDD Copilot, where I was following this BDD structure and generating the instructions to Selenium or Playwright on the fly. Both are just prototypes to show you what we could build it and how easy it is. And you could introduce this into your use case. So first, let's start with the second last idea, and that's form filling on the fly. So imagine that you have this URL, this login form, and for that you would like to fill the form. And if you would go into the URL on the slide, you might find out that there is easy to log into the screen because I have, this is built just for the demo purposes. I have login name and the password might be any string, and the login name need to be email, which ends with @tesena.com. So I run this with, I build an autonomous form filling keyword, which basically grab the HTML, send it to LLM model, and get back some instruction what should be filled in. So I've got these instructions. And once I've got that, I was able to execute the test and look at the test execution. Nothing special is there. I just fill in the data and then sign in. And I was able to sign in, and you can see logout button on the right top corner. So I'm logged in. Then I took another login screen. This was source demo. And I run the same, and I've got completely different locators and test data. In this case, I was pushing not the entire HTML, or in both cases actually, but only HTML form. So in first case, the model was able to read from the form implementation what should be filled in. In this case, it was just guess. If I would send over to the LLM model entire HTML, the instructions are below, and then it would work. So in this case, I was able, again, just fill the data, but I was not able to pass login, and the reason is because I didn't provide right context. So I would need to provide the entire HTML, and then it would work. So just example side by side. The only change I did was the URL, and I was able to get the same results. So this is something which might help you to simplify the work with locators and even with some test data. So for instance, if you would need to use some specific data like provide me any Polish IBAN to fill in this field, you could build it on top of this idea, also this type of test data generator. But let me show you how this is built and how it works. There is no magic, but I like the term magic here. So what's the magic behind form filling? I just basically write some simple robot framework code. And if you are interested in that demo or in that prototype, I can share that with you. Just reach me out after the talk. So I had this code in robot framework. Basically, these were the tests. Then I had prompt that was template, which I will share with you soon. And then I just feed the template with my data and then ask via REST API, OpenAI for the instructions. And that's it. So the prompt looks like this. I'm a test engineer writing test in robot framework using browser library. I've opened the web page and it continues. But what I provided into the template was actually the HTML and then example how I would like to get the result back. These days, you could even go further, and instead of example in JSON, you can also provide some JSON schema, so you might be 100% sure that you are getting the proper and valid data. In a bigger example or in bigger project, I found that this is super simple prompt and need to be tweaked and expand, so I have much better prompt for the production use. But for this demo purposes, this is good enough to explain and share the idea with you. So this is how it works. And for the similar situation, I built something I called BDD Copilot. And basically, I had the keywords, which I didn't implement. I just let them implement by LLM. So I passed this keyword to the LLM, and these keywords were processed, and I've got different results for these different URL. Then we could see the same video how I could log in. In this case, I believe I shared the entire HTML, so I was able to pass through the login, but I will skip this because we are running out of time a bit. And same was for the Dronjo app. So I basically built the same, but a bit different approach by running BDD or Gherkin style. After this one, I will go back to the visual testing and assertions. This is a bit crazy slide because this is not following the flow of interaction, but I felt like, okay, I already explained all the LLM ideas behind. I explained how I integrate robot framework code with REST API provided by OpenAI. And I would like to show you something what I didn't prototype, but there is some more potential using LLM for assert. So let me just show you what we could do. I took this screenshot. This is WooCommerce. It's actually a module for WordPress where you could build your own e-commerce app. And there are some demo data. And I add to the shopping cart just 2 products. And these 2 products are in the shopping cart with all the details. And it's in Slovak. Actually, I'm Slovak, so this is with Slovak localization. And what I did, I upload this to the OpenAI, and then I ask how many products are in the cart. And I've got the answer 2. And I also ask what's the amount of the order. And you could get these data from the screenshot. So this is still just very raw idea, but what you could do with the prompts and text, you could do also with images. Another example I was playing with was that I uploaded 2 screenshots. One was expected and the second one was actual result. And I asked what is the difference and whether there is some bug and what's the confidence of that LLM model that there is a bug. And I've got pretty nice result. So tweaking these ideas could bring us to another idea how we could boost our test automation, just integrating simple REST APIs. And if you are concerned about the costs or about the security, I'm now prototyping and building something locally, and I'm getting pretty interesting results. It's still a bit slow in compared to OpenAI REST API, but AI is coming to our local machines, so we don't need to be worried about that. But maybe I'm now just moving to my last slide, because that's about the summary, and now the statements maybe should be there. So let me just quickly summarize. I shared with you 7 ideas how you could boost or expand or enhance your efficiency in test automation. I start with very simple technical asserts which you could introduce across your testing scope or test cases. Then I move on to the visual assertions and visual testing, and I end up using pretty, at least for me, cool AI and LLM approaches where I integrate my code on the fly with REST API where I could prompt some LLM models. And this could be done also for, I would say, 10 more other options than not only OpenAI. So this was covered in my talk. And what I would like to add are just quick summary notes. Introducing simple asserts, technical asserts, might improve your coverage and coding efficiency. And it could still be robust and could be quick. These are still just technical asserts and are just quality signals. So you might say, okay, this is not good enough, but still it expands your coverage. If we are talking, or we were talking about the interaction with LLM, there are a couple of things you need to tweak, especially temperature, because you are getting different results. You probably need to store the results and not ask all the time the same queries on the fly to make the test more consistent and repeat the same what you test last time. You might fight with context windows because many times this is something what, especially my early prototypes failing on that when you have real world app then the HTML might be too big. So you need to somehow optimize the HTML, minimize it, and so on. Sometimes you could struggle which model to use. Actually, GPT 3.5 is, I think this era is over. We know that now, or a few weeks ago, there was a new model, 0110, introduced by OpenAI, but there is a lot of other models popping up from Meta. There is Mistral. There is Google Gemini, and a lot of other vendors are coming there. So which model to use? That's a tough question. Sometimes you need to follow your company policy they decide it already for you, so it might be easier. But a lot of going on there. And of course, as I said, sometimes you will need to tweak your prompts because it looks like prototype might look perfect, but when you start running it against the production, I mean the real world apps, you will need to tweak your prompts. At least that's my experience. So I hope I inspired you and you enjoy my talk. So that's my last slide. I would like to thank you joining me today, or us today. And I'm happy to discuss or answer your question if there are any. Thank you very much. Enjoy the rest of the conference and hopefully see you somewhere else. Thank you and bye.
Hello, Marcel. Thank you for
Hi.
joining us.
Thank you for having
great.
me. It's my pleasure to be with you here.
Great. Really nice to have you here. Everyone, make sure that you get your questions in, and we will put them to Marcel here. One that's a little bit probably on the latter part of your presentation. You mentioned there's a lot of models coming up right now, or available models that you could use. Do you, if someone just starts joining or starting to work with LLMs, are there any tips you can give on how to select the right, although that might be difficult, model to start with?
Yeah, actually, I wouldn't spend too much time on it. I found OpenAI API good enough, and the document, it's simple. It's just REST API calls, and you can just read the documentation, and you could get into that topic very quickly. The prices are also good. So I spend on my prototypes a couple of cents in euros. So it's maybe €1, €2 per month. So super cheap. And I was trying to compare other models, and I found a lot of people are doing that. But I don't see any reason for me, because this is just REST API call. And once there is a better model, but there is no like 3 times better model or something like that, because these companies are competing. So it's always popping up something, but I'm okay with OpenAI. But if you would be interested, I was delivering a couple of workshops in the past, and I was keep maintaining once like overview slide about it. And after, I don't know, 6 months, I gave up, because there are so many new models and so many changes that I said, okay, I'll update it today, but tomorrow it will be outdated already. But there is one nice website for that. If you would like to explore that, I could share it maybe in chat or somewhere. There is, it's called artificialanalysis.ai. I don't know whether we have any chance to share it with the audience, but that's the page where you could go, and they are usually updating it, or they are keeping up in hours with the recent updates. So I don't know whether there is any chance to share it with the audience, but it's artificialanalysis.ai. Yeah, that's the thing. So that would be my recommendation. Start simple, and if you want to just expand and orientate in that area of models, I will go here as a starting point and search there for the models. There are prices, quality of model, speed, a lot of various parameters you could get from there. and see which model might work for you. So this is one thing, and I don't know whether you noticed, but Claude, or yeah, they call Claude, or Anthropic is the company. They announced pretty interesting new model to control our computers. So maybe that's the new era of automation. So not only we are now working with a lot of text and images, but they are announcing something new. So that's another nice move or interesting move.
Indeed it is. We've got another question coming in. Let me quickly see. Someone is, or Adrian is facing some issues with testing on multiple different types, type of or version of browsers using visual testing. How would, in this case, there are some minor graphical artifacts or anti-aliasing. How would you approach such issues?
Yeah, this is typical, like a reason why people are giving up with visual testing, because sometimes it's super flaky and unstable. And I'm trying to address this by applying proper good practice, which means sometimes you need to stabilize in this case, it's not about the test data, but sometimes it's due to test data. In this case, you need to set up your environment properly. And to do so, you need to follow a certain approach, like building all the setup in some containers, or having it even locally when you run it. You need to stabilize this. And the other approach might be that you are having some threshold set up. So you could say, I accept some small differences of the page. Some people don't like that approach. Then there could be some augmentation, but this is usually handled by the tools, that you have like not one picture, but you have a set of pictures, which might be augmented on the tool side, which means that you just move the picture a bit left and right. So you generate a couple of pictures on the back end. So the tool is able to distinguish whether this is a false positive situation or it's real bug. So there are a couple of options in that area. So I list a few of them.
Really nice. Thank you for the answer. This really helps. Good advice. I think we're out of time. So thank you a lot, Marcel, for joining in, for answering questions, and of course for your talk. And we hope to see you around somewhere else again.
Thank you.
And then
thank you very much. And I'll be now moving to that workspace, or what's that?
The speaker's corner
environment, and we'll stay there for 10 minutes or so. So if someone would like to join me to discuss something, I'm happy to talk to you there. Thank you very much.
Great. See you in Work Adventure in the speaker's corner. And I'm going to hand it over back to Chris for the next talk.
Thank you, and bye.
Bye.
Bye-bye.
Yeah. I also want to thank Marcel. This very interesting talk. And now the next session is actually a combined session. It's about co-working on an open source project. And we will have two recordings that we will start from the recording from Dave, who will explain what RFSwarm is. And then we have a video from Arek. He is helping Dave work with developing the RFSwarm project. So what it's all about, they will tell you just in a minute in the video.
Hi everyone, welcome to a presentation about RFSwarm. You might be wondering what RFSwarm is and why is it important. RFSwarm is a testing tool that allows you to use robot framework test cases for your performance and load testing. As you're probably well aware, robot framework is normally used for automated regression and functional testing. RFSwarm allows you to use these regression and functional tests to also use them for your performance testing. By doing this, it helps remove the duplication of effort between your automated regression test team and your performance testing team. RFSwarm can be used as a standalone application, or it can be integrated with your CI/CD pipeline. RFSwarm is written completely in Python. As such, the install process is the same as when you install Robot Framework or one of your Robot Framework libraries. So why did I create RFSwarm? I've worked for more than 15 years as a performance tester. I've used commercial tools such as LoadRunner and NeoLoad, as well as open source tools such as JMeter, Gatling and Grinder. Over the years, in many testing teams that I've worked in, I saw a massive duplication of effort between the test automation team and the performance testing team. I wanted to solve this problem and enable test teams to utilize the same scripting effort for the automated regression team and the performance testing team. My first attempt at resolving this issue was to create a framework that I called the stepping framework. This framework worked well for the customer that I was working for. It enabled them to reduce the performance testing scripting time significantly, and it enabled them to leverage the existing performance test cases that they had to enhance to build up their automated regression testing suite. It also then enabled them to have the automated regression team and the performance testing team work together. Unfortunately, this stepping framework was limited. It only worked with specific tools, and it only worked with a specific application. Over time, I discovered Robot Framework. I saw that Robot Framework did a much better job than my stepping framework. It was much easier to use, and it had many libraries which enabled it to work with many applications. So I decided to drop development of the stepping framework that I was working on and start using Robot Framework instead. My goals with RFSwarm was initially I wanted an application that was open source. As I'm a big believer in open source software, I believe it is great. I also wanted to make sure that I had a tool that didn't have limitations on what you can test based on what the licenses allowed you to do. This is something that's always been an issue for me in my performance testing with the commercial tools, is that when you hit the license limits, you can't then test further and find out what the limits of the application under test is. It was also important for me that the automation team and the performance testing team use the same scripting language. This not only reduces the duplication of effort, but it enables the teams to work together and coherently as a single team rather than as two separate teams under the same team leader. Also important to me was protocols, or libraries as they're called in Robot Framework. Most performance testing tools have a very limited suite of protocols that they can actually test, and so that limits what applications you can test. So with RFSwarm we can remove this limitation and basically test any application. Finally was reporting. LoadRunner as a commercial tool was the only one that really did reporting well out of all the performance testing tools. So I wanted a performance testing tool that actually did a good job of reporting. Whilst RFSwarm's reporting is not quite as good as LoadRunner's yet, I believe I've got a solid foundation for it, and it'll get there eventually. Where is RFSwarm at now? My initial goals for RFSwarm have basically been achieved. With Robot Framework's library structure, RFSwarm has support for many protocols, more than any other performance testing tool. The only protocols that other performance testing tools support that RFSwarm doesn't currently support are the Citrix ICA and the Microsoft Remote Desktop protocols. Maybe in the future we'll have libraries for these as well. RFSwarm has a reporting tool that was added in version 1 of RFSwarm. Initially the reporting tool is quite basic, but has been gradually getting better as I add more features, and it will continue to add more features to it over time. Hopefully someday it'll be as good or better than the best of the commercial performance testing tools. RFSwarm seems to have been well received. While I don't know exactly how many people use it, I have some sort of idea based on how many people download it from the py.org servers. And you can see the counts there in the slide. Everything in RFSwarm is currently done on a best effort basis in my free time. So what are the future plans for RFSwarm? Basically, as people can request new features for RFSwarm, I will continue to add features, and hopefully eventually RFSwarm will be as good as the commercial performance testing tools. Currently in the pipeline is desktop icons and a bunch of other features in the next feature release. Eventually I hope to add things like SLAs and comparison between test runs into the reporting tool. I would also like to add multiple language support into the UI, into the user interfaces of the RFSwarm Manager and RFSwarm Reporter. Currently it's only available in English. However, the reports generated from the reporter can be generated into any language that you choose. So it's only the user interface that you're using yourself that's in English, and your output and your test reports can be in any language you want. I eventually hope to make RFSwarm the preferred performance testing tool, not just based on price, but based on the features as well. I hope to get sponsorship or funding for the RFSwarm project so that I can provide weekly bug fixes as required and quarterly feature releases, and so that I can work on it full time. I also hope to get a full coverage of the application with the regression testing suite. Currently, NICE Project have allocated Arek, who is one of their interns, to help me on working on this. So I'd like to say a big thank you to NICE Project for Arek's help. What are the disadvantages of using RFSwarm? Currently, RFSwarm needs more hardware for generating a load than what the commercial tools do, especially when you're using the web, when you're testing for web. However, to offset this, the money you save on not buying licenses alone will buy the hardware that you need in order to run RFSwarm. As an example, the hardware to drive RFSwarm with 200 robots using the request library would be similar to what you would spend on 1 year of licenses for the web protocol in one of the commercial tools. However, the difference is that hardware you can keep for more than 5 years, so even still you would be saving money. Selenium library, or browser library, has about the same footprint and hardware requirements as using browser-based testing in the commercial tools. Reporting is not quite as good as the commercial tools yet in RFSwarm. However, it's already better than what is available in any of the other open source performance testing tools. With the reporting tool, you can generate Word, Excel, and HTML reports, and it has templates that you can use for predefining the report output before you even do the performance test. What are the advantages of using RFSwarm? Firstly, and most importantly, is the Robot Framework community and Robot Framework itself. Robot Framework has an awesome community of people all around the world who are very helpful and willing to help you resolve issues with with Robot Framework. Next is open source. The open source community worldwide is also really awesome. The other great thing about being open source is that the code is available, so anyone can find bugs, they can fix the bugs and submit a pull request, and bugs can be fixed much more quickly this way. Test scripts in Robot Framework are much easier to read than test scripts in other performance testing tools. Anyone who is an SME can easily read a Robot Framework test script and understand what is happening. This is not the case with other performance testing tools. Faster development of test scripts is also another great feature of Robot Framework. And in my own experience, I've found that developing a test script for performance testing with RFSwarm is much faster than developing test scripts of the same business processes in other performance testing tools. The test script development is also easier and requires less technical knowledge. You don't need to be able to program in C or some other old language that's not really used by anyone else anymore in order to write test cases for RFSwarm. You just need to be able to write a Robot Framework test case. Thank you for watching this presentation on RFSwarm. You might be wondering how you can contact me. The best place to start is the RFSwarm page on GitHub. On there you'll find documentation for RFSwarm. As well, you'll find links to the Discord channel where you can meet other people who are using RFSwarm, chat with them and get help. Also, you can find a link to the Slack channel on the Robot Framework Slack server. Again, here you can get help, further help for RFSwarm. I've also created a LinkedIn group for people who are using LinkedIn, who want to connect with other professionals who are also using RFSwarm. And finally, if you want to contact me about sponsorship or funding of the RFSwarm project, my email is there. Thank you.
Hello everyone, my name is Arkadiusz and I would like to welcome you to my presentation about RFSwarm project support by NICE project. About me, I am a QA intern at NICE project and I am working with Robot Framework for 1 year. Currently a second year student at the Wrocław University of Science and Technology. I have always been open to new experiences and learning new skills, so I'm delighted that I can participate in this contribution. I am still quite new to the Robot Framework community, but with each project I gain more and more knowledge and confidence, which allows me to create and optimize automated tests more effectively. How the contribution began. Our collaboration with Dave began at the end of March this year. The primary goals of this project were to create test cases for the user interface tools and resolving some bug fixes that will show up during testing process. My role in the project team was to support the developer mainly to implement regression tests that the developer came up with and other fields that would be required at the time. This allowed the developer to focus more on the application development. This collaboration project with RFSwarm developer was initiated by Adam Hepner and Jerzy Głowacki from NICE project, who were always there to help me and provide value advice, for which I am incredibly grateful. Regression testing. My main task was to help Dave with regression testing, which was designed to test the RFSwarm applications after making code changes into it. In order to ensure that no new defects have been created as a result of the changes, or that previously undetected defects had not manifested themselves in the unchanged part of the software. Currently, these tests are executed using GitHub runners as part of our automated workflows defined in GitHub Actions. The tests are run on all 3 operating systems, Windows, Linux, and macOS. In addition, we also run tests on Python versions from 3.9 to the latest 3.12 to ensure that the application runs perfectly on all platforms and supported Python versions. Currently, all applications of the RFSwarm project are being tested, i.e. Manager, Agent, and Reporter, which Manager containing the most tests as it is the most important part of the RFSwarm ecosystem. The test development process. The contribution is made from the NICE project fork via pull requests. The project management tool that we use for tracking tasks and progress is GitHub Issues. As the collaboration continued, the to-do list grew over time, and testing has now covered almost every aspect of the RFSwarm project, not only user interface. At this point, the RFSwarm application has many more tests than it did at the start of the collaboration, and making changes to the code are no longer uncertain as before. There are still things that require testing, but most of the fundamental areas are already covered. During the development of the tests, it was possible to find some bugs that caused the applications not to function correctly. These bugs were immediately fixed, and RFSwarm is now in better shape than before. The challenges during test development. One of the biggest challenges that I encountered was making all the tests work equally on all 3 platforms. There were situations where some tests did not work on one of the platforms, which required a special approach and often a change in the whole test architecture. However, the benefit of testing the RFSwarm application on all 3 platforms is so great that changing the entire test logic was simply worth it. The second challenge was to handling of user interface in tests. We are currently using the image horizon library, which clicks GUI elements using pre-saved images that reflect the thing being clicked. We plan to change this tool to Selenium or browser library in the future because these libraries have more tools and easier ways to click on items. This will be possible by the implementation of the Python im module, which allows for creating Electron-like offline HTML/JS GUI apps. The applications will then be usable with a better new interface, but tkinter will still be there as an emergency user interface. Collaboration with Dave. When I started working with Dave, I was still learning Robot Framework. This collaboration was also to teach me this powerful automation framework. Dave was an incredibly good teacher and was always there to give me some advice. He explained me all the things I have problem with in a clear and easy way. Thanks to this collaboration, I am much more familiar with the robot framework now, and I am happy with it. The collaboration with Dave has produced a lot of satisfying results, which I will talk about on the next slide. What was achieved and the result of the cooperation. During these 7 months, me and Dave were focused mainly on regression testing RFSwarm. At this point, around 150 different tests have been achieved, which actively ensure the quality of the RFSwarm project. In addition, we were able to fix errors that were related to the logic of the RFSwarm applications and some user interface bugs. Fixing these bugs has improved the stability of the RFSwarm applications and their performance. I was also happy to have been involved not only in the development of the regression tests, but also in solving application bugs. In this way, I was able to help the developer not only in testing, but also in actively developing the RFSwarm project. In addition, I was also able to improve my programming skills, which is very satisfying for me. We were able to release 3 new versions of RFSwarm during these 7 months, which mainly focused on bug fixes and testing, but also included new features. The 4th update we have been working on is still in development, and it is the largest of the rest. It is a major update, and I cannot wait for it to come out. The RFSwarm community is growing all the time, and I am extremely happy to be part of this project. In the future, we plan to continuously improve the existing regression tests and add new ones that should test areas that have not yet been covered, or newly added features. Our current tactic is to create the regression tests as soon as a new feature is added. There are still a few tests to be done, but the piece of the test development is currently satisfactory for me and the developer. Thank you for listening to my presentation. I hope you enjoyed it. Finally, I would like to say a big thank you to the NICE project for the opportunity to gain new knowledge, and to the Dave for his great help and teaching me during this project. Goodbye.
Okay, that was a great presentation. And here are Arek and Dave. Hi, guys.
Hello. Hi.
Hello.
Hi. Yeah, great presentation. Great. I'm astounded by the collaboration, because you, Dave, live in Brisbane, Australia, and Arek is in Wrocław in Poland. So it's literally the opposite side of the globe.
Yeah.
And the first question is, how do you organize the collaboration? How do you work together?
Yeah, it's pretty easy. We have a there's probably about 5 or 6 hours of overlap in the day for us, and so everything in RFSwarm's development is done with GitHub issues. So I raise the issues. So even if I know Arek is not online, I'll raise issues and I'll just send him a message on Slack, and he will look at it later. And then likewise, if he encounters something that he's not sure about, he will send me a message on Slack, and then I'll look at it in the morning when I wake up.
Yeah, the time zone wasn't really a big issue for us. We could easily communicate and work each other. So yeah, that's what we achieved.
So in the computer world, distance does not matter, and time
does not matter. No.
Yeah. In these times, it's not really matter. So.
Yeah. Okay, we have a question for Dave. Does RFSwarm also support being run on container platforms like Kubernetes?
There is a project by a lady called Esther. She's developing some Docker containers for RFSwarm. So at the moment she has a base container that has RFSwarm plus request library, and then she's got some other containers with the RFSwarm agent plus Selenium library, or with also browser library. But she's building more containers at the moment, and also she's planning to build a container for RFSwarm Manager. So yeah, yes, it does support running on containers. Basically, it'll run on any. It'll run if it runs on Windows, it runs on Linux, it runs on Mac OS. So any Windows or Linux container it will run on. And likewise, I've installed RFSwarm on containers on a Proxmox server. So on a Proxmox type container, was it LXD? I think it is the container that Proxmox uses. LXC containers. So yes, it runs on those as well. It's completely platform agnostic.
Okay. So a question to Arek. What were the most significant challenges you faced during the collaboration process, and how did you overcome them? What key lessons did you learn from working on the real-world project like RFSwarm?
So I mentioned on my presentation that the most hardest challenge to overcome is to make that test cases work on all 3 platforms. It was really sometimes hard to just make them work and make them do what they should do. So the second challenge that I actually didn't mention is the understanding the philosophy behind the test case architecture that they want to be respected. So we could easily cooperate with each other for one project, including these test cases. And maybe the third challenge that's also worth mentioning is the understanding of how the application really work in order to implement bug fixes to help dev with not only with regression tests, but also in the more advanced way. So what I have learned from this collaboration is how it really looks like, how the open source development actually work, the true nature of it. I was never really familiar with it, but thanks to this collaboration, I now feeling very confident at working on open source projects.
We have to proceed with our program. I could talk with you much longer, but yeah, we have a schedule that we have to follow. But you will be available at the speakers corner.
Yes.
Work Adventure. Yeah. So if anybody has more questions, you can ask Dave and Arek directly on the Work Adventure platform. Thank you, guys. It was a pleasure having you here.
Thank you too.
Okay.
It's nice
Thank
to
you.
be here. So.
And yeah, now it's time for the lunch break. There were some questions about the music that we play in the breaks. I just have an idea that the people that will fill out the survey after the event will get the recording as a thank you for filling the survey out. So now it's the time for the lunch break, and we'll be back at 1 p.m. with the keynote. 1 p.m., of course, Central European Summer Time. So see you back then.
testing's realm, where challenges reside. Robot framework emerged, a beacon by our side. Empowering with precision, its syntax guides the way. Logging every sway. Robot framework, you light our fire. With versatile syntax, taking us higher. Innovation blooms as we automate each day. Robot framework leads, showing the way. Amidst the code where complexities entwine, the robot framework shines, designed so fine. With libraries to hand, solutions we define. Test the line. Robot framework, you fuel our drive. With libraries abundant, helping us thrive. Innovation blooms as we navigate this maze. Robot framework empowers in so many ways. Through testings, trials, boldly we tread. With robot framework, no challenge fills with dread. From APIs to UI, test widespread. Our path ahead. Robot framework, you make us excel. With testing prowess, breaking every spell. Innovation bloom with every test we convey. Robot framework empowers day by day. In testing's realm, where challenges reside, robot framework emerged, a beacon by our side. Empowering with precision, its syntax guides the way. Logging every sway. Robot framework, you light our fire. With versatile syntax, taking us higher. Innovation blooms as we automate each day. Robot framework leads, showing the way. Amidst the code where complexities entwine, the robot framework shines, designed so fine. With libraries to hand, solutions we define. Test the line. Robot framework, you fuel our drive. With libraries abundant, helping us thrive. Innovation blooms as we navigate this maze. Robot framework empowers in so many ways. Through testings, trials, boldly we tread. With robot framework, no challenge fills with dread. From APIs to UI, test widespread. Our path ahead. Robot framework, you make us excel. With testing prowess, breaking every spell. Innovation bloom with every test we convey. Robot framework empowers day by day. In testing's realm, where challenges reside, robot framework emerged, a beacon by our side. Empowering with precision, its syntax guides the way. Logging every sway. Robot framework, you light our fire. With versatile syntax, taking us higher. Innovation blooms as we automate each day. Robot framework leads, showing the way. Amidst the code where complexities entwine, Robot framework shines, design so fine. With libraries to hand, solutions we define. Test the line. Robot framework, you fuel our drive. With libraries abundant, helping us thrive. Innovation blooms as we navigate this maze. Robot framework empowers in so many ways. Through testing trials, boldly we tread. With robot framework, no challenge fills with dread. APIs to UI, test widespread. Our path ahead. Robot framework, you make us excel. With testing prowess, breaking every spell. Innovation bloom with every test we convey. Robot framework empowers day by day. In testing's realm, where challenges reside, robot framework emerged, a beacon by our side, empowering with precision, its syntax guides the way, logging every sway. Robot framework, you light on our fire, with versatile syntax, taking us higher. Innovation blooms as we automate each day. Robot framework leads, showing the way. Amidst the code where complexities entwine, robot framework shines, design so fine. With libraries to hand, solutions we define. Test the line. Robot framework, you fuel our drive. With libraries abundant, helping us thrive. Innovation blooms as we navigate this maze. Robot framework empowers in so many ways. Through testing trials, boldly we tread. With robot framework, no challenge fills with dread. APIs to UI, test widespread. Our path ahead. Robot framework, you make us excel. With testing prowess, breaking every spell. Innovation bloom with every test we convey. Robot framework empowers day by day. In testing's realm, where challenges reside, robot framework emerged, a beacon by our side, empowering with precision, its syntax guides the way, logging every sway. Robot framework, you light on our fire, with versatile syntax, taking us higher. Innovation blooms as we automate each day. Robot framework leads, showing the way. Amidst the code where complexities entwine, robot framework shines, design so fine. With libraries to hand, solutions we define. Test the line. Robot framework, you fuel our drive. With libraries abundant, helping us thrive. Innovation blooms as we navigate this maze. Robot framework empowers in so many ways. Boldly we tread with robot framework. No challenge filled with dread. From APIs to UI, test widespread. Our path ahead. Robot framework, you make us excel with testing prowess, breaking every spell. Innovation bloom with every test we convey. Robot framework empowers day by day. In testing's realm, where challenges reside, robot framework emerged, a beacon by our side, empowering with precision, its syntax guides the way, logging every sway. Robot framework, you light on our fire, with versatile syntax, taking us higher. Innovation blooms as we automate each day. Robot framework leads, showing the way. Amidst the code where complexities entwine, the robot framework shines, designed so fine. With libraries to hand, solutions we define. Test the line. Robot framework, you fuel our drive. With libraries abundant, helping us thrive. Innovation blooms as we navigate this maze. Robot framework empowers in so many ways. Through testings, trials, boldly we tread. With robot framework, no challenge filled with dread. From APIs to UI, test widespread. Our path ahead. Robot framework, you make us excel with testing prowess, breaking every spell. Innovation bloom with every test we convey. Robot framework empowers day by day. In testing's realm, where challenges reside, robot framework emerged, a beacon by our side, empowering with precision, its syntax guides the way, logging every sway. Robot framework, you light on our fire, with versatile syntax, taking us higher. Innovation blooms as we automate each day. Robot framework leads, showing the way. Amidst the code where complexities entwine, the robot framework shines, designed so fine. With libraries to hand, solutions we define. Test the line. Robot framework, you fuel our drive. With libraries abundant, helping us thrive. Innovation blooms as we navigate this maze. Robot framework empowers in so many ways. Through testings, trials, boldly we tread. With robot framework, no challenge filled with dread. From APIs to UI, test widespread. Our path ahead. Robot framework, you make us excel with testing prowess, breaking every spell. Innovation bloom with every test we convey. Robot framework empowers day by day. testing's realm, where challenges reside. Robot framework emerged, a beacon by our side. Empowering with precision, its syntax guides the way. Longing every sway. Robot framework, you light on our fire. With versatile syntax, taking us higher. Innovation blooms as we automate each day. Robot framework leads, showing the way. Amidst the code where complexities entwine, the robot framework shines, designed so fine. With libraries to hand, solutions we define. Test the line. Robot framework, you fuel our drive. With libraries abundant, helping us thrive. Innovation blooms as we navigate this maze. Robot framework empowers in so many ways. Through testings, trials, boldly we tread. With robot framework, no challenge fills with dread. From APIs to UI, test widespread. Our path ahead. Robot framework, you make us excel. With testing prowess, breaking every spell. Innovation blue, with every test we convey. Robot framework empowers day by day. In testing's realm, where challenges reside, robot framework emerged, a beacon by our side. Empowering with precision, its syntax guides the way. Longing every sway. Robot framework, you light on our fire. With versatile syntax, taking us higher. Innovation blooms as we automate each day. Robot framework leads, showing the way. Amidst the code where complexities entwine, the robot framework shines, designed so fine. With libraries to hand, solutions we define. Test the line. Robot framework, you fuel our drive. With libraries abundant, helping us thrive. Innovation blooms as we navigate this maze. Robot framework empowers in so many ways. Through testings, trials, boldly we tread. With robot framework, no challenge fills with dread. From APIs to UI, test widespread. Our path ahead. Robot framework, you make us excel. With testing prowess, breaking every spell. Innovation blue, with every test we convey. Robot framework empowers day by day. In testing's realm, where challenges reside, robot framework emerged, a beacon by our side. Empowering with precision, its syntax guides the way. Longing every sway. Robot framework, you light on our fire. With versatile syntax, taking us higher. Innovation blooms as we automate each day. Robot framework leads, showing the way. Amidst the code where complexities entwine. The robot framework shines, designed so fine. With libraries to hand, solutions we define. Test the line. Robot framework, you fuel our drive. With libraries abundant, helping us thrive. Innovation blooms as we navigate this maze. Robot framework empowers in so many ways. Through testing trials, boldly we tread. With robot framework, no challenge fills with dread. From APIs to UI, test widespread. Our path ahead. Robot framework, you make us excel. With testing prowess, breaking every spell. Innovation bloom with every test we convey. Robot framework empowers day by day. In testing's realm, where challenges reside, robot framework emerged, a beacon by our side, empowering with precision, its syntax guides the way, logging every sway. Robot framework, you light on our fire, with versatile syntax, taking us higher. Innovation blooms as we automate each day. Robot framework leads, showing the way. Amidst the code where complexities entwine, the robot framework shines, designed so fine. With libraries to hand, solutions we define. Test the line. Robot framework, you fuel our drive. With libraries abundant, helping us thrive. Innovation blooms as we navigate this maze. Robot framework empowers in so many ways. Through testing's trials, boldly we tread. With robot framework, no challenge fills with dread. From APIs to UI, test widespread. Our path ahead. Robot framework, you make us excel. With testing prowess, breaking every spell. Innovation bloom with every test we convey. Robot framework empowers day by day. In testing's realm, where challenges reside, robot framework emerged, a beacon by our side, empowering with precision, its syntax guides the way, logging every sway. Robot framework, you light on our fire, with versatile syntax, taking us higher. Innovation blooms as we automate each day. Robot framework leads, showing the way. Amidst the code where complexities entwine, the robot framework shines, designed so fine. With libraries to hand, solutions we define. Test the line. Robot framework, you fuel our drive. With libraries abundant, helping us thrive. Innovation blooms as we navigate this maze. Robot framework empowers in so many ways. Boldly we tread with robot framework. No challenge fills with dread. From APIs to UI, test widespread. Our path ahead. Robot framework, you make us excel with testing prowess, breaking every spell. Innovation bloom with every test we convey. Robot framework empowers day by day. In testing's realm, where challenges reside, robot framework emerged, a beacon by our side, empowering with precision, its syntax guides the way, logging every sway. Robot framework, you light on our fire, with versatile syntax, taking us higher. Innovation blooms as we automate each day. Robot framework leads, showing the way. Amidst the code where complexities entwine, the robot framework shines, designed so fine. With libraries to hand, solutions we define. Test the line. Robot framework, you fuel our drive. With libraries abundant, helping us thrive. Innovation blooms as we navigate this maze. Robot framework empowers in so many ways. Through testing's trials, boldly we tread. With robot framework, no challenge fills with dread. From APIs to UI, test widespread. Our path ahead. Robot framework, you make us excel with testing prowess, breaking every spell. Innovation bloom with every test we convey. Robot framework empowers day by day. In testing's realm, where challenges reside, robot framework emerged, a beacon by our side, empowering with precision, its syntax guides the way, logging every sway. Robot framework, you light on our fire, with versatile syntax, taking us higher. Innovation blooms as we automate each day. Robot framework leads, showing the way. Amidst the code where complexities entwine, the robot framework shines, designed so fine. With libraries to hand, solutions we define. Test the line. Robot framework, you fuel our drive. With libraries abundant, helping us thrive. Innovation blooms as we navigate this maze. Robot framework empowers in so many ways. Through testing's trials, boldly we tread. With robot framework, no challenge fills with dread. From APIs to UI, test widespread. Our path ahead. Robot framework, you make us excel with testing prowess, breaking every spell. Innovation bloom with every test we convey. Robot framework empowers day by day. testing's realm, where challenges reside. Robot framework emerged, a beacon by our side. Empowering with precision, its syntax guides the way. Longing every sway. Robot framework, you light on our fire. With versatile syntax, taking us higher. Innovation blooms as we automate each day. Robot framework leads, showing the way. Amidst the code where complexities entwine, the robot framework shines, designed so fine. With libraries to hand, solutions we define. Test the line. Robot framework, you fuel our drive. With libraries abundant, helping us thrive. Innovation blooms as we navigate this maze. Robot framework empowers in so many ways. Through testings, trials, boldly we tread. With robot framework, no challenge fills with dread. From APIs to UI, test widespread. Our path ahead. Robot framework, you make us excel. With testing prowess, breaking every spell. Innovation bloom with every test we convey. Robot framework empowers day by day. In testing's realm, where challenges reside, robot framework emerged, a beacon by our side. Empowering with precision, its syntax guides the way. Longing every sway. Robot framework, you light on our fire. With versatile syntax, taking us higher. Innovation blooms as we automate each day. Robot framework leads, showing the way. Amidst the code where complexities entwine, the robot framework shines, designed so fine. With libraries to hand, solutions we define. Test the line. Robot framework, you fuel our drive. With libraries abundant, helping us thrive. Innovation blooms as we navigate this maze. Robot framework empowers in so many ways. Through testings, trials, boldly we tread. With robot framework, no challenge fills with dread. From APIs to UI, test widespread. Our path ahead. Robot framework, you make us excel. With testing prowess, breaking every spell. Innovation bloom with every test we convey. Robot framework empowers day by day. In testing's realm, where challenges reside, robot framework emerged, a beacon by our side. Empowering with precision, its syntax guides the way. Longing every sway. Robot framework, you light on our fire. With versatile syntax, taking us higher. Innovation blooms as we automate each day. Robot framework leads, showing the way. Amidst the code where complexities entwine, Robot framework shines, design so fine. With libraries to hand solutions we define. Test the line. Robot framework, you fuel our drive. With libraries abundant, helping us thrive. Innovation blooms as we navigate this maze. Robot framework empowers in so many ways. Through testings, trials, boldly we tread. With robot framework, no challenge fills with dread. From APIs to UI, test widespread. Our path ahead. Robot framework, you make us excel. With testing prowess, breaking every spell. Innovation blue with every test we convey. Robot framework empowers day by day. In testing's realm, where challenges reside, robot framework emerged, a beacon by our side, empowering with precision, its syntax guides the way, logging every sway. Robot framework, you light our fire, with versatile syntax, taking us higher. Innovation blooms as we automate each day. Robot framework leads, showing the way. Amidst the code where complexities entwine, robot framework shines, design so fine. With libraries to hand solutions we define. Test the line. Robot framework, you fuel our drive. With libraries abundant, helping us thrive. Innovation blooms as we navigate this maze. Robot framework empowers in so many ways. Through testings, trials, boldly we tread. With robot framework, no challenge fills with dread. From APIs to UI, test widespread. Our path ahead. Robot framework, you make us excel. With testing prowess, breaking every spell. Innovation blue with every test we convey. Robot framework empowers day by day. In testing's realm, where challenges reside, robot framework emerged, a beacon by our side, empowering with precision, its syntax guides the way, logging every sway. Robot framework, you light our fire, with versatile syntax, taking us higher. Innovation blooms as we automate each day. Robot framework leads, showing the way. Amidst the code where complexities entwine, the robot framework shines, design so fine. With libraries to hand solutions we define. Test the line. Robot framework, you fuel our drive. With libraries abundant, helping us thrive. Innovation blooms as we navigate this maze. Robot framework empowers in so many ways. framework, no challenge fills with dread. From APIs to UI, test widespread, our path ahead. Robot framework, you make us excel with testing prowess, breaking every spell. Innovation blue with every test we convey. Robot framework empowers day by day. Testing's realm, where challenges reside. Robot framework emerged, a beacon by our side. Empowering with precision, its syntax guides the way. Logging every sway. Robot framework, you light on our fire. With versatile syntax, taking us higher. Innovation blooms as we automate each day. Robot framework leads, showing the way. Amidst the code where complexities entwine, Robot framework shines, designed so fine. With libraries to hand, solutions we define. Test the line. Robot framework, you fuel our drive. With libraries abundant, helping us thrive. Innovation blooms as we navigate this maze. Robot framework empowers in so many ways. Through testing's trials, boldly we tread. With robot framework, no challenge fills with dread. From APIs to UI, test widespread, our path ahead. Robot framework, you make us excel. With testing prowess, breaking every spell. Innovation blue, with every test we convey. Robot framework empowers day by day. In testing's realm, where challenges reside, Robot framework emerged, a beacon by our side. Empowering with precision, its syntax guides the way. Logging every sway. Robot framework, you light on our fire. With versatile syntax, taking us higher. Innovation blooms as we automate each day. Robot framework leads, showing the way. Amidst the code where complexities entwine, Robot framework shines, designed so fine. With libraries to hand, solutions we define. Test the line. Robot framework, you fuel our drive. With libraries abundant, helping us thrive. Innovation blooms as we navigate this maze. Robot framework empowers in so many ways. Testing's trials, boldly we tread. With robot framework, no challenge fills with dread. From APIs to UI, test widespread, our path ahead. Robot framework, you make us excel. With testing prowess, breaking every spell. Innovation blue, with every test we convey. Robot framework empowers day by day. testing's realm, where challenges reside. Robot framework emerged, a beacon by our side, empowering with precision. Its syntax guides the way, logging every sway. Robot framework, you light our fire with versatile syntax, taking us higher. Innovation blooms as we automate each day. Robot framework leads, showing the way. Amidst the code where complexities entwine, the robot framework shines, designed so fine. With libraries to hand solutions we define. Test the line. Robot framework, you fuel our drive. With libraries abundant, helping us thrive. Innovation blooms as we navigate this maze. Robot framework empowers in so many ways. Through testing's trials, boldly we tread. With robot framework, no challenge fills with dread. From APIs to UI, test widespread. Our path ahead. Robot framework, you make us excel. With testing prowess, breaking every spell. Innovation.
And welcome back, everyone. The lunch break is over. We're moving on to the next talk, and the next talk is from Tariq King, and he will be presenting the automating quality vision beyond AI for testing. Have fun watching the video, and we'll have the Q&A afterwards.
Today, I hope to kind of get you into a space where you can go a little bit beyond our current way of thinking and where we're at. It's a very exciting time to be in testing, there's no doubt. And many of you are probably very familiar with the use of generative AI and large language models for doing software testing tasks. My name is Tariq King. I think mostly I'm just really in love with the software engineering and software testing disciplines and how we do this right. And I think it always resonates. I think if I go back to about 2015, I'm always the person that at various checkpoints starts to think about the future. And in 2015, I was doing just that, kind of thinking about what would be the future of software testing, what would it look like? I had been challenged to look for new and innovative ways to make software testing better. And the fact of the matter is that back then, our kind of insights on testing were that it really still continued to be quite of a manual endeavor. So whether you think about exploratory testing or human present testing, which is inherently something that humans need to be actively engaged in and involved in, hands to keyboard, or you even thought about automation, this was still the current state where there was still a lot of human effort required to actually create test scripts. The only thing automated was the execution. And at the time, I met a gentleman named Jason Arbin that had been also working and thinking about the software testing space and the future of it and how it could be kind of made better. And we formulated kind of a grand vision that we had at the time, could we have testing that was totally lights off when it comes to the philosophy of testing? So just like manufacturing, a lights out philosophy meant that you could turn off the lights in the factory and have everyone execute, and still the machines could continue running without the need for human intervention. And so we formulated that space at the time and started really pushing content on the use of AI for software testing. And these were kind of categorized into three buckets: AI-driven test automation, so building tools that would infuse AI into the actual tools themselves to give testing tools new capabilities. Different methods for testing AI systems. So of course you can't build something with AI in it and as a part of it without thinking about the reliability of the system itself and what needs to be done to validate the AI itself. And then a topic that was quite close to me, which is that the fact that because AI systems are very adaptive and they can change at runtime, we need to design the system with testing in mind, testing as part of the runtime, part of the architectural design. So that we kind of get to a space where we can do self-testing systems. And so at that time, after knowing Jason for some time, we got together and I joined his company, Test.ai, and we started working on really driving AI-driven testing across the board. And I was really fortunate at the time to be, number one, working with real AI in production for very large clients, as well as had an opportunity at O'Reilly to start publishing some of the work that we were doing. And it is really cool. Like if you stop to think about how AI can help software testing, there was a number of areas. We had real experience applying AI to the traditional core problems in testing that we always tend to start with typically when you think of automation. So UI-driven automation, how can we use AI to actually identify objects on the screen and click on things just like humans would and be resilient to change because of that computer vision aspect. The tests themselves were very reusable. So now we could not just test a single app in the App Store. We could think about testing domains of applications in addition to the entire App Store and running tests on all of the apps, which was pretty cool to do at a large scale. And also thinking about some specialized domains where you don't have as much automation capabilities as in others, right? Selenium isn't going to help you to automate your game unless your game is embedded in a web browser, specifically with a DOM. But computer vision and the use of reinforcement learning could help you to not only validate the game visually, but actually run through actual scenarios in the game and do testing. Still to this day, some of these projects are some of the best that I've ever worked on. And last but not least, another clearly hard problem is how do you validate video quality, especially for video streaming applications, right? So we saw that AI had the potential to transform and really make a difference in software testing. And we predicted like a bit of a takeover, that we would start to see initially some small pockets where you're using AI for UI testing and core things like API or even unit testing. But then as we were ourselves even doing our own investigation, we were starting to see its applicability across non-functional concerns or cross-cutting concerns, as we like to call them. So AI for performance testing, AI for UI design and usability, or to check trustworthiness and security. And so again, we were looking forward, thinking that this is something that could happen. And then also acknowledging that for this to happen, we need to make sure that the AI itself that is embedded as part of these frameworks or as part of these tools is itself self-testable, right? Because if you can make such dynamic decisions, there needs to be some guardrails. And even if initially at first the humans were involved in guiding the AI or making some corrections that would reinforcement learning feeding back into the system, eventually it would be able to take over some of these testing tasks and make that in a part of the self-testing loop. And so now fast forward like about a decade to 2024, and we've been living now in the era of generative AI, which similar to the adaptive nature of AI is very dynamic. And it's pretty cool to see now we have capabilities that had been there in part, but are now just booming and widespread. So now we have algorithms that can be used to generate natural language conversations, create different types of artistry like audio, images, even videos, and do so without much intervention from humans, right? So back to this lights out philosophy that we've been dreaming about for software testing. And last year I had a lot of fun with a couple of audiences. This year I'll have some more fun with them, but showing how AI can generate things that we can't tell the difference between the so-called imitation game. Like these are all photorealistic faces of people that do not exist, right? Completely AI generated using generative adversarial networks. And it goes beyond just faces. AI can generate artwork in the form of these paintings. Also, we can't tell the difference between the music it generates. It's clear to see that the capability is so very well refined at this point that we can't tell the difference, right? And of course, like the thing that kind of started a lot of it for many of us is ChatGPT and natural language generation using large language models. And I always tell people, like, the big win from a ChatGPT perspective, in addition to obviously the natural language itself, was that this was what was the turning point for really making AI very believable for many people. For many years, even at Test AI, like we would have people just asking us to show them the AI, because even though we showed them these cool capabilities, they really wanted to see and interact with it. And this is what ChatGPT really did for us, right? It made AI be something that we could interact with on a daily basis and have as a kind of permanent assistant day in and day out. It made AI very usable and understandable, and now we can do a lot more, right? And so it's no wonder that like we've been kind of focused on leveraging generative AI, and in particular those language generation capabilities for software testing. And there are several generative AI assisted testing activities and use cases that typically come out as part of this. The first one being test case development, design, and the creation of test cases. So whether it be analyzing requirements and generating tests that cover those requirements in terms of the functionality of the application, thinking about user acceptance tests, or looking at source code and design. So again, also from a more functional standpoint into more of an implementation base, we can now use this to generate complete test scripts, right? So no longer is it us taking test cases and manually typing them or translating them into like a machine readable form. Now AI can just do all that on its own, and then update them and evolve them as the application changes. Things like test planning and being an assistant there with documentation, using it for migration projects is always a good thing, where there's no documentation, and now we can reverse engineer much of that documentation, which leads us into just thinking about overall maintenance, right, and management of the testing process, whether it be test cases or looking for duplicate artifacts, whether it be tests or defects, and just simplifying the complexity of testing using generative AI. And of course, it's very good at mimicking things. So thinking about things like synthetic data, and one of the biggest problems is actually moving into a real world environment, right? And now having real data, and now we see that we've missed the mark on our software engineering efforts. And with synthetic data generation, we can now start to look at these complex real world data sets and generate synthetic data that looks and feels like real world data, but doesn't have a lot of the privacy and security issues that you would have using production data. And then last but not least, thinking about test execution, reporting, and so on and so forth. Of course, using predictive analytics to make sure that we can triage failures automatically, or just summarizing the vast quantity of bugs and logs that are out there, so that humans can actually ingest them and make smart decisions. And so this is our current state that we're in right now, where everyone is looking at all of these different use cases within testing, and it's quite exciting, right? But it's broader than that. Like when I actually look across the board, this is not just our discipline looking at this. This is across the board. Everyone who's doing anything in any domain is thinking about how can we use generative AI to help us become more productive, right? How can we get efficiency gains from it? And it's not just about spitting out things faster. You can always spit out artifacts faster. That doesn't mean that you have an overall productivity gain, but it's really threefold, right? It is that throughput, but coupled with the fact that you need to be producing meaningful artifacts, right? Otherwise, you're just going to have a lot of rework and wasted effort. which is just an overhead when it comes to cost efficiencies, right? So it is this quantity, quality, and efficiency game that brings us together for overall productivity. And this is where, like, when I start to think about everything that's happening in the testing space, really starts to translate into the overall life cycle. So, of course, anyone who knows anything about testing knows like testing is not this phase that happens at the end of the life cycle, but we need to be thinking holistically at every stage of development, right? And so a tester's concern is really one that flows from the inception of an idea to requirements engineering, all the way through designing the user interfaces, the architectural design, implementation, testing, and deployment until it gets into the hands of an end user or customer. And, you know, generative AI is very useful for helping with all of the above. It's very generally applicable. One thing I want to draw your attention to here that's very important, though, is understanding that when you embark on such a journey to try to transform the life cycle, you need to have a solid foundation of engineering practices, things like your agile practices, shifting left and paying attention to quality early, overall quality engineering, testing, CI/CD, etc. Like, it is not built on top of something that you can't measure, something that you can't baseline. So just understand that there's still a need for this foundational injects that needs to happen. And then these generative tools can actually give us an order of magnitude, in my opinion, of gains, right? But I'm going to just walk through the life cycle as we see it and how AI is helping. First thing, obviously, at the requirements end that you can think of is simply, generating user stories with acceptance criteria, right? And from a testing perspective and a testing mindset at first, it starts off with just thinking that, hey, you know what, we need to validate the requirements, right? Make sure we're building the right thing. Well, AI can actually help you up front to spit out the right things, right? If you feed it the right conversations that might be happening and you feed it the right data, let AI do the heavy lifting and actually generate those user stories for you and actually try to do a comparative analysis and fill the gaps itself. When it comes to the UI mockups and generative AI and all the generative adversarial networks and the progress there on photos, it's amazing at actually putting together an entire user experience, right? Being trained on what good user experiences look like. At EPAM, we do a lot of open source. I drove a lot of the open source projects when I first joined in the testing space. One such AI project is this AI Genie, which is really a plugin for Jira that helps you do generative AI tasks from within Jira related to user stories. So you can generate acceptance criteria in natural language, bring in your own large language model and configure it so it's completely free. And it can also generate sequence diagrams that represent those user stories to help you do requirements analysis and validation with customers. And the reason I mention this is because, like, number one, it's just cool to have these types of capabilities at our fingertips. But also, it is kind of indicative of how I see things unfolding. I see generative AI technologies coming into the tools and frameworks that people use on an everyday basis, right? So we're not trying to force some other tool down their throats, but wherever a particular role is living, that's where I would see AI starting to creep up and starting to be integrated into the life cycle. Similarly, for those who are more into the user design aspect of it, this is a commercial tool, so not open source. And but I came across it and I tried it out and I thought, man, this is pretty cool. So this cool tool called Wizard is basically like your one-stop shop with their new feature where you can use a single prompt, like say, hey, I want a weather app for planet Mars, click generate, and it starts to do all this magic. And you're right there after using this kind of auto designer capability, you're able to then go and edit these mockups or wireframes and so on and so forth and do your design, right? So you're, again, bringing AI into the world of the roles that are actually using them to do tasks and accelerating it that way, right? And this one in particular, like I really wish that I had something like this when I was in school doing software engineering. But thinking about software design, whether it be your sequence diagrams or state machine diagrams or any kind of architectural or deployment model, you can now use AI to generate, these models that, again, usually take quite a bit of time for anyone to actually define initially, and then are just infeasible for us to update as stuff goes on. So we know typically we end up saying, hey, you know what, the code is the only kind of source of truth, right? Because we really can't keep pace with all these artifacts. Well, now with AI behind the scenes, and this is a tool called Diagram GPT by eraser.io, literally, like, you start to write a description of the problem you're trying to solve. Here, I asked for a cloud architecture of a social media application similar to Instagram, and then told it what technologies like AWS, EC2 for compute, use S3 for storage, and then watch it start to just generate in front of me the architectural model, right? And again, saving a lot of time. And it actually doesn't matter if the AI got it 100% correct in terms of what was in my mind. Now I have something already that I can work with that took me very little time to actually create, and it's probably quicker for me to move those things around and edit this, or tell the AI like, hey, you got this part wrong, and guide it in the right direction, than to build this from scratch, right? So check it out, eraser.io, Diagram GPT, very cool tool for building these diagrams. I'm sure there are others. Of course, a lot started out thinking about GitHub Copilot, and so we aren't thinking about just IntelliSense to help us with method signatures, but entire code block generation, right? Using this, again, within the development environment, right? And in a similar way, at EPAM, we built a tool called Alita, which kind of has evolved, but it started off thinking about software testing and test automation and test engineers who are living, again, probably within the IDE and don't want to go into a separate chat window to generate code. They need it to live in the IDE. And so by having those capabilities actually just be there and being able to generate complete sets of automated test code within that same environment and then validate them and execute them, that was golden, right? So here we just generated a set of Java code for a program, and it really pulls a lot from the IDE. So it pulls from the project and says, hey, this is the language that we're using, right? This is the prompt. The prompt actually lives in the code itself and can evolve in the code. And you now have like all of these capabilities at your fingertips as you build test automation, right? Whether it be at the UI level, unit level, or integration level. This is a unit level example here. And then last but not least is thinking about the pipeline and CI/CD. And actually, it was this example. We have a group that has built a project called InfraPhoenix that leverages like our experience using and building CI/CD pipelines to use AI to accelerate that activity. So there's AI that's driving and executing and pushing out the Terraform code. There's AI that's analyzing the pull requests and the comments in the pull requests and so on and so forth. There's AI in the application code itself, right? Like similar to what we just talked about unit test generation or to explain portions of the code. And this is leading to AI actually becoming part of defining the quality gates, right? And handling issues within the pull requests and fixes themselves. So this particular aspect of it is what started to trigger for me the fact that we're definitely, number one, going beyond testing, even when we start to think about testing, because the ultimate thing that testing will do in a modern software development life cycle is actually try to automate these quality gates, right? So what are we really trying to do as we look at becoming more productive throughout the life cycle? We are typically saying like, yes, we want to push stuff out there faster through automation, but then quality becomes a key set of checkpoints, right? And so it reminds me of this mantra that we had at Ultimate Software, Q equals P, which stands for quality equals productivity. So what we're saying is that this is an equation, and at any point, if quality drops, then the other side of the equation is also impacted, and that also falls. Similarly, if quality goes up, then productivity also rises, right? And so what we're seeing, in my opinion, is that AI is actually automating quality engineering. And for some people, it sounds a little bit scary because they think of their jobs and what they're going to do. But this is not just singled out to one particular role. Remember, if you're thinking holistically about quality, you're talking about validation and verification at every single stage. And when we think about the life cycle and productivity, we're generating artifacts and generating content to help accelerate every single one of these activities and roles, everything from the product owner all the way through to actually testing and then deploying the product and doing DevOps, right? You know, it's one of those things where you can think about testing in a vacuum, but it just makes it harder to actually do validation. Instead, we typically tend to think of building quality into a product, and AI is really helping us to do that. But it does raise like a few challenges that are kind of new because of this technology. And this is where I think for the future of testers to start kind of focusing their minds on what comes next and how do they actually support the ongoing transition that we're going through. But you know, the first thing that comes to everyone's mind here is usually security. How can we make sure that we're using AI in a safe way? We're not leaking our own private information. And then what about the intellectual property upon which some of these models are trained when using LLMs or any of these pre-trained models? The second thing is that, like, we know already that it's very difficult to kind of really sometimes understand what these models are doing, and that goes down into making sure that you understand how to interact with the model and what types of things it might bring back, and doing that analysis. It's actually like a very experimental and testing type of mindset to be able to interact. And so there needs to be upskilling of engineering teams to understand exactly how to use this technology. So we'll talk about that, but that is definitely something that needs to happen. We also know that the models are fallible, right? Just as humans are. But sometimes, obviously if you give the wrong input, you get the wrong answer, but sometimes you can give correct inputs and it doesn't necessarily guarantee that you're going to get the correct answer. And so again, there needs to be some level of validation there. And then, you have a large quantity of information that's getting generated, and it can look correct to the untrained eye. But it can be very wrong. It can be something that was totally made up and it sounds very convincingly right. And last but not least, like actually measuring productivity, or if you use Q equals P, measuring quality in this case, is actually just non-trivial. And as I mentioned before, it's not just about faster output. And so where I see our trajectory kind of shifting is to really answering this question: is how do we successfully integrate generative AI for productivity, for quality into the life cycle, right? And actually, I find myself these days, this is kind of like the biggest thing that I'm engaged in right now with consulting, is to say to organizations, well, first and foremost, you can have secure, enterprise-ready AI. And I'll get back to the collaborative part of it in a second. But one thing that's pretty cool at EPAM is that one of our first initiatives around all this stuff was to recognize that we need to have this secure proxy in place, which we have a project called AI Dial that has been rolled out enterprise-wide and that we leverage. But with AI Dial, the principle is just the same of like, hey, you need to make sure that whatever models you're using and whatever information you're sending and transmitting stays within your four walls if you want to make sure that there's no leakage, right? And you can do that, right? You don't have to use a public API for OpenAI, for example, and send your data across the wire, right? You can have your own enterprise instance on Azure, or if you're using Gemini or Google, it doesn't really matter. The principle is like, let's have these secure models be available, right? And so I can log in and I can access Claude, Gemini, any one of the models that I care about. I can actually build things on top of them, and I can be rest assured that this is all within my infrastructure. So that's kind of ground zero. The other thing that we're seeing is that with like the Alita example that I showed you before within the IDE and doing test generation, it started to become less about testing and more about like the collaborative nature of working on prompts together, developing them, sharing them across the board, integrating them into different, the technology into different tools. And so Alita, instead of being kind of testing focused, has kind of grown into this AI collaboration platform where the secure models are behind the scenes and you're really enabling teams and organizations to work together to define the models that they need or customize the models that they need and build the tools that work for them. And so understand that, like, to me, like this secure, collaborative, enterprise-ready AI is sort of the first thing that I think I see, you know, as a testing community, we can help people navigate through because we're thinking about all those concerns from the get-go. All right, so I don't like when people kind of step into the hype of AI and lose some core values, right? Prompt engineering, I think when first started to kind of surface, was kind of purported as like, this is the future of your career path. Like, you know, in the future, we'll have all prompt engineers and da-da-da-da, and like get a degree in prompt engineering. I don't even know if such a thing exists, but maybe it does by now. But a lot of that is hype. And the truth of the matter is that this is a necessary skill, not because this becomes your new career, but because everyone is going to be using these models, and understanding like how you actually get good results from these models and how you interact with them is of key importance, right? It's just like any kind of discipline that requires some foundational things, like this is something that you have to bootstrap. And so me, myself, like I've seen that actually like going through the process of learning how to experiment and kind of build good prompts is more valuable than thinking that you have like a laundry list of like the 10 best prompts that you're just going to use, right? So we have to bring that inquisitive mind to you know, AI and generative AI in general to be able to achieve good results through prompting and prompt engineering. And this kind of led me down a path where I thought, like, you know what, this is so vital for the testing community. And while like I try my best to, in my trainings, kind of bring a lot of the practical side of things out there, I found a good opportunity to collaborate with Brightest and Artificial Intelligence United to actually build a certification that is primarily a hands-on certification. And that might sound like a oxymoron, but really there's over like 80 exercises in this certification. And that really help you to start to bring this towards something that you can use every day and iterate with. And the reason I kind of mention this is not necessarily to plug the certification. There's a big divide in our community about whether certifications are worth anything or not. For me personally, it was more of a, how do I help to influence and transform the space through teaching and training the trainers, right? And so my engagement here is really training a lot of people who are going to go out there and train others on how prompt engineering can really help, right? And of course, have fun in the process. Like I know both Jason Arbin and I have courses at these conferences on prompting, and they're very different in many ways, but also build on foundational principles. And last but not least, like in thinking about how to kind of navigate through the transformation to automating quality engineering, is understanding that like we're using AI to do all these things, but we need to make sure that we're in a space where we're validating and verifying the AI itself, right? And that's twofold. Number one, that's paying attention to how these models are built, how they're trained, and so on and so forth. And then also recognizing that once the model is deployed, that it can deviate or drift away from what you thought was happening. It can generate very you know, new and interesting things, and there needs to be a level of testing that happens post deployment in production, right? And so it really takes a village, right? And I think that the testing community is that village. where we recognize that whenever we're talking about quality, that it involves multiple roles and bringing multiple stakeholders together to actually achieve this, right? Especially if you're going to pay attention to quality early, thinking about end users or thinking about the engineering process, whether it be the AI components or the core development components, thinking about security and so on and so forth. And so there needs to be this kind of holistic kind of shift left to quality engineering for AI and machine learning. And then what do we do on the tail end, right? And this is where LLMs become rather interesting to validate. Obviously, these are non-deterministic machines, right? Where you ask a question and it can give you different answers, no matter if you ask a question now, you ask it later. So a big part of this is just looking at the fact that there's many layers to this. It's easy to look at the surface of the AI, but you really have to go deeper, right? And so this is a visual of the testing iceberg. I wrote a couple articles on testing AI. And the key here is that, hey, like, let's make sure that we're looking at all of these dimensions, whether or not the model is hallucinating, if it's coherent. There's a level of user engagement if you're building a conversational model that you need to make sure that you check for, and for fluency and how it's understanding your context. There's responsible aspects of the model, so security, privacy, safety. And then if you're using it for some tasks like testing or requirements engineering, how practically useful is it, right? How informative or concise is it with respect to what you're trying to achieve? And so, again, I think that this is a space where, as you start to think about the future of AI and the future of quality engineering, we have to think that there's a symbiotic relationship here, where as testers, we need to make sure that we can trust these models. For AI to be trustworthy, it must be something that we can test. And so testability of AI systems becomes a big thing. Of course, we need to be able to control the system to test it and observe it. But with AI, we also need to be able to explain, or have the AI explain why it came to certain decisions, right? And to me, these are all like wide open areas. If you start to think about the software lifecycle and what we mentioned before, if the AI can start taking over a lot of the tasks that we might be doing today manually, where does it leave us as experts in testing? And I think that this is where it leads us to. We understand how to pick apart and dissect things and look at where things might not be as they seem. And this area of explainable AI is just about that. Do we have explainable data, right? So what data did we use to train the model or fine tune it, right? What about the predictions? Can we look at the predictions and see like, hey, why did it come to certain conclusions? Which features contributed to, and weights contributed to this particular prediction? And then overall, the algorithms need to be explainable. And, you know, I think that as we, as a community, start to step into like what is happening to us and start to accept it, I think that we'll start to see that this is all good change. Of course, there's dangers, but we are starting to see that we're moving to this fully autonomous software development and testing, right? And of course, like you probably heard about Devon AI, there's some things there that were real, some things that were fake. I just saw a video the other day on Co-Tester. This is not an endorsement of that product, but talking about the fully autonomous software tester. The truth is that like there is a push towards having agents automate a lot of what has been done traditionally by software engineering and testing roles. And we've always had automation as part of life in general, and it changes the way that we do things. And really my vision here is that I think we're going to see much more of this. And I've been very fortunate to like work with people that are very like-minded in the sense that we see these things coming in waves, right? Like we started off with basic IntelliSense, right? And now we're seeing that there's a lot of co-pilots, right? Even look at the marketing for a new Windows PC, like it's all about co-pilots. But there's another wave that has already started. This is the wave where we're seeing like a big demand for, can we put more on the actual AI, right? Humans will still be in the loop, so there's humans with agents in this second wave, and as we have humans in this loop, it's all great because we are validating, we're verifying, but there will come a point. This is what always happens in AI, right? The first set of GANs that generated images were easy to spot that they weren't real, right? And now you can't hardly tell like what is real from what is fake. There comes a point where the AI can actually take over that task with enough human feedback. And so I think we're going to start to see agents with humans in software development, right? Which just means that the agents are the dominant and primary ones actually doing most of the work. And humans are kind of giving the oversight. And then full autonomy would mean that the agents are actually trusted to completely take over this task, right? And maybe even someday we have these autopoietic agents where when we start to think about self-organizing agents, or what happens with super intelligence beyond the scenes, becomes something that's interesting here to think about. But these are the waves, right? My buddy Adam Arbach and Artur Ziółkowski are working hard, like to think about like how the future will unfold using this technology, and it's pretty cool to kind of start to think that maybe the agents are going to take over, right? So to start rounding up, I think that no matter what, like we know that this technology is here to stay. We know it's more than testing, right? We've gone beyond testing at this point to look at the whole software development lifecycle. And we also know that there's going to be people out there using this for good, and there's going to be people kind of using this for not so good things, right? And so I think my encouragement as a community is to say, like, let's embrace the future. Let's not think that, like, just because things may change and job functions may change, that anything is going to stop this. But start thinking about what will make it successful. And really, the truth is that we need ethics frameworks around AI. We need to make sure it's transparent, it's responsible, there's enough governance, it is explainable. And this is where I think the testing community it really has like a core part to play in this, right? So I encourage you to think beyond that, because at least for me, it really boils down to the fact that I think of the future that my children are going to grow up in. They're already living with AI, and I want it to be something that really doesn't harm them and that really supports them as they are able to use it in whatever capacity it ends up being. So with that, I'll pause there and take any questions.
Thank you so much, Tariq, for your awesome presentation. Really nice to see also a little bit beyond what we're currently doing.
Thank you. Thanks for having me.
You're welcome. One question, you and I think David also, or I think it's been going on in all the talks. We're talking a lot about prompt engineering, and you have a little bit of a different approach to it than maybe we sometimes hear. Can we make a little bit of like a parallel between when like search engines like Google came, where you had to learn how to ask Google things? Is prompt engineering? Can you make a parallel between those two, or is that completely different?
Well, you can make somewhat of a parallel to this, right? I mean, even to this day, still sometimes my wife taps me on the shoulder saying she's looking for something on Google and she can't find it, and I can help her find it. But one thing you would have noticed as well, also in the early inception of search engines, compared to now, like the technology has advanced to a certain point, it's continued to get better. So now there's less and less of those requests. Of course, my mother probably will still tap me on the shoulder to find something for her. But there's a parallel there, yes. And I think as we continue to see the models become more improved, maybe the need for prompting or any kind of sophisticated prompting will actually be reduced. I mean, my approach to looking at prompt engineering is less about memorizing certain patterns and more about just being inquisitive about how the model responds, because these models are changing all of the time. I'm finding creative ways. I'm a very lazy person, so finding creative ways to get the model to set its own context. Why do I have to tell you everything? I can maybe ask you a question about a topic, see what you know, and leverage that in the conversation for the context, so that I can work less and the technology can work more for me. And so yeah, I know I approach it quite differently, but it is because of kind of how I see our technological kind of capabilities have evolved over the years in things like search.
Thank you. One other thing that came up, you are, and I hope a lot of people are, but you are very positive in how AI can develop, but you also mentioned that we need to do something for it. We need to make sure that it is used for good. Are there any specific things that you think we as also as a community should be doing about that?
For sure, and I like to describe my outlook as cautiously optimistic, right? I think as testers and test automation engineers and everything, we do have a very inquisitive mind, but we also do want to look for efficiencies. When I think of this particular community, the robot framework, and kind of what is developed there, you look at what has been kind of like a very general purpose framework for enabling test automation in many different levels, right? So I think there's a need for us to be able to have such a thing, because the big part about AI now is integration, right? And not, I mentioned it throughout here. Right now, like the current wave is like, let's put all these things in these different tools, and we're going to see that. That's our current state. However, I think more and more, when you start to look at how AI is pulling together the entire life cycle, there is a need, number one, for all of this to kind of converge into some command center, if you want to call it that, right? So that is one thing specifically for this community that I would encourage people to think about, because you all have actually pioneered a lot in that space. Obviously, the other big thing is, yes, everyone who has a testing mindset should be thinking about how do we make AI more aligned with our current values and ethics frameworks, AI fairness and safety, protecting our data, right? So, again, many things that this community probably could contribute to, but if I had to pick the top two, it would be those.
Interesting, yeah. What we also saw you have a lot of different aspects in the whole life cycle that AI can be applied to. I thought it was really interesting to see where it all went together. And you just mentioned something like converging to something like a control center. Is that something that will, do you think that will be around soonish, or is it already there? Or is it something that you think is really something for the future?
Yeah, I mean, I was just at a conference in Vancouver where, again, this was not planned. I gave a keynote speech, and the person that followed me also gave another keynote. And Mike, his keynote was actually more like a talk that I've given, including this one. It had threads of all this. And at the end of the day, it was the realization that AI is stepping into all of these, because of the general purpose nature of AI, it is stepping into all of these different functions and areas, right? However, if you think about it, right now we still need the experts, your product owners or your product analysts or your developers, to validate the generated content, but we also need to collaborate, right? So eventually it has to come into some, if we're going to just use it and consume it, it needs to be at least a common place where it can kind of be fed to everyone and go on through. I think it is something in the future, but I think it's going to be the near future, not the far future. I keep hearing people with these 5 and 10 year predictions of, of this stuff. And I'm like, no. We were 5 or 10 years ago, 10 years ago. This is a lot sooner now. So let's not go back into the mode that this is this much further out. So I think we're going to start seeing us move from this dissected AI in every tool to some folks trying to tackle that problem of bringing it into a single umbrella and single framework.
Thank you so much for your insights and the story that you give us. We are going to have another break for 10 minutes. And well, thank you so much, Tariq, for your insights. Thank you so much.
Yeah, again, thanks for having me, and enjoy the rest of the conference, folks.
Thank you.
Lines of code, we're writing a lake and debugging till our brains feel fried. But there's a tool that's pretty great, and a robot framework by our side. Automation's our salvation. Keywords make it all so clear. We're testing like robots tonight. Robot framework makes it alright. Python powered, easy to read, and test cases flow like melodies. From web to mobile, it succeeds, and cross-platform compatibilities. Automation's our salvation, and debugging to a breakthrough. What doesn't make run robot gain? Robot framework makes it alright. We're testing like robots tonight. Robot framework makes it alright. Selenium, API, and more. Who knew QA could be such a store? Python powered, easy to read. Test cases flow like melodies. From web to mobile, it succeeds, and cross-platform compatibilities. Automation's our salvation. Keywords make it all so clear. We're testing like robots tonight. Robot framework makes it alright. Selenium, API, and more. Who knew QA could be such a score? Morning's clean, results are green. Our code's the tightest that you've seen. No bug escapes, our robot's gaze. QA has never been this crazy. We're testing like robots all night long. Robot framework makes it alright. Song. So we'll feel API and more. Who knew QA could be such a score? Who knew QA could be such a score? Who knew QA could be such a score? Python powered, easy to read, and test cases flow like melodies. From web to mobile, it succeeds. OS platform compatibilities. We're testing like robots tonight. Robot framework makes it alright. Selenium, API, and more. Who knew QA could be such a score? Would be such a score? Our boarding's clean, results are green. Our code's the tightest that you've seen. No bug escapes, our robots gaze. QA has never been this crazy. We're testing like robots all night long. Robot framework makes it alright. Song. We're running clean, results are green. Our code's the tightest that you've seen. No bug escapes, our robots gaze. QA has never been this crazy. We're testing like robots all night long. Robot framework, you're our song. Lines of code, we're writing a lake and debugging till our brains feel fried. But there's a tool that's pretty great, and a robot framework by our side. Automation's our salvation. Keywords make it all so clear. We're testing like robots tonight. Robot framework makes it alright. So Selenium, API and more. New QA could be such a score. Python powered, easy to read, and test cases flow like melodies. From web to mobile, it succeeds, and cross-platform compatibilities. Automation's our salvation, and debugging till our brains feel. What doesn't make run but gain? Robot framework makes it alright. We're testing like robots tonight. Robot framework makes it alright. Selenium, API and more. New QA could be such a score. Python powered, easy to read. Test cases flow like melodies. From web to mobile, it succeeds, and cross-platform compatibilities. Automation's our salvation. Keywords make it all so clear. We're testing like robots tonight. Robot framework makes it alright. Selenium, API and more. New QA could be such a score. Voting's clean, results are green. Our code's the tightest that you've seen. No bug escapes our robot gaze. QA has never been this crazy. We're testing like robots all night long. Robot framework makes it alright. Song. So FEL, API and more. New QA could be such a score. New QA could be such a score. Oh, new QA could be such a score. Python powered, easy to read, and test cases flow like melodies. From web to mobile, it succeeds. OS platform compatibilities. We're testing like robots tonight. Robot framework makes it alright. Selenium, API and more. New QA could be such a score. Would be such a score. Reporting's clean, results are green. Our code's the tightest that you've seen. No bug escapes our robots gaze. QA has never been this crazy. We're testing like robots all night long. Robot framework makes it alright. Song. Reporting's clean, results are green. Our code's the tightest that you've seen. No bug escapes our robots gaze. QA has never been this crazy. We're testing like robots all night long. Robot framework, you're our song. Lines of code, we're writing a lake and debugging till our brains feel fried. But there's a tool that's pretty great, and a robot framework by our side. Automation's our salvation. Keywords make it all so clear. We're testing like robots tonight. Robot framework makes it alright. Selenium, API and more. New QA could be such a score. Python powered, easy to read, and test cases flow like melodies. From web to mobile, it succeeds, and cross-platform compatibilities. Automation's our salvation, and debugging till our brains feel. What doesn't make run but gain? Robot framework makes it alright. We're testing like robots tonight. Robot framework makes it alright. Selenium, API and more. New QA could be such a score. Python powered, easy to read. Test cases flow like melodies. From web to mobile, it succeeds, and cross-platform compatibilities. Automation's our salvation. like robots all night long. Robot framework makes it alright. Song. The web feel API and more. The new QA could be such a store. The new QA could be such a store. Oh, new QA could be such a store. Python powered, easy to read, and test cases full of melodies. From web to mobile.
Hi, welcome. After the break, now we'll have a session with Artur Ziółkowski about Scalable Test automated framework. And yeah, I just wanted to remind you that you can post your questions through the QA form. When you submit a question, the form gets minimized at the bottom left side of your screen. So you can find a rectangle with the minimized window there, and we can open it and ask another questions. And yeah, now we'll get started with the presentation from Artur.
Hi guys, my name is Artur Ziółkowski and I'm so excited to be a part of this Wrobocon conference in 2024, where I can share my knowledge around robot framework, which I gained over the years. Today, I would like to touch a difficult problem, which is creation scalable test automation framework. Kindly, I ask you to be open-minded because you will understand this presentation in different ways, depends who you are today on testing path. Before we dive into the presentation, a few words about me. I have been involved in QA automation testing since 2010. I starting from the Pythons. Corporation where I worked, after a few years, decided to create new products. So I was shifted to this new products where I start working with the robot frameworks. I'm starting creation the test framework from the scratch. So I will also start working as an architect for this automation needs. Today I'm working in our clients for the Nordic banks, where I am QA lead for 2 different products. At home, I am fan of IoT and I'm motorcyclist. At the beginning of my presentation, I would like to find the answer to why the frameworks are not scalable and what it means in my opinion. The not scalable frameworks is framework where we as a QAs, we have a problem with the maintenance, yeah, or even we have a problem with delivering features, yeah, that you spend the entire sprint to fighting with the coding, but at the end you can't deliver the test which is working, yeah. I divided this problem to 2 different small sub-problems. Like one of them is an organization level and second is a desk level. Yeah. After that, when we find the answer, in my opinion, why frameworks are not scalable, I would like to show you scaling levels for the drivers, interfaces, also the scaling on the drivers and products levels, which allow to me build different test environments in different companies, but based on the same backbones. Yeah. Like I mentioned at the beginning, it depends who you are and where you work today. If you work together with 1, 2 friends inside of small team, from the organization point of view, the main goal of your team is just deliver the feature. Yeah. But when we start talking about bigger projects, when we have 10, 20 different teams and they need to share the same environments, test framework environments itself also, they need to share the knowledge, yeah, and they need also the team can be involved in SIT testing or end-to-end testing to each other, yeah. So it's very important from the organization level that they need to share the same way of working, yeah. So these backbones, which I would like to present on this conference, allow to me multiply very similar test framework, which was shared at the end by the 9 different products with 15 plus different QAs. Yeah? So let's talk about why the framework is not scalable. So let's start from the organization level. Like I mentioned, when you work in a small team with few friends as a testers, and you have 3 testers inside of one team, probably everything can be handled by them, yeah, without any problems. All of the features, regressions, etc., etc. So all of team needs will be covered by them. Yeah. But when the organization or product or team is growing, new features added, new developers was hired, and new QAs comes to the team, we can hit the point where the team is a little bit too big to handle the normal stuff, because all of QAs deliver different codes, yeah? Because there is no any rules how they should cooperate. Of course, they share some kind of the knowledge, low-level drivers, to the open connections or log into the pages, etc., etc. But when you deep into the code, how they name it, the function, how they name it, the parameters, values, how they generated the values to check different combination is totally different, yeah, because the testers also have different knowledge. And the team is growing, so but the rules which was used by the QAs is still the same at the beginning. And this is a point in time when the QAs and the organization needs to start thinking about a little bit different about the automation. We should raise the hand to the organization that the way of working should be a little bit changed. For sure, or I'm almost sure, it's not comes from the top. Yeah, the higher management comes to the team and said, guys, okay, we have more QAs, let's create the framework which will be can be shared by the hundreds of people. Yeah, so the organization not treat our automation as a product, and this is a problem also for the different levels of the organization: product owner, scrum master, release manager, etc. No one knows at the beginning that the automation need to be somehow handled, because from all of point of view, from them of point of view, if you deliver the release, deliver the feature, you finish the sprint, and everything is green on the Q test and Jira, from them point of view, everything's work correctly. Yeah, but you can all of these releases from the testers can be big fight, like a war, to achieve the green regression, etc. Because the maintenance is very hard, because you have 10 different testers and you don't have any rules cooperation how they should share the code. So when you deep into the code, you can spot that all of this is created in different ways. Yeah? So from the team point of view, there will be, when we are growing, and there will be point in time when we as a testers should raise the hand to the higher management, to the scrum master, product owners, that the way of working of the automation need to be a little bit changed. Yeah, because if you don't think about it from the beginning and you spot these problems, and that you discover that entire automation is prepared in different ways, so probably you need to make the research, find the best options, and redesign the rest of them. Yeah, so we'll hit the wall in the point that some kind of redesign or maybe revamp or making from the scratch will be needed. Yeah. So let's go to the another level, which is the desk level. At the beginning, what I mean when I say desk level, I mean our desk. Yeah. So first of all, which we face and is a little bit blocker for us to make the automation a little in the bigger scale, is the time pressure. Yeah, when we have the planning, we're thinking about the feature with the compose to the stories. We always thinking about the shortest path to deliver the feature and automation for that. Yeah, we're not thinking about, okay, maybe this feature is very similar which we made in the past, so I need to make the research if something exists, etc. Maybe redesign current automation, and during that I will deliver my feature. Yeah, we think about, okay, the shortest path, I need to make this function, okay, I need to check this one, okay, few days. Yeah, but will be nice on the planning sessions to split our activities to 2 different stories, one for the development and test automation framework, and second for the execution, which increase the visibility of your activities. Yeah, because you can spend 2 days for the development, and in happy path you can spend 1 hour or 1 day to the execution, but also you can spend 2 weeks with the execution, because you try one, but you was blocked by the environment issue. You try in next week, and you spot the problems is with the microservice. So you raise the defect, but it's still on the, but your execution is still blocked. Another round, etc., etc., and it showed to the Scrum Master also how you split the jobs, how you split your work, how many time you spend on the development side, and how many time you spend on the execution. Yeah, this is something what I'm introduced in our teams, and this allowed to us to show to the higher management also how big problem for us is the execution part. Yeah, that we don't have a problem with the development, but in our case we was very often blocked by the environment, or other teams. Yeah. Also, the time pressure is another point that we agree to make the semi-automated or manual tests when we have the global decision that the entire product should go only for the automation. Yeah? And always manual is can be done in a few minutes if it's an easy feature. But if we allow to this way of working, it means that our depth of automation is start growing, and it will be very hard to find the time slot to refactor all of these depths and make the automation for them. Yeah. Second things, what I see on our desk level problems is that we are not thinking globally. Yeah. When we are reviewing the scripts, when we're reviewing the code, mostly people would like to create new one instead of create new one function instead of find existing one in the framework. Yeah? Even if someone make the research, yeah, and find very similar function which he needed, but with different API maybe, or maybe a little bit too much checking or something like that. Yeah. Instead of calls to the author of this function and review the code, make some kind of agreement, split the code, etc. Many people decide to create the script, decide the function from the scratch, which will fully fit for his needs. Yeah. But at the end, when you have 10 testers in your team and all of them make the same decisions, it means that you have 10 different functions checking very similar things, but 10 different functions, 10 different codes. So, like you see, you start having in one repository 10 different automation frameworks, yeah? Because all of them goes own path during the delivering of the feature. Yeah. And I see the last point, which is no layers, no borders in our automation. So it means that we are mixing everything into each other, like test data, so parameter naming, values generated with the system under test. So with users, password, links, ports, hosts, etc. Or we make the aliases for the same parameter. So when you have 10 different QAs in the product, all of them using different alias for the same parameter in databases. When you start reading the scripts and two different guys interactive with the same data, but the scripts from the code point of view is totally different. Yeah, but mostly they are doing the same stuff on the product. Yeah. Okay, so let's go to first level of how we build the scalable test automation framework. So let's talk about the drivers. Before we jump it, a few things what I mean the drivers here. So probably, as you know, we have in the robot framework, we have a Python at the bottom, and on the top of the Python, we have a robot framework, yeah? Which deliver his own libraries like built-in, collection, date and time, operation system, etc. All of these libraries which we use in daily stuff. Yeah? And you can fit the robot framework with the external libraries like robot framework Selenium, robot framework browsers, etc., etc. Doesn't matter. So for me, and after that, mostly of us use them directly in the suite or resources level. Yeah. For me, drivers is something between the robot framework and our scripts. Yeah. So, we talk about the drivers, for example, for the UIs. Yeah. UIs can be covered in our environments, in our test automation framework can be covered by the Playwright or via robot framework browsers or Selenium. Yeah? So we have a Python robot framework. On the top of the robot framework, we have our own Python code, and where we use directly the robot framework Selenium or robot framework browsers. And on top of the on top of our drivers, we have our test repository, where we keep the scripts and resources. The driver should be, but it can be stored as a Python code inside of the repository. But in my opinion, it's a better way to keep them as a separate libraries, separate package, which user can install by the pip command or via requirements file. When I'm building the drivers, I'm trying to use the robot framework drivers. Like when we're talking about the Selenium, when we create the drivers, we can just pick directly the Selenium or use the robot framework Selenium instances. I prefer use the second options because it allowed to me to keep all of the errors messages which I will raise to the scripts in the same common way as the entire robot framework doing that. Yeah. So it's nice to have it when you build the test automation framework in bigger scale to keep all of the errors, messages, and behavior in the same way. So even when I make the cross-check the values on the Python level, yeah, I'm not creating my own print that the value is not equal to each other. Yeah, I'm using the built-in, yeah, and should be equal, because the problems because the errors which will be so on the logs level will be the same and common to entire framework. Yeah, so I'm always, if the driver is existing in robot framework, or maybe package is existing in robot framework like Selenium, robot framework Selenium, I'm using that, yeah, and not directly the Selenium code. And if I make any verification, comparing the values, etc., I trying always using the robot framework libraries, because it allowed to me keep the same feeling to the entire framework, which is very important for me, for the beginners users. Yeah? When you have a new guys in the team, which is a junior, nice to have in the test automation framework all of the messages in the same way. Yeah, that when you're debugging this any problem with this framework, you have always the same message. Yeah. Okay. So when we this is the drivers for me. Yeah. So when we're talking about the drivers for the UI is one of our interfaces. We can have 100 of them. Yeah. SSH, Telnet, few different UIs for the same product. Yeah. REST API, SOAP, some kind of client interfaces, typing. Yeah. 100 of them. Yeah. So for all of them, you need to create driver between robot framework and your test repository. Yeah. I would like to present to you the drivers, how I create the scalable driver for UIs. Yeah. So let's briefly talk about how the drivers, how the UI automation is done in our industry. Mostly the QAs, when they start testing the UIs, they know how the POM and page object model, page object pattern works. They creating the modules for each view parts, where they share directly the comments and options from the Selenium. So you have some modules, and at the end you have a method from the Selenium. It's very hard to read such tests because, okay, you know where you are based on the submodules when you read them, but when you start reading the Selenium methods, it's very hard to understand what's going on, because you need to read XPath, map them somehow in your brain that this XPath is related to this parameter, okay, and this is a value. Yeah. So it's very hard to read. Of course, the maintenance, and of course, it works when on your viewport you have 5 parameters. But if you have 500, it will be very hard to maintenance also. Yeah. Second things, when the users have face the problem with with reading the code, they start implementing the dedicated functions for it to touch dedicated parameters. Yeah? So you can have the input username, get username, etc., etc. It also works. It's improved when you read the code, when you read the scripts, you know what's behind the scripts is going on. But like I mentioned, if you have a 500 parameters on one dedicated view part, I don't know how will you handle it. Yeah, and these 500 parameters can be changed every day. Yeah? You will change your scripts and it will be like never-ending story. Yeah. So I'm preparing. I'm a little bit change the POM page object model assumptions. I'm still basing on the submodules, but I'm a little bit extend this by delivering the static methods at the end of the submodules. Yeah. So I'm starting the CRUD. So this is driver UI via CRUD. And at the end of each submodules, I have always choose parameter, little params, navigate, delete, and update. Yeah, which allow to me give the common API to this driver. Yeah, this function is always have the same functions, the same API. Yeah, it's based on also on the CRUD, which is very similar as the REST API. Mostly today, our front ends. After our front ends, we have REST API, and we have some kind of backends here. So it also fit to such testing to compare front end with backend. And something what I get it also with this way of working with the UI driver is that it doesn't matter how complicated UI will be, yeah? How many submodules will be there. Yeah, I have always the same static methods, of course. Not all of the submodules need to have all of these methods. Yeah, maybe sometimes it will be just navigate and read all params. Yeah, but as a user, I just need to know the submodules path, and the method is always the same. The API, like I mentioned, for all of these methods is always the same. So the choose parameter from the green submodules to pink submodules is always the same. Yeah. So the driver works in the same way. How it works? It works that I'm using the API for this driver is everything what you see on the pages. So if you see parameter A, you need to provide to choose parameter name A, yeah, with some kind of the values. All of the mapping that the A is mapping to the dedicated X path is hard coded on the map on the driver. Yeah? Map can be a part of the driver or can be delivered as a separate package. It depends on the product. But all of the magic is behind the driver. Also, that the parameter A is an input text, not the multiply list or toggle, is also hard coded, or it can be under the map, which it can be external packages. It's also on the also is on the driver level. So at the end, when you leave the driver as a users, as a QA, you don't care about how it's mapped, what kind of parameters I would like to touch, etc. I just need to know the submodules, which I need to follow, and I need to know the parameter from the page, which as a user, I can just go to this page and read the parameters and value which I would like to choose. Yeah. So all of this magic is behind the driver. Of course, thousands of the questions here. Okay, parameter A today is the input text, but it should be multiply list. Yeah, all of these things is a separate testing. We can test the model for the UIs. Of course, if something will be changed here, the driver will be faced because I would like to input text, but today is a toggle. I will find these problems. Yeah, then I need to call to the architect and ask if this changes is correct one or not. If correct, change the driver level only, and all of the tests which use this parameter will be fixed. Yeah. Even if there will be new parameters added here, yeah, and you have a scenario where you don't need to touch this parameter, yeah, you don't need to change your scripts, yeah. If the submodules, how read all params work? Read all params works in that way that I am reading entire page, entire view part which you navigate, and I'm using inner HTML, so I'm reading entire HTML content and parsing them to the Python output. Yeah, I don't create a dedicated method. Okay, get text from parameter A, get text from parameter B, because it takes too much time. Yeah, and I have 500 parameters on the UI on the dedicated submodules. I would like to read all of them because it doesn't matter. Tester A would like to filter out some kind of data, but another tester will change will check another data. It doesn't matter from the code. Yeah, I just need to read everything from the page, map them to the object, and return to the scripts. Yeah, and the tester on the script level will filter out something what he's looking for, nothing more. Yeah. So briefly, this is how the driver level, which is pre-installed, need to be installed to the test automation framework, or can be keep also in the repository directly in the automation repository. But I prefer the options that will be stored as a separate package. And this way of working allowed to us to avoid any problems with the UIs. Yeah, and of course depends what kind of interfaces you have in your product. All of them need to be designed somehow in scalable format. Yeah. Of course, if there will be another submodule added as another feature, I need to create just another submodule, mostly copy paste the code from existing ones, because all of the operation is very common how we deal with them, and just create the mapping. Yeah, and map that parameter A is mapped to XPath. Or if you have any communication with the developers can deliver it as a separate map. Yeah. So we as a tester mostly we don't spend time to play with the Selenium RoboSerm or Selenium directly. Yeah, we just have the pattern of UI which can be very easily fit by the map, and map is related to parameter. Map is related to parameters which you see on the view parts. Yeah. Okay, so let's discuss next level, which is interfaces. As I mentioned, you can have multiple interfaces to your product, like SSH, Telnet, SOAP, REST API, UI, SNMP, etc., etc. Depends what kind of product do you have it. But mostly the split for the interfaces is related to the hardware, because when you have a hardware, the idea of the hardware is have it to more than one interface. Like let's imagine you have a router in your house. Yeah, and probably for your router you have a dedicated UI, but for sure there is also SSH. Yeah, and via SSH you can make the same operation as the UI. So this splitting and then the scaling on the interfaces level can be done in the products where you have a common API to the products, and all of the interfaces follow the same API. Yeah, so you need to have the product where you have a common API, and you have interfaces. Then you have a dedicated feature. You cover the feature via interfaces. Yeah, when the number of interfaces is growing, it's just obvious to be sure that you cover all of the system tests. You need to multiply this scenario for all of the dedicated interfaces. Yeah, so it's very easy to understand that when the number of features is growing, yeah, and we have a multiple interfaces to cover it, yeah, then there will be a lot of work. Yeah, I mentioned that it's mostly play with the hardware products, but it can be also with the pure software. Yeah, it's very easy to imagine that you have a product, and you have only one today. You have only one interface, which is UI. Yeah, but behind the UI you have a REST. Yeah, and your company faces the client who will ask for the REST and pay for the REST. Yeah, to get the access to REST API, and it's just obvious that company will deliver REST API to the customers, so we will have at least two interfaces, UI and REST API. So it can be very easily extended. Yeah, it depends mostly on the money. Yeah, and our customers. Yeah, but the hardware is more affected of that, because the hardwares are pretty almost have more than one interfaces, and they have common API. So you have a UI, you have a REST point, you have a netconf, SNMP, SSH, and dedicated CLI, and at the end, all of these interfaces cover the same features. Yeah? And it depends of your client. Different clients use different interfaces. Yeah. So you need to test all of them to be sure the feature can be handled by dedicated interfaces. Yeah. So based on this slide, you see there will be a lot of work, and you need a lot of hands to cover all of this. and if you spot any problems, maintenance, any refactor of the interfaces will be so painful, yeah, for the entire team. So it can be done in that way. Yeah, it's just obvious that when you have a different driver, different interfaces, you need to provide. You need to think about the common interfaces driver. Yeah, you can call these libraries depends of your product, etc. But at least you have a one common layer with adapters, where you have an interface, then you have an adapter. When you have an interface, then you have an interface driver. If you would like to test something dedicated to the driver, like I mentioned via when I talking about the UIs, then of course you need to have some kind of adapter because the operation need to be translated. And at the end you have another layer, which is interfaces layer, which result of this library will be deliver the common API to the scripts. Yeah. This allow to us to increase the coverage of our automation, and also reduce the number of work. Yeah. So because you don't need to be focused on the feature and speed them to the dedicated interfaces, you're just focusing only on the features, and what kind of interfaces you are using is just one of the parameters of this common interfaces driver. Yeah. So it's very easy to extend and increasing the automation here. Yeah. If you're thinking about it's very hard to do that, I can say it yes, but I have an experience with the driver, which contain just give me think. We had CLI, we have REST, we have netconf, and we implement the UI. Yeah, so for different interfaces, like you here, was zipped command under common interfaces driver with different adapters. And me as a tester, I just need to think about how to make the CRUD operation, and what I would and what kind of scenario I would like to test. And I just changing the interfaces naming on this common interfaces driver, and after that, different drivers was used. Yeah, so I just prepare one script which I run 4 times to cover all of the integration testing. Yeah. Okay, so let's go forward to next level, which is drivers. How to support multiple drivers in our repository. So, like you see on the screen, the orange code mostly is a Python. Yeah. Like let's briefly remind you: Python, robot framework, drivers, our drivers, and interfaces if we need it. Yeah. Then repository. Yeah. So how to deal with all of the drivers in our repository? That can be how to handle them. Yeah. And to not make a big big mess in our repository with all of the drivers. Yeah. So first of all, the red color is as our test repository. So I'm presenting the very basic layout, so scripts, libraries, resources, system under test, and tools. So on the resources level, I'm delivering something what I call the functional keywords, FK. All of the FK need to follow the interfaces. So if I have a UI interfaces, then I have a FK UI. If I have a CLI, I have a FK CLI, FK REST. So I make very similar layout, which mostly I'm mirroring my layouts from the drivers levels to the repository, because I would like to avoid situation that the testers need to go to 2,000 different web pages to read the documentation of the different drivers. Yeah. So I replace the method from the drivers on FK level, but of course with small improvements. Yeah, like on interfaces level probably have a when we're talking about the UI, I have open browsers, yeah, keywords, and another login to the page. Yeah. Then I'm zipping them together on FK level to create to build smaller blocks, yeah, like open and login, yeah, to the browsers, yeah, or like open browsers and login to UI, yeah. If we have a SSH or some kind of REST, it's follow the same rules, yeah. And mostly I'm following the CRUD comments, yeah. So the first layer which QAs can meet in test repository, I'm call them functional keywords, yeah. And this is a mirroring of my drivers, yeah, which allow to introduce the automation to the QAs without any dedicated robot framework documentation. Of course, all of these interfaces follow the robot framework standards, and we have a UIs when user can browse the driver content. Yeah, but mostly the method is so only when you combine the methods, it makes some kind of scenario. Yeah, so you can just easily zip few methods from the driver and reflect them on the functionality keywords. Yeah, like based on the UI, like open browser and login. Another one, navigate to somewhere and read all params, or even better, navigate somewhere and choose parameter to filter out some kind of data. Yeah, so you can zip keywords, few keywords to a little bit bigger scenario. Yeah. After that, I'm introduced generic keywords, which is a level up of the functional keywords. And the rules of the generic keywords inside of repository is that the generic keywords can use only functional keywords. So generic keywords can't use directly the drivers level. Yeah. So I'm building like a pyramid. Yeah, step by step. Python, robot framework, drivers, repository, functional keywords, generic keywords, and we're going to the roof. Yeah. So generic keywords use only functional keywords. Functional keywords use only the drivers. So when we're changing something on the drivers level, like API, naming of keywords, etc., I don't have a domino effects, yeah, because I need to change only on one layer. And this is a problem with the robot framework itself, yeah. Like when you have a spaghetti code with imports, which I saw to later on how to resolve them, and you make the refactor and move keywords to different places, rename them, etc., you'll start observing the domino effect that you start losing your passage on your regression because missing keywords, because the import is broken, etc., etc. These levels give to us the protection of any refactoring is missing. Yeah? So generic keywords is very similar idea of the functional keywords, but a little bit more complex. Yeah, because if the functional keywords can zip together, zip one functional keyword, zip two methods from the driver, so it means the generic keywords at least zip 4 methods from the drivers. Yeah, because use two different and use 2 keywords from the functional keywords. Yeah, so it's like a pyramid which is growing, and you start using one keywords which do a multiplied operation. Yeah, like on the generic keywords, you can have it like navigate to page, navigate to modules, choose parameter, then we have a filter out the data, read all params, and verify. Yeah. So you have one method which navigates you from the main pages to sub pages. You choose some kind of parameters, click filter out, and we are reading the data and verify the data which we see as the results. Yeah, where we use only one keyword. Yeah, from the automation point of view. Then GK keywords can be used on the scripts level. Yeah. So we have the scripts. After that, we have a GK, FK, and interface if we have it, and driver. Yeah. This is a pyramid of our framework. And this level, like FK and GK level, is next level how to be scaling drive and test automation framework. Yeah. And at the end, as a test automation guys, you at the end mostly spend the time building your scripts, because the generic keywords, FK keywords, are generated in common way of working, fully documented, and they share the same code on the Python level. So they are very easily to investigate it because, like I mentioned, all of the levels follow the interfaces. So you have a FK UI, GK UI. So if you would like to play with the UI on your script, you know where to find the answer, what kind of operation we can support it today. So if you spot there something is missing, okay, I need to go to the driver level and implement something on my end. Yeah, but the split by the FKGK, and they are following also for the interfaces. It's very easy to make this research, which I'm pointing at the beginning of the presentation. That is a problem why the framework is not scalable, because we are not browsing the repository and content of repository. And when we find something, we at the end decided to make it from scratch. In this way, there is no option to do that, yeah, because everything is fully visible by the other guys. And if you make redundancy of this very similar keywords, it can be very easily refactored, yeah. And of course, on the future level, maybe we need to play with few different interfaces, like do something via UI, check on the databases, etc., which is fully okay to combine such things operation on GK levels. Yeah, GK's level you can combine different keywords also. Yeah, from the same level. Yeah. At the end, I will show you the code with the UI driver, and I will explain you how to resolve the problem with the imports on Robot Framework. Okay? Because it's very hard to understand how it's work and find the way of working to avoid any problems with refactoring of the codes. Yeah. So like you see, in these cases, you're mostly focusing on the feature, implementing the features. If you spot if something is missing, you implement it in as a logical operation, like a few combination in one row. You need to implement a new GK. If you spot that the entire functionality is missing, you just go to the drivers and to the separate repository, implement the drivers, and implement the functional keywords for these missing pieces and GK. Then you reuse on the scripts level. But the main point here is that it's very easy to find what you are looking for. Yeah, you can be new guy in the organization, and you get the new feature. You know that you need to play with the REST and databases. It can be very easy to find what kind of a method we have it. Read the documentation on GK keywords, on FK keywords, which is prepared in the robot framework way of working. And you can very easily browse the repository and find the content which you are looking for and make the decision. Okay, there is nothing what I'm looking, so I need to implement something. Then you can go to your colleagues from your team and ask, okay, guys, looks like these elements, these pieces of this UI is missing. I'm correct? Yes. Go to the driver. Yeah. Okay. Current slide showed to us how to support and build the framework for the one dedicated product. Yeah, because there is no any place for the product. Because if you would like to play with different products, for sure there will be deviation between them. Yeah. Okay, they can share the same drivers, the same FKGK levels, but for sure there will be difference between the functionality and between the steps. Maybe the feature will be the same for both of them, but the order how they maybe call something will be different. Yeah, and for sure they will have a own. For sure they need to have their own space to at least naming something. Yeah. Because the same things can be named in different ways in different products, yeah. Because the customers is different, yeah. Let's talk about how to support multiple products here, yeah. So we have the same layout, the same presentation, but we need to make difference in the scripts level, yeah. So we need to deliver placeholder also on the resources place, yeah, because if you have a multiply products on the scripts level, they need to have their own keywords also, yeah, because they will utilize the GKFK in a little bit in different way, yeah. So we need to create the products keywords on top of the generic keywords, And this is like a sandbox for this dedicated product where they can make everything what they need, and different way of workings even, because the product can be tested in different ways. But it's a placeholder for them, yeah, where we don't touch at all how they name it and how this keywords looks like, etc. This is a safe spot for the products, because from the testing point of view, they need to have their own sandbox where they can do everything what they need to cover their needs, yeah. And for sure, their needs is not the common, it's not the same needs like the other products, yeah. And we can easily make these products more on this level, yeah. But all of them use GKFK level, yeah. Like on the screens. Like I mentioned, I had a repository where we had the 9 different products, yeah. They have all 9 different folders, and the one global rules here is that they need to use GK keywords, yeah, because this is the main rules for the products, yeah. Because if we allow them to use drivers levels on the products folder, yeah, then the result of this will be that for inside of the products we will start have different test automation framework, because they will sit only inside of the his product on his product folder, and contribute only inside of this folder, and making content only here. They will not go outside to make some kind of GKFK level. But when we have the rules that the product, if they deliver a new function or and they need to make the code, they need to create the GKFK maybe driver level, then they always going outside of the product. Then that test automation framework is growing. The next product maybe have the same feature after a few months, and the content how to test it is already there. So this is very important to remember about these levels, and the levels need to be executed one by one. You can't skip from the product directly to the drivers, yeah. You always products need to use GK, FK, FK drivers, yeah. Then you have based on this policy, you have as an owner of such test automation framework, you are almost pretty sure that when new things coming on the table, the guys working on that, they deliver something new pieces to the framework, yeah, and after that someone can reuse them, yeah. So this is how it can be split on the products levels, and at the end this is an organization level, yeah, where we have a full scalable test automation framework on each level. Products can use one or multiple interfaces, doesn't matter. But if, like, let's imagine that the product one not use the CLI, but after a few months, few years, customers decide, okay, we would like to have a CLI interface number 2 from this slide. All of the knowledge how to test operation are there, yeah. So they just need to sit and reuse it existing pieces, not making the automation from scratch, yeah. Also, like I mentioned, I'm done this test automation framework in few different companies based on the pure software, which is banking, also which is also on the hardware-centric products. So it can be done in multiple ways. But at the beginning, always you need to start thinking how to do that, yeah. And you need to sit to each other and thinking about how to make this test automation framework, not just the scripting, yeah, because the scripting of tests is working only in small scale when we're talking about 2-3 person in one team, yeah. When the team grows and there is more than 5, 7, 8, 10 people, it will be a problem, yeah. In this organization, when you base on this chart, based on this slide, you can see very easily that the people from product N+1 can be very easily shifted to product 1, because they share the knowledge of the drivers, way of working, how to document it, how we run the scripts. CI/CD is also the same. Entire automation is the same. So you can have multiple products and multiply users of this test automation framework. And if there is any needs, or even the product is canceled, you can easily try to find the places for QAs to in other teams, yeah, because they don't need to learn everything from the scratch, yeah, because everything is mostly very common, yeah. So at the end of this slide deck, I would like to say to you a few words that I ask you to remember. The first of them is treat interfaces as microservice, because it can grow every day. Yeah, if there will be any customer who pay more, there can be very easily extended. Yeah, it's just question how much. Second things, treat the test automation framework as a product. Reserve time to implement it. Reserve time to maintenance. Reserve time to make the research. It's not just a scripting. Yeah, you as a QAs should be involved to build something more, not just the scripting and make the regression green, because it's not the goal. Yeah, it's the goal from the organization point of view. But at the end, if you treat test results as a child of test automation framework, you will be as a test automation developer, and the test will be just a result, like a application working. Yeah. Okay. Now I would like to show you the code and a real example how I am implementing this in my projects. Yeah. So I would like to share with you the PyCharm with two different repositories. First of this repository is a repository as a Python code to support UI testing, which we call Demo QA. Demo QA is a very basic page to test some kind of iteration on testing different elements on the pages. So you can go to elements, text box, you can play with different data here, checkbox, etc., etc. So different combination of using Selenium or Playwright, yeah, doesn't matter. All of this driver is implemented in Scalable format, which I presented during the presentation. Let's jump briefly to the code. Like I mentioned, all of these methods based on the CRUD comments. So we have a navigate page, choose parameters, read all params. Sometimes I'm also delivering the read and verify all parameters because mostly when we are retrieving something from the pages, at the end we would like to verify some kind of the fields. Yeah, so I'm also delivering code here to avoid any should be equal on the robot framework level, yeah, because it doesn't matter. Yeah? When I mentioned during the presentation, it never doesn't matter if I'm playing on the Python level. I'm also, when I'm doing some kind of basic operation, I try to use the same methods which was delivered by robot framework. Like in these cases, like you see, to checking the values, I'm using built-in should be equal, because it's nice to have the entire automation, entire framework in the same taste. Yeah. So I'm not creating my own Python verification with my own print. Yeah. Because when I have the new guy in the team who know the robot framework, it's nice to have it that he will see the same error message. Yeah. So it allows to all of the QAs better understanding what's going on inside of the code and make the debugs. Yeah. So like I mentioned, all of these things is about the CRUD comment or CRUD way of working. The same the text box. Yeah. So you have a navigate, choose parameter, read all params, and read and verify all parameters. Of course, all of the mappings is done by the hard-coded map inside of data. Of course, the map can be hard-coded. Like in this case, can be stored as a separate libraries, also hard-coded, or delivered from the developers as a map. It depends what kind of the impact we have inside of our product and what we can achieve. Yeah. Okay. So based on the driver, let's take a look on the elements checkbox. Based on this, you can choose parameters, put here to choose any type of folder from here. Of course, there need always this CRUD way of working on the UI need to have some kind of assumptions. In this case, in the checkbox, when you go to the checkbox, I'm always expound all of the elements. Yeah, and after that, I'm choosing something. Yeah. Okay. So this is a driver which I would like to reuse on framework level. So let's jump to the testing repository. So it's a very basic repository, backbones, libraries, resources, scripts, suite, tools. I suppose most of the projects have the same or very similar structure. Libraries to placeholder to create the Python code here. Resources, this is what we would like to discuss. Scripts, SAT, system under test, place to keep the variables related to tested environment, tools, placeholder to create some kind of utilities around the automation or product. Yeah. Okay, so let's talk about the resources. Yeah. So like I presented on my during my presentation, I mentioned that the functional keywords is like a first level of the framework inside of testing repository. Yeah. So let's take a look how it looks. When I'm creating these levels, we need to have some kind of the rules. Yeah. So first rules regarding this framework and to build the scalable automation framework is that you need to have the place where you import some kind of libraries. Yeah? Because if you allow to testers to import anything what they need during the creation of the resources, at the end you will have the resources folder with thousands of different files, and you have spaghetti imports inside of this folder. And when you would like to refactor something, move keyword to another resources, etc., it will be very hard to understand. Yeah. So my first rules, which I'm creating when I'm creating the robot framework repository, is creating the handlers. This is my idea how I avoid the spaghetti code and problems with all of the imports inside of the robot framework. Like probably you know, when you're importing something, any type of resources in robot framework, you import like with the stars in the Python, you import everything what this resources imported also inside of these resources. Yeah. So you have access to all of different libraries. Yeah. So I'm creating inside of functional keywords. In this folder, I'm creating like the entrance to import all of the Python stuff which we need during the automation. Yeah. So this is a libs and variables handler where I'm importing all of the required libraries. And when I'm delivering new, because the new project is going to the automation repository or the project is growing, so we have a new UI, new interface, etc. I'm creating the Python code as a library, and at the end I'm importing this library here. Yeah. So this is like entrance to entire framework. Yeah. So for starting from the bottom, we have a Python. After that, you have a robot framework, something like robot framework Selenium. On top of the robot framework Selenium, you have your own driver. Then we are jumping to the repository and test automation repository. First level is a functional keywords, which contain resources, which is named libs and variables handler, where I'm importing all of these Python codes. Yeah? And this file is like a entrance to entire framework. Yeah? After that, I start preparing my FK resources. Like I mentioned, I'm always following the driver's name. So when I'm creating the demo QA driver, I also create the FK demo QA. It's allowed to me to avoid situation that the libraries have different naming and the resources have different naming, and I have a new guy in the team and explain how it works is very important. In these cases, all of the things have the same name, and you can just follow the naming, and it's very easy to jump deep to the code. Yeah. And like I mentioned, FK is a first basic resources where I implemented the same methods from the driver. Sometimes I'm creating a little bit bigger, so I zip two methods from the driver to a little bit bigger keywords. Like we have a keywords to open browsers, and we have navigate to page. Yeah? So I zip two keywords inside of one and create, of course, one keyword. Yeah? Like also checkbox, navigate to page. We always would like to navigate from the main page because we don't know where it was before the execution of this keyword. After that, navigate to elements and navigate to checkbox. So this small keywords zipping three unique methods from the different subclass from the driver. Yeah, and of course you can jump to. Sometimes it doesn't matter, and it's not fit to create like zipping, like choose parameters. I would like to just choose the parameters and maybe I don't want to verify them, so I'm not creating the choose parameter and reach and verify all parameters. But yeah, so this is a placeholder. when we have a new guy in the team and he have a new feature or task, okay, guy, you need to do something on the QA website, sorry, demo QA website. So there is a resources, everything what you need is here. Read the documentation and prepare the code. Yeah. Of course, when we take a look again on the functional keywords, yeah, we have this entrance, which is leaves and variables handler, but we also need to have the exit from this. And the exit is FK handler, where I'm importing all of the existing FK resources inside of this folder in one resources. Yeah. So this is exit from this layer. So when I would like go to another layer, which is generic keywords, and this generic keywords should base on the FK, not on the driver, directly just on the FK. We have the same way of working. We have the GK demo QA driver, and sorry, demo QA, where I just need to import the FK handler. Because when I'm importing FK handler, it means I'm importing the handler which contains everything what was created on FK level plus entire Python code. Yeah. So I'm importing one file to get all of these methods, resources which was delivered by the QA to the framework. Of course, there is another rules to avoid the duplication of the keywords of the naming, because when you importing entire automation resources, you will for sure will face the problem that the two different resources contain the same keywords with the same name. Yeah? So I'm always using the prefix. This is next rules in frameworks which I created. The prefixes need to be created, yeah, need to be added, because when I would like to refactor the keyword name and there is a double usage, double resources which contain the same keywords, and I don't have it there, and I don't see the prefix. So it means I need to go to these resources, take a look on the what kind of resources was imported here, and we are starting having the spaghetti code. Yeah? So the prefixes, in my opinion, is a mandatory, like we have in the Python codes. We are using the class that something. Yeah. So I suppose the prefixes should be mandatory at all in robot framework. Yeah. Okay. So the handlers, they are the exit from the dedicated level. We have a FK handler, and of course we follow the same rules on GK handler. So on GK handler, of course, I'm importing everything what I created on GK folder. So when I go to the product, which is not mandatory level, it depends if you have a multiple projects and we would like to share the automation. On the product keywords handler, I need to just import, sorry, when I'm creating the PK and keywords, I just need to import GK handler. Importing one file, I have access to all of the stuff which was made by the automation guys. Yeah. Okay, and of course we have the PK handler when I'm testing the dedicated product. Let's assume it's the product one, and I'm creating new suite. I just need to import the PK handler, and I have access to all of the methods which I created inside of my product, plus everything in this framework, plus to the drivers, etc., etc. There is no any problems with the imports, missing keywords, resources was moved somewhere, etc., etc. Yeah, of course, if you decided that this keyword should be used in GK level, yeah, you just remove from there. You can add here, and you just need to find all of this usage and just redesign it. Okay, FK, and you just change the name to GK, etc., etc. Yeah? So it's very easy to find the root cause of the changes if something is missing. Yeah? And of course, this way of working allows you to make any pre-commit for the automation, Robocop checks, etc., etc. Because when you import one script from and the script's importing GK handler, it's importing everything. If something is missing, you already know. Yeah? Okay. And so next things is a stud file, system under test, where the different products, different QAs can store the data related to the environments. Like the product one can use the UI demo QA on this address. Yeah? But it's very easy to imagine that we have a second product which have the same backbones of the UI, but with different data. Yeah. Like let's assume the choose parameters here is not the play Windows folder, but to play with the Linux folder. So we can have the same pages, but play with different test data. And then inside of the company, they will be stored as two separated links, separate instances. So the product 2 will have different UI address here. Project 1 have different. They can use the same GK and FK level for this UI, but they will use different instances and play with different test data. Okay, so something what I would like to left after this presentation. These backbones which I created, and the way of working with the robot framework on the resources level. You create the functional keyword, generic keywords, product keywords, and inside of these folders you are creating 4 different handlers. Lib handlers, FK handlers, GK handlers, and product keywords handlers. And at the end of the on the scripts level on the product, you are just importing the PK handler from dedicated products, and you have the access to entire framework. This way of working allowed to me to create the automation where we share 9 different products with 15 plus people. And we are this 9 different products. They was involved in one like streaming application one by one, so you will share the same tools, etc. During SIT. So I don't need to create new or very similar things to cover additional application which is behind me or before me. I'm just reusing the existing stuff from this existing team. So this is my way of working. While I'm creating new automation around the when I'm creating new automation framework and I'm choosing the robot framework, this is my backbones how I created these frameworks. And it allowed to me avoid any problems with the missing keywords, importing spaghetti code, missing variables, etc. Of course, all of these levels I add the README, so after the presentation you can check it. The READMEs I put here, I suppose all of them mandatory things which you need to know. Of course, also the entire code is stored in the GitHub based on when you find me based on my nickname. On the GitHub, you have access to both robot framework repository. One of them is a demo QA driver based on the testing UI based on the VIA-CRUD to cover these pages. And second one is a scalable test automation framework where I put entire backbones with the README files, etc. Okay, thank you very much for watching me so long. I know that it was a very tough presentation, and I'm very glad that I can share my knowledge how to build scalable automation framework, and I cross finger that you will reuse it in your products. If you have any question after the presentation, you can find me on the LinkedIn or via email. Thank you very much. See you.
All right, that was a very detailed presentation about building scalable test automation frameworks. And with us is Artur Ziółkowski. Hi, Artur.
Hi. Sorry if it was so long.
Yeah, no problem. And we have some questions. The first question is from Ed. Yeah. Hi, Ed. Nice that you are with us, as always. What is your deciding factor whether some functionality should be written with robot framework keyword or within Python code? For example, you put the drivers between robot framework and the test script. This would make the drivers to be robot framework keywords. Some of these could be in Python. So how you decide robot framework or Python?
Okay, good question. Of course, it depends on the project because it's very hard to imagine that there will be one global rules to apply it to all of these different companies and projects. But mostly, my rules which I'm using is that if I'm touching the interfaces itself, I'm trying to implement it that way that I'm not hard coding any values, data inside of any parameters. Inside of the drivers, all of the things need to be provided as API to these functions. So the idea of drivers is that they need to be pure code without any knowledge about the product itself. it means that if you follow these rules, then if another product will comes and will reuse the same interfaces, and you have a different naming, different parameters, different values, you can still use it, yeah. Because if you will start hard coding some kind of naming, etc. on the driver's level, it will be not reused by the others. Yeah, of course. Sometimes, like during UIs and creating the maps, for sure there will be a situation that you I'm getting the explanation during the presentation that you have this choose parameter between Windows and Linux files. Then can be the deviation between the products, and then need to be hard coded inside of the driver. Yeah, but overall, the idea is that when you're touching the driver itself, you are touching the interfaces or the product itself, you need to be as a driver. Yeah, then you escalate and populate these methods to the robot framework. Yeah.
Oh, okay. Yeah, sure. How does one help the end users, so the script writers, discover keywords within this model?
I suppose this way of working is very nice to jump when you have end users and new guys as a junior, or you get some kind replacement in your team. It's very easy to understand what's going on, yeah, because you have layers, which is very easy to understand, yeah, that you have layers of the framework. The resources follow the name, the same naming, just prefix is different. So even if you have a dedicated test cases which you need to cover or feature, and this feature is related to some kind of UI and databases, yeah. So it means there will be dedicated FKGK to this UI and DB. Of course, everything needs to be fully automated in a robot way of working on the FKGK level. And this way of working, that the entire touching these interfaces or the products is hidden behind the code and even is removed from the repository. Yeah, it's allowed to new guys to not just deep to this code, because they even doesn't know that it's existing. Yeah, they have a small part to visibility. Okay, you have resources folder, and in your first day of working, everything is here. Yeah, of course, if you are expert senior, you know how it's working. Yeah, but if you are beginner, that you are not know what's going on behind these resources, and this is very easy because it's self-explanatory because of the documentation, API, etc. Yeah.
Okay, and short last question: what plugins tools do you use within your PyCharm IDE?
Difference. I'm fan of IntelliBot. I know that it's dropped a few months ago or years even probably, but I still use it. So I'm using the IntelliBot mostly as a plugin for the robot framework. Yeah.
Okay. So yeah, thank you, Artur, for the presentation and from the Q&A session. If somebody has additional question, they can catch you in Work Adventure.
Yeah, of course, I will be there.
Okay. So thank you once again. Bye.
Thank you for this presentation. Thank you. Bye.
And so we will have a short break, about 10 minutes till 3:20 Central European Time, and then we'll have a presentation from Dirk Schweier. So see you then.
In testing's realm, where challenges reside, Robot framework emerged, a beacon by our side, empowering with precision, its syntax guides the way, logging every sway. Robot framework, you light on our fire, with versatile syntax, taking us higher. Innovation blooms as we automate each day. Robot framework leads, showing the way. Amidst the code where complexities entwine, the robot framework shines, designed so fine. With libraries to hand, solutions we define. Test the line. Robot framework, you fuel our drive with libraries abundant, helping us thrive. Innovation blooms as we navigate this maze. Robot framework empowers in so many ways. Through testings, trials, boldly we tread. With robot framework, no challenge fills with dread. From APIs to UI, test widespread. Our path ahead. Robot framework, you make us excel. With testing prowess, breaking every spell. Innovation bloom with every test we convey. Robot framework empowers day by day. In testing's realm, where challenges reside, robot framework emerged, a beacon by our side, empowering with precision, its syntax guides the way, logging every sway. Robot framework, you light on our fire, with versatile syntax, taking us higher. Innovation blooms as we automate each day. Robot framework leads, showing the way. Amidst the code where complexities entwine, the robot framework shines, designed so fine. With libraries to hand, solutions we define. Test the line. Robot framework, you fuel our drive. With libraries abundant, helping us thrive. Innovation blooms as we navigate this maze. Robot framework empowers in so many ways. Through testings, trials, boldly we tread. With robot framework, no challenge fills with dread. From APIs to UI, test widespread. Our path ahead. Robot framework, you make us excel. With testing prowess, breaking every spell. Innovation bloom with every test we convey. Robot framework empowers day by day. In testing's realm, where challenges reside, robot framework emerged, a beacon by our side, empowering with precision, its syntax guides the way, logging every sway. Robot framework, you light on our fire, with versatile syntax, taking us higher. Innovation blooms as we automate each day. Robot framework leads, showing the way. Amidst the code where complexities entwine, the robot framework shines, designed so fine. With libraries to hand, solutions we define. Test the line. Robot framework, you fuel our drive. With libraries abundant, helping us thrive. Innovation blooms as we navigate this maze. Robot framework empowers in so many ways. framework, no challenge fills with dread. From APIs to UI, test widespread, our path ahead. Robot framework, you make us excel with testing prowess, breaking every spell. Innovation bloom with every test we convey. Robot framework empowers day by day. In testing's realm, where challenges reside, robot framework emerged, a beacon by our side, empowering with precision, its syntax guides the way.
Welcome back, everyone. We are having time for the next talk, which is Dirk Schweier, with his talk, Support Agile Development with Generated Test Cases. So here we go.
Hello, everyone, and welcome to my presentation. I'm glad to be giving a presentation at this conference today. Before I go into the content of my presentation, I would like to briefly introduce myself. I've been working in various roles in software testing since 2003, and I've been advising clients as a freelancer since the beginning of 2023. My focus is on the following topics: test management, load and performance testing, and test automation. I joined the Robot Framework Foundation at the beginning of 2024 because I believe that the Robot Framework is a very attractive test execution tool. Most of the projects I work on involve agile teams. This means that testing activities need to be integrated into the sprint. If you have a look to the test activities according to the ISDQB, you may have to think about how to organize them in such a way that they can be processed inside the sprint. Testing activities, test design, and test implementation can be combined well if test automation is used, as the test implementation tool can only work with low-level test cases. So it is obsolete to design high-level test cases and transform them to low-level test cases. In test execution, we realize that automation is a popular way to save time and become faster. But there are two topics almost always on my mind. The first is, do I have enough time for test design? The development of test cases is often the part that takes up most time. Time could be saved in this part if test cases could be generated. And the second is, do I have enough time to maintain my test cases? We all know that the test cases from the current sprint usually run well and will pass. What about the test cases from last sprints? They may be outdated or need to be adapted due to new requirements, and changes to the interface, for example, can mean that keywords need to be adjusted so the changes are handled correctly. It is not uncommon that test automation in agile projects to fail at precisely this point, and for test cases to be added to the pile of technical debt. In my presentation, I would like to show an approach that I used to optimize the test work in the sprints, and thus also keep the maintenance of the test cases under control. One design method I believe is well suited to complex business rules is testing with decision tables. In the first part of the presentation, I would like to share my view of a decision table with you. In the second part, I will give an insight into how the decision table is prepared in order to be able to generate test cases. Afterwards, we then look at the test cases that result from the decision table. At the end, I will then summarize the presentation with the essential statements. So you might ask, why do I like to use decision tables? Well, I heard about decision tables for the first time in the Certified Tester Foundation Level seminar. I immediately liked the presentation and the possibility of developing test cases. The number of rules represents the number of test cases that need to be developed and executed. This metric is particularly interesting in the role of the test manager, as the test effort can easily be determined as a product of the number of rules and a standard factor for each test case. Usually, you have this when you're long enough on the project. In projects where decision tables are used in the requirement process, as a tester, I can use a simple formula to determine whether all combinations are covered or not. In practice, the decision table is very often incomplete and rules are missing. Well, this happens very often because the experts think that this particular rule cannot occur in practice, so they do not put it into the decision table. Another argument could be that the experts are not clear how should the system react, for example, with error handling. And from my point of view, it is very important that we also describe the error handling in decision tables completely, because this helps the developer most. Of course, I know the question of which tool should be used to develop the decision table. Those of you who work with common spreadsheet editors will soon realize that the decision tables quickly become very extensive. At the latest, when the decision table with all the rules does not fit on the screen, you lose track and often interest. And this was my experience as well. For this reason, I was glad that I became aware of LFET, a software from the LawThink company, a few years ago. LFET is essentially an editor that can be used to develop decision tables. In contrast to a spreadsheet editor, LFET can help you much more. For example, you can filter rules so that you have an overview and you can focus your thought to a special set of rules. Of course, LFET is able to find missing constellations, and they can be identified very quickly, but they can also give you the constellation, but LFET is not aware of how should be the behavior of the system. This must be given by you. And when you have all the rules in your table, you know from the seminar that you can also summarize rules when they are equal in some way. And this is also a feature where LFET might help you, and you can compactify your decision table as good as you can. So that we can look at low-level test cases later, I would like to introduce the example I will be working with in this presentation. This is a screenshot of LFET. In our application, we want to force the user to use a strong password. And the rule set is given in this decision table. A strong password should be 8 to 20 characters long. We assume that minimum 2 different lowercases should be included, and we want also the user to have 2 different capital letters inside the password, and he can choose whether 2 different digits or 2 different special characters. And in our decision table, you can see that rule 5 and 6 represents a constellation which is accepted as a strong password. All the other rules will describe that it violates the requirements and the application should respond an error message. In our case, we will see later, we assume that we have got a small microservice which we hand over the password and we get a response, an error message or a positive message if everything is correct in case rule 5 and 6. Before we can start with the preparation of our test cases, we have to think about a little bit what should the test case for the application look like. And the basic idea is we have 2 steps. The first test step is a password must be transferred to the application. For example, in rule 1, we will transfer a password which has less than 8 characters, and we expect that the service will return an error message because the length has to be minimum 8 characters, and we check if the expected result is like this. And when we talk about the rule 1, we have already identified the main ideas. So in a decision table, conditions are usually the input of the test system or describe how the input has to be. Sometimes we have got several conditions which consider together in order to determine a special value. In our example, we have got 5 conditions which must fulfill the parameter. The actions are usually represent the expected behavior of the test system. Test instructions behind condition and action values can be more than one call of a keyword, which in the case of Robot Framework are to be provided in the form of libraries or resource files. And we can see that we are now thinking in terms of conditions and action values rather than the rules, because the rule is just a combination of different action and condition values. If we store the test instructions in the appropriate places, then the generator only has to process rule by rule, and the test case is a list of test instructions defined for specific condition and action values. For each condition or action value, I can store different items in the decision table. First of all, the precondition. You might imagine that a rule with a special condition value should need a special precondition, for example, a login or something like this. So you can store the precondition, and every or all preconditions of one rule will be generated in a special keyword and will be the test setup of this test case. The second and the third is the test instruction and the expected result. The test instruction usually is what the tester has to do, and the expected result is what the tester has to check inside a test step. If we are working with test automation tools, I suggest that you only use test instruction or expected results. In my case, I prefer test instruction because when we talk about robot framework, we have got a keyword-based tool, and the result will be a list of keywords, and it doesn't matter whether it is a test instruction or expected result. And in the end, you will use keywords which has got good names, and if you have got a should be or something like this, then it is a check, and otherwise it is, for example, an instruction. And finally, you can also store post conditions. With post conditions, will be handled in the same way like the preconditions. You can add something what has to be done after the test case is run, and all keywords from all action or condition values will be generated in a special keyword as well, and this keyword will be called as the test teardown in your test case. In our case, it is a little bit complicated because our validate password, where we hand over the password, doesn't really fit to only one condition. It needs five conditions cover the requirements for our password. So in this case, we can use a central element, which is the intermediate step. The intermediate step in LFET, it could be understood as a test step which is between the condition block and the actions block. And the intermediate step is generated in each rule, so we can bring it in there. So now it's time to jump into LFET, where we can store our test instructions. And we start with our intermediate step. And here we have got our keyword, which is validate password. And we will see how to figure out the correct password. So in the first step, I would like to write down a to-do. That's it. And of course, we need a second keyword where we check the response code. But here we can see that we have got much more action values, and each action value needs a test instruction. So I start with the first one. And here I've got also the possibility to bring in a test instruction. And here we expect that the password is too short. So the response should contain the code. And the code is like the symbol we use here, so it should be len less than 8. So this is our instruction which we store right here. We have to do this for all the other error messages as well. And the additional thing we have to do is in our fifth action, we want that the password is correct. And in our case, we will not get an error code in this case. We just get no message. Unfortunately, there is a keyword for this, because we can use a keyword which is called response code could be equal. We can fill it right in here. We can say the response code count should be 0, because we expect that there is no should be equal. There is no error code in our answer. In order for Robot Framework to find the keywords when executing the test cases, we need to include them. In a Robot Framework file, you know that this is done in the settings area. In the precondition of our decision table, we can add special commands which will compile the settings area in our generated robot file. So if you want to fill instructions into the robot settings area, you have to use a keyword which is *robot settings. And when you fill in the keyword resource, and we have got now our keyword file included, then we have got our statement to bind our resource file. We would actually be finished now, but we have entered a fixed password with to-do. That is now used for every test case. This cannot work. The passwords required for each individual test case must fulfill between 1 and 5 conditions. LFET can use CSV files as test data. I can filter the test data using simple statements. For me, as a test analyst, this means that I have essentially to learn 3 things. First, what does a CSV file that can be used by LFET look like? Second, the test instruction for the condition and action values can be enriched with simple filter statements. And I have to insert a stub in the test statement where a concrete value is to be placed later on. Let's have a look to a CSV file for our example. In the first line of the CSV file, you can see the name, which the test data can be accessed later. In line 3, you see the headings for the individual columns. The column names are important so that a specific value can be addressed in conjunction with the name of the table. Since I only have simple comparison functions in LFET, I have defined the additional columns next to the password, which provide information about the number of different upper and lowercase letters, digits, and special characters in the password. Now I can store the filter instructions for the condition values in the decision table. I will use the password length as an example to illustrate this. The condition value less than 8 stands for a password with less than 8 characters. The filter instruction is made in 4 parts. The keyword table is used to signal LFET that the result should be a record set. Alternatively, you can use row, which means the record set should be reduced to one single data record. This is not the right one here because we will use more filter statements, and we have to filter down until we get the right password. The second position is the name for the record set, which can be named freely, but you are not allowed to use those names which are already in the tables. And what I do is I use plural form in my files. So you have seen passwords. And when I filter the first time, I filter into a record set and name it in a singular form. This helps me to understand whether I have filtered once or it is an additional filtering. So I use password for the record set. And I have to filter from my passwords, which is the table inside the file. And the fourth path is I can say the length should be less than 8. And this is my filter statement. And I have to add the filter statements for all the other condition values, but I think you can understand how to do this, and I have prepared it in the beginning inside my decision table. What we can do now is we can replace our to-do. So we go into our intermediate step, and here we can place a stub to say LFET that we want to see here a result from our table. So we use curly braces and we use an asterisk DTD for global test data, and the name of the table is password, and the name of the column is also password. So this is what we need to filter a single password from our table. And even if the generator will find more than one record in the record set, LFET will randomly choose one data set, and internally LFET will remember, okay, this data set, this data was already used, and in further test cases from this decision table, LFET will try to use a test data set which was not used in the test cases before. So it's time to generate the test cases and look at the result. While I now trigger the generation of the test cases manually, it is of course possible to start this test via a call with corresponding parameters. This means that LFET can also be integrated into a CI/CD pipeline. Generating the test cases immediately before the test cases are executed is particularly advantageous if the test cases are to match the current data in the test environment. In this case, the CSV file can be created as an export from the test environment's databases. This results in fewer failed test cases due to invalid test data. The result is a robot file with test cases. The settings area contains information on generation and the instructions used to reference libraries or resource files. We remember that we included just one resource, which is placed here. The individual test cases can be found under the section Test Cases. The name of a test case is always the consecutive number and the name of the decision table. So in our example, it is, for example, 0001, and password check is the name of the decision table. In addition to the keywords, you see we have got 2 in our test case. You can also see the documentation. And in the documentation, you can see which rule is represented and also which conditions were used to generate this test case. For example, here you can see our first test case is a test case which has got a password with less than 8 characters. Or, for example, our last one has rule number 7, and here we have got a password with more than 20 characters, and you can see the password is very long. Now, I can execute all the test cases here, and you can see in the console that the test cases are executed and they are passed. The result can also be seen in our result file, and you can see here easily all tests were run, and we have got 7 tests and 7 paths, and you can see the name of the test suite also in our report. So we see we generated the test cases, we can run the test cases, so we have got a robot file which is ready for execution. Oh, by the way, there is a constellation in this decision table that cannot be tested. Have anyone of you discovered it? Well, let's have a look to rule number 1. If I say I would like to have a password which has less than 8 characters, and I would like to have 2 or more different lowercase letters and 2 or more uppercase, 2 or more digits, and 2 or more special characters. In this case, we will not find any password, because here we can see we have got 2, 4, 6, 8 characters. So if we fulfill condition 2 to 5, we have 8 characters minimum, and this is a contradiction to condition 1 that we would like to have a password with less than 8 characters. This contradiction could not be recognized by LFET because LFET doesn't know that these 5 conditions depend each other. But what LFET can do for you is we see that now rules are missing, and I can check. LFET says 15 rules are missing. This means combinations, and LFET is able to add all the rules, but but LFET also compactifies the rules. So when we let him to fill them in, we see these rules are missing at the moment, and we can see that we get only the conditions, but we get not the actions, because LFET is not clever enough to know the expected behavior of our system under test. And of course, we can do this for LFET. Here we need the error message less than 8 characters. We have got less than 2 lowercase. Here we have got also less than 8, and we have got less than 2 uppercase. So here this is fine, and we have got the digits, but we have got also less than 8. Of course, this is an error message as well. Now this is our new decision table, and when we check this, then everything is nice. So LFET says everything okay. What we can do next is we just save and generate our test cases. And have a look to our generated test cases in our robot file, we can see that in our settings area, one error is documented. LFET was not able to find the password because the data set was an empty set. And when we follow the message, we have to scroll right. And there you can see first filtering was length. Afterwards, we have got 329 records left. Then low cases, another 91 records left. Go to the end. And then we look at the digits. We have still 2 records left. And then we filtered for the special characters, and there was 0 records left. So we have got an empty record set, and LFET is not able to generate our test case. And if we have a look to the test case, we can also see that this test case number 5 has got a tag which is called incomplete. So if you will have later a look to your test report, you will find out that you have got incomplete test cases, and these are those which we haven't any test data for. So it's easy to identify the issues, and it's easy to check whether it is a contradiction based on the conditions or it is missing test data in your environment. With today's presentation, I would like to convey the following key messages. Decision tables are a very good tool for documenting requirements. If I, as a tester, encounter the requirements in this form, then testing efforts can be estimated very well. You saw I can count the rules, or I can count the condition and action values to estimate the effort. Using suitable editors, I can ensure that the requirements are complete and free of contradiction. This is very important for me because I would like to have good requirements, and if the requirements are good, the developing is much more easier, the testing is much more easier, and can deliver everything in time inside our sprint. The usage of a generator reduces the effort of test design. You saw we can generate our test cases, and generating will help you to use the maintenance costs because the test cases are generated and you only have to look at the keywords. It enables the creation of low-level test cases immediately before test execution because you can integrate them into your CI/CD pipeline, and it enables the creation of low-level test cases to match the current database of the test environment. This is also important for me. If you have got, for example, different test stages with different test data inside. And test cases can be generated automated as a robot file directly. In my personal experience, I believe that the decision table is not used enough. In conjunction with LFET and keyword-based robot framework, we can generate better test cases just in time, and thus make a significant contribution to supporting our agile team. By integrating it into the CD/CD pipeline, developers get timely feedback during the sprint, and the team can ensure that the new increment is of good quality when it is delivered. Finally, I would like to thank the organizers for making the slot available for me. Many thanks also to you who listened to my presentation. I hope I was able to inspire you to see decision tables in a different light. I would like to talk to you during the breaks, which is not possible at an online conference. Sorry for that. For this reason, I'm including my contact details, and I would be delighted to talk to one or two of you. In any case, I hope you enjoy the following presentations at the Wrobocon. See you and goodbye.
Oh, welcome, Dirk, and very much thanks for your presentation and giving us some insights in decision trees and decision tables on how we can apply them to our test automation framework.
Yeah, thank you for the invitation.
One note to start with. In Work Adventure, we have the Speakers Corner, so if people have questions, they can go over there. Dirk, I presume you will also be there.
Yes, I will.
So if you have, your question didn't come up, head over after the talk or after the next talk to the Speakers Corner and see if you can find the speakers that you want to talk to. We do have some questions. So the first one, can this LFTE tool work directly with IDE tools like RobotCode, RobotTidy, and Robocop?
No, at the moment not. And I think it is not necessary because you've seen in the presentation that the result is a complete robot file. Of course, you might ask for syntax highlighting and code completion, which you have not seen in LFET so far. But it is also possible if you develop your test cases and your test instructions to drag and drop code snippets from your IDE to LFET, and afterwards you generate the whole robot file. But it could be an idea, and Harald Lorfing, the CEO of the Lorfing company, is also available at this conference, and I think he will also be in the Speakers Corner. You can talk to him, and maybe it's a new feature inside LFET.
Cool. Another question. With the generator, can you use placeholders and generate the test cases and then post-edit them in another IDE?
Oh, well, I'm not sure if I understand this right, this question. Of course, it is possible to grab the intermediate result and, for example, paste it into a special robot file if you want to do something like this. But I think it is not necessary to bring it to another IDE, because what I like mostly is that I integrate the generation of the test cases right into, for example, the Jenkins pipeline. If you use, for example, tools like Maven, you can directly generate with Maven the test cases from the decision table, and then there is no necessity to work with an IDE in between.
That sounds good. One thing that pops to mind for me is that I know that the data driver library immediately modifies the test specification objects in Robot Framework using the Listener v3 API.
Yeah.
To me, this sounds a little bit the same. You write it to a file and then it's being executed. Is it the same, or is it a completely different concept?
No, I would say it's different, because what we have is when we generate the file, you will have a static robot file. So you don't have any template code like in the data driver library. You can just pick the robot file as it is and use it as it is. So there will also be made no changes or nothing, no magic happens during the test execution like in the data driver library. And this is also interesting if you, for example, just work with LFET and generate some test cases, and you want to get rid of LFET somehow. I cannot imagine why, but the result is always a static robot file, so you don't lose any data or something like this. But for me, it's important that I don't want to maintain my test set. I just maintain my keywords based on the condition values and action values, and then I generate the whole test set, the whole set of test cases right in the moment I need them for execution.
Does that also mean that if you don't change your decision table, you don't need to generate your robot files again, so you can skip the generation step?
Yeah, you can do something like this, but on the other hand, keep in mind, if you generate, even if nothing has changed, you could imagine that in our example, for example, we use other passwords because randomly another password will be grabbed from the list. And this means over the time of your regression tests, you will test more and more passwords. But if you write your test case once, a concrete low-level test case, how many changes would you do in this robot file? No changes. So you will always test with, for example, ABC here. But if you generate time by time, then you also rotate your passwords, and you don't test always with ABC.
Yes, that makes a lot of sense, actually. Thank you a lot for answering the questions, for your presentation in general, of course. And well, I hope to see you in the speaker's corner. And for now, we'll have a short break until we have the last talk of today.
Thanks a lot. And see you in the speaker's corner. Bye.
Bye.
Where complexities entwine, robot framework shines, design so fine. With libraries to hand, solutions we define. Test the line. Robot framework, you fuel our drive. With libraries abundant, helping us thrive. Innovation blooms as we navigate this maze. Robot framework empowers in so many ways. Testing's trials, boldly we tread. With robot framework, no challenge fills with dread. From APIs to UI, test widespread. Our path ahead. Robot framework, you make us excel. With testing prowess, breaking every spell. Innovation bloom with every test we convey. Robot framework empowers day by day. In testing's realm, where challenges reside, robot framework emerged, a beacon by our side, empowering with precision. Its syntax guides the way, longing every sway. Robot framework, you light on our fire. With versatile syntax, taking us higher. Innovation blooms as we automate code where complexities entwine. The robot framework shines, designed so fine. With libraries to hand, solutions we define. Test the line. Robot framework, you fuel our drive. With libraries abundant, helping us thrive. Innovation blooms as we navigate this maze. Robot framework empowers in so many ways. Through testings, trials, boldly we tread. With robot framework, no challenge fills with dread. From APIs to UI.
And we're back. It's time to start the last session of the day. Joshua will tell us about Web3 testing and robot framework. Of course, remember to ask questions during the presentation via the QA form. So let's start with the video presentation.
Hello, this is Joshua Gorospe, and I will be giving a talk on Web3 cross-chain tools and testing using Robot Framework. So here's a little information about my background. I'm currently working as a staff test engineer at a startup called WebAI, and I've been a tester for approximately 18 years in agency and product companies. I've worked on cybersecurity, machine learning, ad tech, mobile app, e-commerce, and blockchain projects. I really enjoy researching blockchain technologies, experimenting with test tools, and learning more about rapid software testing methodology. I'm also a part-time writer. I use many types of tools in my work, but I like considering myself as simply a tester. Here's an overview of the sections we'll cover. There's two parts. I'd like to briefly introduce you to Ethereum and EVM compatible blockchains. This will be helpful if this is your first time with these subjects. And also I will then get into the strategies that we'll be covering today for the robot framework side of the Web3 tools and how they integrate together. And I will be showing very detailed graphs and workflows to describe how the tooling in Web3 can work with Robot Framework. So the key takeaway is the Robot Framework Solidity Testing Toolkit that I created, which was also featured on Automation Testing with Joe Colantonio. For your convenience, you can use this QR code to get the repo on your phone and follow along as I present this talk. Part 1 will feel like a bit of a rabbit hole if this is your first time with Web3. I need to go through a couple of basic things, but don't worry, it gets better. So Ethereum, EVM, and the cross-chain future. Ethereum set the standard, but cross-chain is the future of the technology, and Ethereum and Solidity specifically have vast and growing capabilities. Ethereum itself is often misunderstood as just a cryptocurrency. The co-founders of Ethereum originally sought to create a world computer, and Ethereum and its EVM are actually Turing complete. There's a growing importance of cross-chain communication, bridges, and any dApps that connect to multiple blockchains in the Web3 industry. Decentralized applications are what's often called dApps. The backend code is the smart contracts. They run on a decentralized network, and they don't have a centralized server. They use the Ethereum blockchain for data storage, and smart contracts are their app logic. Common cross-chain dApps are decentralized exchanges and also bridge aggregators. So, cross-chain use case usually involves sending various types of cryptocurrencies to other blockchains. And I will show you a quick example called ChainArc. So this is ChainArc, and the way it works is you can send various types of cryptocurrencies, and you can send it at the cheapest price, or you can send it the quickest possible, but that costs a little extra. And basically it supports these 8 different types of blockchains. So what is the Ethereum virtual machine? The EVM is a decentralized environment that executes code. It uses gas to measure the computational effort and ensures efficient resource allocation and secures the network. Basically, smart contract execution is one of the most important parts that we need to know about, and security and decentralization. It ensures cryptographically secure processes and enables transactions and functions to happen without any type of trusted intermediaries. This is a visual representation of the EVM. This comes straight out of the ethereum.org developer docs. Take note of the volatile state and also what's immutable and what's persistent. EVM compatibility is the ability of other blockchains to run the EVM and execute Ethereum smart contracts. This is what enables cross-chain development and deployment of dApps. There's several benefits of this: portability, reusability, expanded user reach. Examples of EVM-compatible blockchains that expand beyond Ethereum's capabilities are the top compatible ones, such as Tron, Binance Smart Chain, Arbitrum, Base, Polygon, Avalanche. So these TVLs you see, they're as of September 7th, 2024. Gives you a good idea of the activity of what's going on in each of those top blockchains. Each blockchain offers unique features, interoperability, and capabilities, which is too much to discuss here. The number of EVM-compatible blockchains is growing and expanding, and hundreds of EVMs exist. You could check that out on DeFi Llama if you want to go dive into it deeper. RPC node providers and JSON RPC API for Ethereum clients. So basically, RPC node providers are the infrastructure that allows applications to connect to the EVM blockchain. This allows Web3 wallet applications, an example is MetaMask, to connect to those blockchains. And many types of node providers exist. There's Alchemy, there's Infura, Moralis. For the examples later on in this talk, I'm going to be using mostly Alchemy and Infura and a few public RPC endpoints. JSON RPC API for Ethereum clients is an interface and API specification for Web3 developers. Ethereum clients use the methods from this specification to interact with EVM-compatible blockchains. It defines 61 API methods for standardized Ethereum client communication. Ethereum client tools, SDKs, and libraries that are common are basically you could use curl or WebSocket Cat. There are examples on how to use those common tools in the JSON API specification. And there's also several Web3 libraries and SDKs that exist. Some examples are ethers.js, the Go Ethereum client. In Rust, you'll find Foundry and EthersRS. These aren't the only ones you could use. There's a lot of them, and you can find them in any Solidity curated GitHub lists. This diagram shows that blockchains can be treated like any other backend system that you're used to testing. By now you've probably heard RPC mentioned a couple times, and you thought to yourself, wow, I think I've heard that before. Robot Framework uses a similar technology too. If you thought that, then you're correct. The remote interface uses XML RPC. In fact, several examples in part 2 use the Robot Framework remote interface. But don't worry, we're getting to that soon. In this slide, we'll go over examples of public RPC endpoints versus private RPC endpoints. In MetaMask, when you use the default RPC endpoint, you're actually using a public endpoint that's used by basically everybody out there. When you sign up for a free tier in Alchemy or in Infura, you're signing up for a private endpoint with your own API key, so you get to control who uses it. In this slide, I'd like to talk about being safe and protecting yourself while working in Web3 and blockchain. There's an article called Ethereum is a Dark Forest. It's based on a book with a similar name. It's basically talking about how to avoid detection and staying away from these very dangerous bad actors. The article talks about a real-life Ethereum mainnet horror story, and the lessons learned are try to protect your personal information, try to protect yourself from detection, avoid exposing any kind of personal information about yourself, especially your wallet address. Try to have dedicated test wallets, consider a high quality VPN, and always assume that you're exposed. In addition to the basic protection topics from the previous slide, cleanroom environment testing using Hardhat or Foundry is a safe option to use, and it's also repeatable. That allows you to use a local node with its own local RPC endpoint. It allows you to also run automated checks with no actual gas costs. Another option is read-only transactions through node providers and also using specialized Web3 SDKs. Some examples that trigger transaction fees are performing a transaction using the methods of a smart contract or sending cryptocurrency from your wallet address to another person. So now that you have this Web3 knowledge, it's hard to absorb. I know this from personal experience, and I hope you're still with me. And of course, knowing is half the battle. So here's a brief disclaimer. Just want to be transparent with all of you. These strategies were created to help me research and experiment with different types of Web3 tools. They were only meant for educational purposes and to encourage positive blockchain and Web3 awareness. And also, I did not intend to teach anyone how to use this for any kind of unethical purposes or to put yourself at risk. These strategies were based on public examples and public specifications. So please be good to your fellow man and protect yourself as well. And I recommend you review Part 1 later. In this slide, I'd like to go over a multi-chain Infura WebSocket bot strategy. The strategy demonstrates 3 API methods from the 61 existing Ethereum JSON RPC methods. One of them is ETH fee history, which monitors gas fee information. The other is ETH get block receipts, which monitors recently completed transactions. The other is ETH subscribe, which monitors pending transactions on a recently created block. This demonstration will connect to Ethereum and Avalanche to monitor transactions on those blockchains. And it will gather transactions and list blockchain explorer URLs for each transaction. The tools used with Robot Framework will be Docker, Infura RPC endpoints, and WebSockets through WebSocket Cat. Now I will demonstrate the multi-chain Infura WebSocket bot. You can use the link below to follow along, or you can scan the QR code from your phone to view it in landscape mode. So I'll give you a second to do that. Okay. Right now the Docker container is building. The Infura WebSocket bot is now running. And as you can see, connected to Ethereum and to Avalanche. Okay, it should be done. The Robot Framework Automation subscribed to Ethereum mainnet to read the most recent transactions and also to gather gas fee history here at the top. These are the recently completed transactions from before. These are the transaction hashes that were collected, and those hashes were converted into URLs, which we can use to go to Etherscan. So this was gathered by the Robot Framework Automation. Same was done to Avalanche as well. Let's take a look at the results now. So you can see from here, monitor gas fee information, we monitor recent blocks and completed transactions, also monitored for new pending transactions, also gathered the transactions and logged them as Blockchain Explorer links. In this slide, I'd like to discuss an Alchemy SDK bot strategy. This strategy demonstrates two examples from the 22 NFT API methods found in the Alchemy SDK. Get NFTs for owner, which gets the total amount of NFTs for an owner's address. Get NFT metadata, which gets the current metadata about a specific NFT. This demonstration will connect to Ethereum, but you could easily switch it to other blockchains supported by the Alchemy SDK. It uses the Robot Framework remote interface. The tools that are used are Docker, Alchemy SDK, and the Node remote server. So at this point, I'd like to demonstrate this code. And same as before, you could use the link, or you could scan the QR code. Okay. Now I'm going to run the automation for the Alchemy bot. Similar to the Infura bot, this uses a Docker container. This will run the Node robot remote server. And it's done. It's very fast. So the first task actually checks the NFTs owned by Vitalik Buterin. The second task gathers current metadata about a specific NFT collection. Gets down to details about the deployer address, the name of the actual NFT that we're looking at here, the specific NFT. This is the collection name, by the way. The token type, and also information like the Discord URL. Okay, let's check out the results. Here are the results of the Alchemy SDK bot automation. In this slide, I'd like to discuss a hard hat local Ethereum blockchain strategy. This strategy demonstrates 12 custom-made test keywords that run some of the methods of a Solidity smart contract. It connects to a local blockchain node that behaves like Ethereum, but without the risks of mainnet or testnet. It uses the Robot Framework remote interface, and it uses Hardhat and Ethers.js, and the Node Robot remote server created by Comic. Again, take this time to use the link below or scan the QR code as I demonstrate the Hardhat local Ethereum blockchain strategy. Running this particular example requires 2 terminals. I'm going to run the local node in the terminal on the left. Okay, the setup on the left has finished running. Now I'm going to run the actual tests. While the tests are running, keep an eye on the console log on the left. Now, it just finished this very quickly. Starting from the top. So basically what happened here on the left, while this local node is running, the test is checking on the smart contract that was deployed, which is a test token. Just checking on the symbol of the token, the decimals it supports, the total supply of the token, the address, of course its balance. Also here, we're performing actual transactions in test 7, 8, 9, all the way down to 12. You can see a gas report here generated by actual transactions shown here. When you generate a transaction, that's when gas is spent. That's a quick overview of this example. Remember, if you'd like to see the code, check out that QR code that I shared earlier. In this slide, I'd like to discuss a parallel running Foundry and Playwright test strategy. This strategy demonstrates 2 custom-made parallel running keywords that test a Web3 mock wallet connected to a local Foundry node. This demonstration will connect to a locally forked blockchain node that copies the Ethereum mainnet. Now, Foundry can very easily and quickly fork other EVM-compatible blockchains. You just provide it a valid RPC. The tools used are Foundry, Paybot, Playwright, and WogMe. So now I'll demonstrate. Just like before, use the link below to follow along, or you can scan the QR code and view from landscape mode. Okay, similar to before, I'm going to be starting the locally running node on the left, and then I'll run the tests on the right. Let's start this. At this point, you can see that the smart contracts are being compiled by Foundry. It's deployed to an address here. That address right there. That's the actual address of the contract we're going to interact with. This is another address here. There are actually 2 contracts that were deployed. This contract is dependent on that one being deployed. Now I'll run the tests, and you can see the interactions while a Playwright test is interacting with the wallet. At this stage, the Robot Framework browser library is being initialized. And now the tests are being run with Paybot. You can see here that some ETH was spent. You'll see in a minute from the console that the tests that ran the actual transactions have already completed. Now the Playwright test is basically checking that this particular wallet, mock wallet app, is showing that the ETH has been spent for those transactions. just very briefly walk you through this very long output from the Foundry automation here. This is the address it interacted with. It's the ERC20 token Solidity contract. We created a QA token. And then we sent some tokens to an address to generate some activity in the logs, and also to check that from the actual mock wallet, we are making sure that the Ethereum is being spent and showing up properly from the wallet. Let's take a look at the result file. You can see here that Paybot ran both tests at once, and it shows very good results. In this slide, I will discuss a parallel Solidity security test and vulnerability scanning strategy. This strategy demonstrates how to create your own Solidity auditing automation system. It will run parallel consensus Solidity tests and vulnerability scanning in Docker containers orchestrated by Paybot. This demonstration retrieves target Solidity contracts to audit from Blockchain Explorer websites Etherscan and PolygonScan. The lists of targeted contracts and Blockchain Explorer websites are handled by Robot Framework Data Driver. The tools used by Robot Framework in this strategy are Docker, Consensus Diligence Tools, which is a collection of various types of security tools targeted at Solidity smart contracts, Etherscan API, PolygonScan API, Paybot, and of course, Robot Framework Data Driver. Just like in the other demonstration slides, you can use the link below, or you can scan the QR code from a phone and view it in landscape mode. Now I'm going to run the automation. Right now the automation is downloading 4 smart contracts, 2 from Ethereum and 2 from Polygon. These smart contracts will be scanned and tested by the consensus diligence tools. The 2 diligence tools that we'll be using today are Mithril and Napalm. Mithril is a vulnerability scanning tool that checks EVM bytecode. Napalm is a static analysis tool. The vulnerability scanner passed. It didn't find anything in the EVM bytecode of the 4 contracts. 2 of the contracts passed the Napalm test. The other 2 failed on this issue related to wallet security, privileged functions. Let's take a look at the results. As you can see from the results, you can see here that the Napalm test is failing on this issue. And now we've come to the end, and hopefully this presentation has made you curious about Web3 tools and how they can work with Robot Framework. If a Solidity developer ever asks you, why Robot Framework? Isn't it just a Selenium project? Why not Mocha.js? You'll probably have interesting information to share with them. And thank you for attending this presentation, and big thank you to Adam Hepner for letting me attend and do this presentation. If you have any questions, I'll stay on to answer them. And if you enjoyed this content, I also teach workshops. And here's my contact information. And I hope to talk to some of you after this presentation's over. Have a good day, wherever you are.
So, and we are live with Joshua. Hi.
Hi. How are you doing, Chris?
Yeah, I'm fine, thanks. How are you?
I'm doing great. It's a beautiful day here in New York.
Yeah, New York is the time is just beginning. For
That's
me,
right.
it's almost evening. So wherever I hear blockchain or Web3, I think it's complicated. And
Yeah.
after this presentation, I think, yeah, it is. So if somebody would want to try to test, you mentioned that the security is very important, but assuming that somebody already has a strong VPN, is aware of the security risk and what to take care of, what would be the next step if somebody would like to try to test Web3?
I think that if you're going to dive in, you should really dedicate time to studying what a wallet is and how to use a wallet app like MetaMask. And after you've learned that, you should look into creating wallets just for specific tasks. So if you have an interest in investing in, like for example, DeFi protocols, make a separate wallet for that. If you have an interest in testing the protocols, if you have an interest in testing anything in Web3 space, I recommend just a dedicated testing only wallet. Just keep it and go the extra mile, keep it in a separate laptop just for testing on that type of stuff for Web3. And I think that you'll be safe for the most part. Just make sure that you don't check in any secrets into your repos, and follow normal security practices that you would follow at the companies you work for. But always remember that there's always something else out there. Stay informed. I recommend Hackin.io. They have some resources that help and white papers and case studies of different types of vulnerabilities that are out there. Yeah, that's just an example of an auditing company in the Web3 space.
Okay. At the end of your presentation, you said about why robot framework and not Mocha.js, and I'm curious, why did you choose robot framework for testing?
Yeah, that's a great question. And yeah, it basically when I was self-training myself in how to deal with Web3 technologies and how to just deploy a smart contract on my own, either on testnets and on my locally running nodes. Basically, I got introduced to their test tools, and the majority are using JavaScript tools, by the way. One of the most popular software development frameworks in the Web3 space is Hardhat. So if you look up hardhat.org, they have an entire development framework, and that includes locally running nodes, runner, test framework, and they use under the hood Mocha and Mocha.js, and of course the Chai assertions library. And yeah, so that's kind of like what I was self-teaching myself with, and I was observing what they're doing with it. The community, Patrick Collins is one of the teachers that I followed, and I immediately noticed that there's things that I very easily love to do and lean towards doing when I have my robot framework work in front of me, and I look at that and I look at the Mocha.js stuff. It's like, well, I could easily do this in less than a day in robot framework if I wanted to do chaos testing, if I wanted to do model-based testing, if I wanted to do various types of fuzz testing strategies. It feels easier in robot framework because I've been doing it for like 10 years. But also you have this whole ecosystem of hundreds of libraries and people, like-minded people in the robot framework space that have done this for years. And it's kind of hard to find some of this stuff in the Web3 space because it's there's not many QA engineers like the folks on this in this conference in that space, to be honest.
Okay. And you mentioned the Robot Framework Solidity testing toolkit you created. What were some of the biggest challenges you faced while developing this toolkit, and how did you overcome them?
Great question. Yeah, one of the biggest concerns I had was, yeah, I was thinking to myself, do I have to spend a lot of money to do this testing? I have to build up little stacks of Ethereum that are, at the time when I first started building this 3 years ago, I think they were around 2,000 to 3,000 for just one Ethereum. I initially thought that, and I was looking around, and I noticed that it's a lot easier starting like 3 years ago already. The hard hat ecosystem, and also back then, it's not anymore, Consensus, which was founded by one of the co-founders of Ethereum, built the Truffle suite. And basically what they were doing is both communities is allowing people to be more hands-on, bringing the tools to be more accessible through locally running blockchain nodes. So that's kind of like what inspired me to work with the Node remote server, which is a remote server that Comic created. That's the person's handle. I'm not aware of their real name. So that remote library then inspired me to create my own little bespoke robot framework libraries for Web3. So that's kind of like my little research stack that I built in the Solidity testing kit that I made, and also some small little monitoring bots as well. I have a mental roadmap of how I want to where I want to take it next, and it's all very research oriented at the moment and exploration.
Okay, so thanks, Joshua, again for the talk and for the session. Yeah, we have time is up from the Q&A, so thank you once again. And
it's an honor.
Yeah, you probably will stick around in the Work Adventure to.
Yes.
So if anyone wants to talk about Web3 testing, they can approach you and just ask away.
Yes,
Yeah.
and thank you for everything, as you've run a wonderful conference, and thank you for your time, everyone.
Thank you. Bye.
Bye.
So that was the last session for today. So regarding the Work Adventure, the platform is available for the rest of the day for all of you. So I think now, after this great session and the great talks, you can discuss them there in the space. There are tables, there are benches on which you can sit on, and when you do that, the teleconference room will open, so you can discuss the topics that you heard about today, or just meet other people, like-minded people that are robot framework enthusiasts. So I think it's time for our closing statement. And yeah, that's it. That's the end of the third edition of Wrobocon. And yeah, what an incredible day it has been.
Yes, we've covered so much ground today, from cutting-edge AI implementations to testing and innovative approaches in open source collaboration. And the quality of the presentations was great. The number of people from our community joining in Work Adventure has been truly outstanding.
Yeah, and we would like to extend our heartfelt thanks to all of our amazing speakers who shared their knowledge and experience with us today. So David Fogl with the insights into Robot Framework AI library, Kailash Pathak showing us the future of Playwright Test automation, Marcel Veselka demonstrating the power of automation with Robot Framework, Dave Ames and Arkadiusz Kuczyński presenting the innovative RFSwarm project, our keynote speaker, Tariq King, challenging our perspective on AI in testing, Artur Ziółkowski sharing his experience on scalable test automation frameworks, Dirk Schweier showing us new approaches to test case generation, and Joshua taking us into the world of Web3 testing.
Yes, and a special thanks goes to our sponsors and, of course, the Robot Framework Foundation for their continued support. And, of course, to all you all joining in for this conference as attendee from all around the world. And, well, it is you together that make this community so vibrant and engaging.
And remember, all the presentations have been recorded and will be available to you in next few days. You will receive the details per email.
And we encourage you to stay connected with the Robot Framework community. You can join us, as you can see down here, on the Robot Framework Slack. Through the website, you can just join in on the Slack. There's a link there. And that is where you can have a lot of good conversations, all Robot Framework related, all year round.
Mm-hmm. And your feedback is incredibly valuable to us. So please take a moment to fill out the conference survey that will be also shared with you shortly. And your input will help us make the next year's Wrobocon even better. Yeah, and like I said,
speaking.
Sorry, like I said, when you fill out the form, you will receive one of the songs that were played in the break during the breaks. And yeah, now you, Guido.
Yes, and speaking of that next year, make sure that you have your calendars ready, because soon the dates for Wrobocon 2025 will already be announced. So follow us on social media and join the mailing list, and you'll stay up to date.
And before we say goodbye, we'd like to also thank the amazing organization team who worked tirelessly behind the scenes to make the event possible. Dziękujemy.
And it's been a pleasure hosting you all today. The energy, enthusiasm, the knowledge shared, we think it's a really showcase of the strength of the global testing community, and especially the Robot Framework community. Stick around in Work Adventure. We'll be walking around and have some good talks, good chats about everything Robot Framework, and maybe even a little bit outside of that. Thank you so much.
Do zobaczenia. Until we meet again, keep testing, keep learning, and keep pushing the boundaries of what is possible with Robot Framework.
Goodbye, everyone, and see you around in Work Adventure.
Lines of code, we're writing a lake and debugging till our brains feel fried. But there's a tool that's pretty great, and a robot framework by our side. Automation's our salvation. Keywords make it all so clear. We're testing like robots tonight. Robot framework makes it alright. So lay up SEO and more. Who knew QA could be such a score? Python power, easy to read, and test cases flow like melodies. From web to mobile, it succeeds, and cross-platform compatibilities. Automation's our salvation, and debugging till our brains feel. What doesn't make run robots gain? Robot framework makes it alright. We're testing like robots tonight. Robot framework easy to read, and test cases full of melodies. From web to mobile, it succeeds. OS platform compatibilities. We're tested like robots tonight. Oh, my framework makes it alright. Selenium, Neon, and more. Who knew QA could be such a score? Would be such a score. Reporting's clean, results are green. Our code's the tightest that you've seen. No bug escapes, our robots gaze. QA has never been this crazed. We're testing like robots all night long. Robot framework makes it alright. Song. Reporting's clean, results are green. Our code's the tightest that you've seen. No bug escapes, our robots gaze. QA has never been this crazed. We're testing like robots all night long. Robot framework, you're our song.